Nah?
Ini memang sudah di record. Adalah. Cek. Enggak, lihat di YouTube di aksesnya yang cuma bisa punya link aja. Kenapa Zoom satunya ada 2? Oh, aku. Sorry. Ah. Apa? Iya. Apa? Iya. Sudah tak? Oh. Oh, gosh. Cek. Oh iya, sudah.
Cek 1. Bisa aman. Cek 1. Kita toler sebentar ya, nanti kalau performanya siapa aja ya.
Ya. Bapak keluar. Kalau nanti saya beli. Oh, ada one. Darso gak pulang 5 tahun, pulang-pulang bawa pacar Jepang yuk, kalah kan yuk. Biasanya gak tonton musim pinjam duit kayak ngono. Cek. Halo. Hello, Mr. Thomas.
Record. Halo, how's life?
Sidoarjo. Kegangan. Cek. Gedangan. Mana suaranya? Apanya yang nggak ada? Apa? Apa yang nggak ada? YouTube. Hello. Hah? Mati, bro. Seperti mati lampu. Ya audiomu gak sih? Cek. Tahu aku tuh. Jawab komen.
Hello.
Halo, Profesor Thomas.
Oh, hello, everybody. Okay. I see that now we can connect, but give me a few minutes just to prepare everything. Okay.
Okay.
I'm not sure if we can start now, or are we going to wait for other participants or not?
Please wait, Mr. Surya.
Okay.
Sudah, Mas.
Yeah, good morning, Thomas. How are you?
Good morning. Good morning. How are you? How are you? I'm fine. Thank you.
Fine, thank you too. Yeah, how about the connection? You said before we have some problems.
Yes, some problems because when I started now in Poland, I saw the very small window with the choice of the country to which the audio is connected, and the Indonesia was not in the list, only Poland, US, United States, and something like this. So I suppose that there were some problems. I don't know where in my university or in just in the servers, something something like this sometimes happen. I created new connection, but it also didn't work as you saw. So
Yeah.
it's good that we managed to connect now. So we can just make short lesson. I think with Hackras it could be good. But I also sent one email with some suggestions, because in such cases it happens we may just connect through WhatsApp, for example. This is a really fast connection. I have connection with different parts of the world, and it works in the real time, just in a second. So you have a message that something is wrong. So we may think about it. Or yeah, I think
WhatsApp
I think
we
it is.
also have here. We can make a one groups here to fast connection, also discussion in
Yes, this
WhatsApp
is good
groups. Yeah.
idea. This is good idea. This is a good idea to make a group. So maybe after the meeting we'll just think about it and create something like this. Okay.
Yeah. Okay.
Okay, so now what I want to okay, I don't want to see this, but okay, can we start? Yeah.
Yeah, I think we start.
Okay.
Yeah.
Okay.
All my screen
So
ready. Yeah.
yeah, I will share the screen. So nice to meet you, all of you. I see that we have quite a serious number of participants. So I'm happy with this. I also sent the short email to Giovanna. In Italy, but I don't see her now in the list of the participants. So maybe supposedly she may not have time for this. So I will share just to start, share the screen. I hope that you see my screen. Yeah.
Yeah. Okay.
Okay.
Really clear.
Okay. So I would like to start with this, because I sent some links, some email with the links to the stuff, to the content, which may help us just in this classes. So I prepared in the Google Drive folder with data, with models. I put also there the description of the courses which I was given in the past as a workshop before the conference, and as an Erasmus teacher. But these files were sent to you, Surya, and you have them. But quite important file is this file, this link docx file, where I put some links which can be useful for us. And you see that the data links to the data, links to the models, and this data and these models are exactly in the Google Drive. I hope you have the access to this drive. Everything is okay with this drive? You can open in your okay. That's good.
You can open it. Okay.
Okay, so we have also in this file the links to the data into the models, final models created in the separate exercises. But there are also some other resources, some channels in the YouTube which maybe help us, some web pages, and I would like to discuss these web pages also shortly and present this content. Some of them during the beginning of our classes. Others maybe during other parts, just making step by step, we may refer to some elements. So this can be really useful for us. So please look at this. So I will start with this resources also, because there are some very basic fundamental resources which can help us, and one of them is this channel. This channel, which is called Hackras na UPP. UPP is the Polish abbreviation of PULS. So this is the Poznań University of Life Sciences. Na in our language means in, exactly mean. So this is Hackras in PULS generally. And this channel was prepared for my students, English-speaking students, in the courses of the geoinformation and environmental engineering and protection. So we have such two courses, English language courses at our university, and I teach Hackras, not only Hackras but also geoprocessing and other stuff. Generally, in these channels, you can find the videos, which are the recordings of the exercises after the classes. So after the classes, I prepare such short videos. In the most of them is without voice, so only some procedure of model preparation is presented here, and I would like to use some of them, especially today. I hope that we managed to make the first run, which is the introduction to Hackras. Maybe we will be able to make next steps, or even a little bit more advanced setting of the inline structure. So if we make exercises, because it's good to make such a workshop, such a course with the exercises, basically, when the students follow the teacher and the teacher explains the features and the elements of the software, just in real time, just preparing the exercise. After this time, you may look at the channel, and this content may help you to repeat the whole procedure without my explanations, but you're only looking at the steps which are done. So as I know, it helps a lot students of my my students at PULS, but I also have some information that students from the other courses from other universities also use this channel. So supposedly these procedures are clear enough for self learning for the students. So it might be good if you just look at this. The link to this channel is in the link docx, so you may find it, and you may just look at these videos. This is not the only channel of this tape, because I have also two other channels. Another channel you may notice is useful is geoprocessing in PULS. So this is for the geoprocessing classes. Okay, not this one. This is okay. This is for geoprocessing classes with some exercises on geoprocessing. Maybe we'll just refer also for them. And another channel, really new channel, is a channel with short exercises on Hack HMS. Hack HMS. So this is a really new idea. Maybe later you will find there more videos. At this moment there are only 2 videos with short introduction to HMS. But HMS is not the content, the basic content of our classes. So we will focus on Hackras. Yeah. So this channel is quite large, and you can find a lot of stuff. Okay.
Okay.
Okay. So this is the first element. Second element, I would like to notice. I will just use this link, the first link in here in Hack, in the section Hack. Let's use it. Let's use it. And this is of course the web page you supposedly know. The web page of so-called Hydrologic Engineering Center. Yeah, you know this web page.
Yes, buka dulu semuanya.
Yes. Okay. So yeah. This is web page of the Hydrologic Engineering Center.
Wait a second, Thomas.
Okay.
Second, please. Let my student prepare it.
Okay.
Open, buka dulu semuanya. Sudah?
Okay.
Yeah. Okay.
Okay. So this is the main web page of Hydrologic Engineering Center, which is the part the part of U.S. Army Corps of Engineers. So this is quite known institution. In this web page we have a section software, And in the section software, supposedly you found HECRAS. Basically, this is the default page of HECRAS. Yeah, so this should be known. You should also know that we have a downloads here, and we can download an installation file and also some example projects. This is also quite useful. And we have a section documentation, and this is something what I would like to draw your attention, because it might be more important. I'm sure that you are able to find the installation file, but documentation is also very, very important for us. Since the version 6.566 generally of HECRAS, the documentation is in the format of the online documents, HTML documents. So here we have a support for our learning, for teaching explanation of the features, especially this page, which is called manual user manual here. This is quite large document. When it was a PDF in the previous versions of HECRAS, it was about 700 pages. So supposedly now it's bigger. So we have a lot of features in HECRAS, but we may also refer, and this is really important, to this document, HECRAS Hydraulic Reference Manual, because all the theory which is implemented in HECRAS is described in this document. Especially fundamental is this chapter, theoretical basis for one-dimensional and two-dimensional hydrodynamic calculations. So all the equations, numerical methods, and this kind of stuff is described here. Yeah, is described here. If you look, you see just step by step the explanation of what is really implemented in HECRAS and what is the meaning of the computations we are doing in HECRAS. Yeah. So this is also important just for self-study. Maybe from time to time we will look at these documents if this is necessary, just to explain more advanced elements. Yeah? So this is what I want to also notice at the beginning. And I would like to also look here once again, because in the section software, it's really good to mention at the beginning. In the section software, we have a lot of software which is developed by Hydrologic Engineering Center, not only HECRAS, but we have also other software which is also very useful in our area, in our field of science. So it's good to mention this in the beginning. HECRAS is one of the fundaments, one of the bases of this institution, but another pillar, let's say, is HEC-HMS. HECRAS is for river flow computations, river flow, river transport processes, and floodplain flow also. HEC-HMS is for hydrology, for hydrologic routing, especially focused on the watersheds. So these two are the basis. Other software which is available here is more or less based on this software, using the results or preparing the data. Yeah, so these are the connections. These two, HEC-RAS and HEC-HMS, are the most important, I think, in this list. Of course, if you have a time, you may look at this page and look carefully what is there. But if you have also some problems, you may look at this section, publications, where you can find a large number of reports, papers, and tutorials, which can be also useful in learning or searching for useful information. Yeah. So this section is also very good, and of course training. There are some also course lists, not only paid, not only commercial. You can also find some stuff which is free of charge. So you may just look at you may just take some content. We may try any of them. You may okay, this is agenda. This is for money. But okay, we have webinars and tutorials, and this content supposedly may be just taken from the web page and might be freely used. Yeah. So this is quite good to know about these pages, because they may help a lot in your self-study. We have also other content. You see that the links to the materials, to the training, to the webinars. We have also other channels in the YouTube, but I will mention them later. So at the beginning, we'll just stay with this. It's enough. Yeah. Do you have any questions about this introductory information?
I think it's good enough explanation. We are very clear about your explanation.
Okay.
Yeah.
Okay. So let's have a look at the channel Hackras and PULS. Here you find one video. This video 01 Intro to Hackras is the only video with audio, but the audio is in Polish, but there are subtitles in English. So this is introduction a little bit longer to Hackras. So I just show you now the short version. So if you want to look at the introduction, if you are this is good just to watch this video. This is about 20 minutes video. Generally the videos presented here are not long, so it should be quite good to use them for your own. Yeah. So this is the introduction, the introduction to Hackras. Okay, so this is what I wanted to tell you at the beginning. Okay.
Yeah.
So now let's have a look at. Let's start generally, but before we start with Hackras, we need to prepare some elements. So anytime we start such exercises, anytime I start such exercises with my students, generally I advise to prepare separate space in the disk to work with Hackras. So of course it's obvious, but there are some rules we need to follow when we prepare such a space. Because Hackras is a software developed in the United States, it might be sensitive to any national letters. So in Polish, it's especially important because we have a lot of such letters with additional signs, tilde and this kind. So if Indonesian such letters does not exist, so you don't have a problem. Yeah. So
Yeah.
it's easy. So we avoid this kind of letters. We base on the very simple Latin alphabet when we create such a folders. There is another very important element we need to remember. We should avoid the spaces in the full path, in the full access to the folder. So please do not use the desktop for creation of such a folder. Suppose the desktop is put somewhere in the user folder with the name of the user, and in the name of the user there might be spaces accepted by Windows but not accepted in some parts of the Hackras. So we should avoid this. And generally just check what is your folder. You can just open this in the Windows Explorer and check here what is the full path to your location. Yeah? If you need some breaks in the names, just use the down line. I don't remember the proper word in English. This connector between you should generally know. You should generally know. So as you see, this is generally my link. I use separate partition and I create a new folder for our exercises here in this location. Yeah. So prepare such a space. I just put here a new folder, exercises, and we can just create exercise for today. It might be test or exercise 01. Yeah. So this is folder for today. Yeah. So the full path is without spaces, without national letters, without any special signs, and this kind of elements which may cause problems when the Hackras communicates with the data. Yeah? Okay.
Yeah.
Okay.
Okay.
So just keep this in mind. Just prepare this folder and keep in mind the location of this folder. Now, the second, also very important thing, but I see that we have a message from Giovanna. Okay, Giovanna is not connecting with us because she has other obligations. Okay, now
Yeah.
also very important is the setting of the regional parameters or regional settings, general regional settings. In Windows, you can find this issue here in the control panel, right? Control panel in English, of course, in the local languages, it should be the translation, but panel supposedly is the same in all the languages. In the control panel, we have such a section, which in English is called clock and region. Clock and region, please look there. In clock and region, we have a region. So this is important to go here. And here in the format section, supposedly there are some default settings for the country. We should, when we start working with HECRAS, we should avoid this and we should change it to English United States. The problem is not only the format of the number, because in the United States, the dot is used. In many European countries, the dot is used to separate the integer part of the number with the rest. In many European countries, the comma is used instead. So I don't know what is the accepted format in Indonesia, but generally it's better to change the format to English United States, because also in HECRAS, we may have a problem with the format of the date. Yeah, with the format of the date later, when we try to set some unsteady flow simulations, we need a date, and only the dates in the United States format are accepted in HECRAS. Okay, so it's good to change format to English United States. This change is not changing the keyboard. Keyboard still the same. So if you are accustomed to your keyboard, to your distribution of the keys in the computer, you still have the same. Yeah, only the format of the date, the format of the number, this kind of settings are changed. If you have a problem that you would like to switch between your format, national format, and the United States, it's good to make a copy of this icon in your desktop. I have such an icon. You just may drag and drop to your desktop from here, you know, and you have still the access, very quick access to the regional settings. And after working with HECRAS, you may change, you may come back to your settings, which are just useful for you, Indonesian settings, and it should help to work effectively and change effectively the formats. Okay.
Yeah.
Okay.
Okay.
So please change the format to English United States to be sure that everything in HECRAS will just cooperate with us. Yeah.
Yeah.
Okay. Underscore. Thank you very much. This is the name I needed. Underscore is of course really useful when we set the workspace in HECRAS. Okay. So now we are ready to launch HECRAS. If everything is ready, if we have a workspace, if the format is set, we may use the icon of HECRAS. This is the newest version of HECRAS. So the icon should be in the desktop. If this is not in the desktop after the installation, you should be able to find it in the list of the applications in section HEC. We should have the HECRAS here. You know? You may copy to the desktop, and it's good to keep the icon in the desktop. Okay.
Udah install semua? Okay, all of my students ready and already installed it.
Okay, so
Yeah, we can continue.
let's open. Okay, do you have installed HECRAS or not? Not yet.
Yes, my student
Okay.
are already, yes, already
Okay.
installed it. Yeah.
Okay. If you have the HECRAS installed, if you double click on HECRAS and the regional settings are correct, you should see this window. This is the first run of HECRAS. Yeah? So
Regional
of course in this.
benar semua? Okay, excuse me. Wait a moment, Thomas. I should ask to my student. Have you already changed the? Yes. Okay. They already changed to the format date to the English United States. Okay, it's done.
Okay. Okay.
Yeah.
So now we can just start HECRAS. So this is the first use of HECRAS after installation. So of course we need to agree the license and click next in this case, and we should see such a window, such a small window. Okay.
Yeah.
Everybody.
Yeah.
Okay. Now, if Hecras runs, the older versions of Hecras were running in a little bit different manner, because in this process there was also a question about the installation of example projects. Now the new version is not asking about it, but if you would like to have example projects which are described also in help, you may use from help this option here, download example projects. So if you need this step, but of course this step may be just done later. So for a moment we don't need to care about it. Okay.
Yeah.
Okay. Now you see also here in help. Oh, okay. Let's start description with this window. Maybe the window is small, as you see, and may not be impressive, but generally this window is the access to other programs, because Hecras is composed of different programs. So the window generally gives us the access to this program, to the software. So the window let us to connect data with simulation software, with results which are produced after the simulation. Yeah. So why this is relatively small and not occupy large space. We have here the menu, and I will focus on the menu at the beginning before we start working. We have a toolbar. I'm not going to talk much about it, because toolbar is the repetition of the options which are in the menu. So in the beginning we will use menu. Later you may realize what are the options in the toolbar and may use more effectively, faster the toolbar. And here is the space where we will see generate the description of the main active elements of the project. In Hecras, we work in projects, and project is generally the connection of the different files or the storage of the different files. We may generally just classify them as a data files, as a simulation programs, and results. Yeah, results stored in the separate files. So these are the main elements of the project. And here we will see when we create a project, we will see the description of these elements which are active at the moment. Not all elements, because project may store more elements. So if you don't see something what you created before in this list, please do not panic. Supposedly it still exists in the project, but needs to be activated. Yeah. So remember this, that activation is something what happens in Hecras, deactivation, activation. So we'll talk about it. Yeah. And below this list, we have also a space for description. It's not obligatory. You may just use this space for your own. If you need some additional notes, you may just write here, and these notes will be saved with the project. Yeah, with the project. When you open project next time, you should see this notes. And on the right, we have one information about the unit system in the current project, or the default unit system if we started Hecras. As you see, this is US customary units. I'm not very happy with these units. In the most continental European countries, we use SI units, System International. Yeah. So supposedly in Indonesia, this is also standard, or no, yes?
Yeah. Yes.
Okay. So at the beginning, in the first step, we need to change the unit system. So how we do it? We need to go to options here.
Yeah, options.
Yeah.
Yeah.
In the options, the third option is unit system. Yeah. And in the unit system, you see that we have the choice between two unit systems. The second is System International. So this is the metric system. And we would like to have it like the default unit system. So any new project should open with this unit system. So check this box. Yeah, check this box. If you don't see correctly, I just magnify. Yeah, do you see this window?
Yeah.
Okay, and press. Please press OK. Now we need to confirm that we change the unit system, and you should see here in this right down corner that we have SI units. Yeah. Okay. So this is really important to just to stay for a moment with this, because after the reinstallation of HECRAS or installation of the new version of HECRAS, the default unit system always is US customary units, because in the United States they like their own unit system, and generally they want to work with their own unit system. So we need to remember, in the countries when the SI units are used, we need to remember about this change. This is the most common error made by beginners, that they are not looking here. Yeah. So supposedly this will be also your first error you make, that you are just forget to check the unit system. Please remember, do not change unit system when the project is open. Yeah. So if you work with project, you have some data, do not use this option, because this option recalculates all the numbers you have in the project into new unit system. Okay. So later I will show you how to do it without destroying your project. Okay. So remember that it needs special steps. So also do not panic. It is possible to correct it, and it's not a problem if you miss unit system. Okay.
Okay. It's clear.
Okay. Unit system is ready. Okay. Okay, at this moment, okay, let's make short introduction of the menu. This menu you saw, so you know that we have the access to the manuals. The web pages are open if you use any of these options. Here in the file, we have standard options of the Windows program: new project, open project, save as, and this I am not going to explain. This is clear. Below, when we start working with a HECRAS, below we will have also the list of the last projects which were just prepared in this account in this HECRAS. So sometimes it's just easier not to use open project, but you use this list. There is also another method to open the project, existing project, but I will show you it later when we have a project. Okay. So this is clear. This menu supposedly is the most educational menu, edit. Because when we open edit, we expect something like in the Word or Excel that you have the copy, cut, paste, and this kind of stuff. It's not in HECRAS. We have something completely different in HECRAS. This menu, edit, is a menu for preparation of the data. So we have a links to another programs which let us to prepare different kinds of data. Yeah? So edit is for preparation of the data. And this menu also show us how to make step-by-step in HECRAS, because we should start with the first group, and the first group we have only one option: geometric data. So we should start with preparation of the geometric data of our river system. Yeah? Now, later, when the geometric data are prepared, we should use any of these options. These are the second group, is the option with the flow data for the simulation of the flow of the clean water, you know, for the simulation of the clean water. And if we make any simulation here, not any, but the proper simulation, we may go to the third group, where more advanced processes like sediment transport, right, like water quality, also temperature modeling, this is possible with these options. But these options works only if the flow is calculated or prepared before. Yeah. So we should not use these options before preparation of the geometric data. We should not use these options, transport processes, before we calculate flow. Yeah. Okay. Okay. So we start with the geometric data, but the most basic thing we can do in HECRAS is simulation of the steady flow or simulation of unsteady flow. Steady flow is a basic calculation of the stationary conditions without changes in time. So in the most cases, it's focused in calculation of the water surface profile along the river. Yeah? So this is what we can do with this. If we have a water surface profile, we may also calculate the inundation area. We may calculate the velocities and this kind of elements. Unsteady flow data, opposite here, is the software which let us to simulate the varying in time situation. So like in a flood, during the propagation of the flood wave. So it's a little bit more complex, and we have the situation which vary in time with some inundation and just coming back, water coming back to the river from the floodplains and this kind of phenomena. And we will try to make this at the beginning. I will mention only now also that we have a run menu where we start computations. We have the menu view where we can just look at the base results as in the format of the graphs and tables. We'll look at them when we have the results. We have options, so you see, you know that this is the menu for setting some changing of the settings in the HECRAS. And one setting was changed, this unit system. The rest we will just leave as they are at the beginning. And we have a relatively new module, GIS tools. This is GIS modules added to HECRAS, which let us to work with GIS data in HECRAS, directly in HECRAS, even without any support of other GIS software. It still needs some support, in fact, but it's really advanced, and supposedly in the future this module will be the only thing we really need to incorporate the GIS data in our hydraulic models. So this is the GIS part of HECRAS. And help, I told you about her before. Okay, is it clear?
Yeah, it's clear enough. Yeah.
Okay, now let's start. Okay, let's start. So HECRAS is open. Let's go to File and New Project.
Yeah.
New Project. Let's use New Project. And when you open New Project, you should see such a window. So first of all, just choose here the proper partition. Where is your folder of your workspace?
Yeah,
so mine is in E. So and then find here your folder, for the current exercise. So I basically go here to the exercises. Exercise 1 should be open, and I'm ready to create project.
Yeah. Specify foldernya semua dulu, di folder masing-masing. Udah semua? Yeah. Okay, it's done.
Okay. Now here we write a title of our project.
Right,
so might be the project 01, for example.
Project 01, yeah.
You may just choose your own name, So yeah. I just give the examples. If you would like to use another name, you can use. Here you should also see file name. File name, as you see, is the repetition of the title or short version of the title with the extension PRG. You may change the file name, this part, but PRG should stay. PRG is a project, so this extension should stay.
Okay.
And if you are ready, we may press OK. And we have the small window just to confirm the information that the project is stored in this file. This is the name of the project. This is the location, and this is the unit system. And we press OK. Project is created, or the base version of the project. Okay.
Yeah.
Ready?
Yeah.
Okay. Now, in the folder, in the Windows Explorer, you should see the first file, project 01 PRG. And yeah, do you see?
Yeah.
One important thing is also, the question is if you see the extension, because sometimes by default in the Windows, some extensions are hidden. If you have a problem with this, that some extensions are hidden, and I would prefer to see the extensions, because it tell us what is the file we work with. So we should change the proper option in Windows. So if this is your Windows Explorer, you supposedly here have the 3 dots. 3 dots. In the 3 dots, let's go to the options, and you should see this window. I'm working with Windows 11. if you have Windows 10, this menu looks different, but there should be the option view, and in the view there should be the options. Yeah. So you should be able to open the same window in Windows 10 also. Yeah. Here we should go here to the second tab, view, and in the second tab find this okay, this option, hide extensions for known file types. Yeah, do you see? Hide extensions for known file types. I will magnify. So this is the hide extensions. Let's uncheck this option. Yeah, let's uncheck this option. This is something what generally engineers should not use, because it may cause a lot of problems. So it's better to see extensions. Yeah, and of course let's press OK. Okay, now all the extensions should be visible, even if the file is recognized by Windows, the extension should still be displayed. Okay?
Okay. Kalau
now,
ada tangan, ya, oke semua.
Okay.
Okay, we can continue.
Can we continue? Okay.
Yeah.
Now, this file is a text file. We can open this in the Notepad. So let's do it. Okay, let's have a look what is inside. So just use here maybe Notepad. This is the application we need.
Notepad.
Yeah, the default application in Windows. This is open, as you see. And we may simply drag and drop this file to the Notepad, and we should see what is inside. Yeah, I will change the font to make it greater, just to show you what we have, maybe even greater. Okay, this will be okay. Okay, so this is the content of the project file at the beginning of our work. When we work later, the new elements will be added to this file, but it's good to know that such file generally exists, and we can look at this file. First of all, in the first line, you see your title, the title given to the project. Yeah? And in the third row, you see the unit system, So now let's come back to the problem that we make an error with the unit system and start working with some project. What is the procedure to repair this? You should close your project and close HECRAS, basically. Yeah? You should find your PRG file, so the file of your project, and open it in Notepad. Here in the third row, as I remember, you should have the US customary, yeah? Instead of SI units. You should just change it manually, just writing in your keyboard into SI units, and save the file with the base save option, and then open project file once again in HECRAS. Yeah? So this is the way we just correct the problem of the unit system. Okay.
Yeah.
Okay. So when you open project file in such a way in HECRAS, HECRAS generally recognize all the numbers as the numbers in the proper unit system. Yeah. Okay.
Okay. Yeah.
Okay. Any questions?
Very clear enough.
Okay. Okay.
No problem.
Let's go.
Yeah.
Okay. Let's go to the next step. Next step is basically edit and geometric data. Yeah. Edit geometric data. So we start with this option when the project is created. The first step is create the geometric data. Yeah. Let's use this option, edit geometric data, and you should see such a window. This is separate program which creates separate files. How we recognize this? In file, we have separate option save. Yeah? So when you want to save geometric data, you need to use this option. When you want to save project, you save project here. Yeah? So this is the difference. Yeah? Okay, we will work for a moment with this window. So I will just make it larger, and what we have here. Of course, we have a menu menu, and we will use the elements from this menu just step by step. I will explain what they are. But we have also some toolbars in the top and toolbars on the left. Yeah. Yeah. Okay. Should I repeat something?
No, you can continue.
Oh, okay. Okay. Generally, some of them are used to create new elements. Some of them are used to set the parameters of the existing elements. So we will just look at them. And this space here, large space, is for displaying of our system or for drawing our system, because we can also manually draw the elements of our system here. And at the beginning, we'll just use this option. Okay.
Yeah.
So we are not going to use at this moment GIS data. So we prepare very artificial channel rich of some channel which we can imagine, just to make the very simple computations and focus on the base elements of the HECRAS. In the second meeting, I think the second meeting, we'll just use the GIS data, and then you see also the same elements, but in combination with GIS. So it makes it a little bit more complex. Yeah. So this is the idea for the exercise, for the first exercise today. Any questions? No, it's clear.
Yeah,
okay, yeah?
No, because actually our last previous discuss with my student, we are still have a challenge or problem dealing with to give the measure data into the HECRAS, but it's okay. It's for the next meeting. You said before.
Yeah, I think we first focus on the very pure project without GIS. GIS causes all another problems. So I need to give you more information, just not to mix too much. It will be better just to make separate meeting. As you see here, I exactly did the same during the workshop. The first block is for working without GIS. The second is with GIS. What led to understand what is the difference. Yeah, what is the difference in between working without and with GIS. Yeah.
Yeah. Okay. Thank you very much.
Okay. Okay. Now we have to start with the channel network. With the channel network, I'm going to make the simulation with the single reach. So we need to have this single reach in this view. To draw manually a river reach, we use this tool. This is the first icon in the top toolbar. River reach here. Okay, just press it, please. And when you go to this zone, you see that your cursor now is a pen. Just for drawing. We draw the channel reach just by clicking, like in any CAD or drawing software. We finish single reach by double clicking. By double clicking. So let's draw any channel reach. It does not need to be straight. You may just make several breaks. I will explain why it's not important just in a moment, but just draw something. Okay?
Okay, coba tulis gambar.
Ready? Double clicking finishes, and then after the finish,
dua kali.
After the finish, you should see this small window here.
Yeah, ready?
Okay. Now, first of all, when we are not working with GIS, it does not matter what is our drawing, because the manual drawing, is not used for computations, but only to put the elements of the river system in the proper order. So the connections are important, not the distances. In this case, the distances are defined in another place of the project. So we will just define the numbers and the distances correctly just in another step. So we have the first reach, and the location of the elements in the river channel, in the river network, is just recognized by two names. Each reach has the name of the river and own name of the reach, because the river might be split in several reaches. So first of all, it should be the name of the river. Let's say river 01, for example. I prefer to use the simple names at the first introductory exercises. And we should just give some name for our reach 01, for example, okay? Of course, if we model the real river, it's good to use the real names, no? just to recognize it. But now this is artificial, totally artificial river, so we may use the river 01, reach 01. No? Ready?
Yeah.
Okay. Let's press OK, and you should see this that we have the direction of the flow. So the direction of our drawing is the direction of the flow, recognized as the direction of our flow. When we work with the GIS data, it will be really important what is the direction of the lines we use in GIS data, because direction of the lines is treated exactly in the same way as the direction of the flow. Yeah? So remember this, that it matters how you draw the lines in GIS software when you later put into HECRAS. Yeah? So in any case, we will care about it. Yeah. So now you see that this is the direction of the flow in our reach. Here we have the name of the river, and here we have the name of the reach. Yeah? Now we may not like, we may dislike generally, dislike this drawing, and we would like to change it. We have such an options to change here in the edit. Change name, move points, objects, add points, remove points. Yeah? If we, for example, want to move points, we may choose this option and make some changes as you see. Yeah? Remember to uncheck the option after use. Yeah? The option should be unchecked. So if you want to make some changes, just check how it works very shortly. Just correct your drawing. Okay.
Yeah.
Ready?
Yeah.
Okay. Now we may save our geometry data. Use file, save geometry data. File, save geometry data. Okay. And you should see this window very similar to the previous window when we created the project. We are in the same location. This is the default location. We may change it, but it's not recommended generally, especially in the beginning. No, we are not going to change the location. In this location, this file will be created with the name of the project and extension starting with J, and this star here means the number. So first geometry is J01, second J02, and so on. Yeah. So this is the convention. And here we should give the name of our data, maybe Geom01 as the first geometry. Yeah.
Okay.
Okay.
Yeah.
Okay. So please write the name and press OK. And press OK.
Yeah.
Okay. Let's press OK so the data are saved. Let's minimize this window, and this is what we should see. This is what we should see in the main windows of HECRAS. We have the first line just completed, and the third line with the geometry. Here we have the active geometry of our project. Yeah.
Yeah.
Everybody.
Yeah.
Okay.
Okay, it's clear.
Okay.
You can
Now.
Yeah.
In this folder, you should see also the file J01, and this file may be also open in Notepad, but I'm not going to do it now. It's really simple, and there is generally nothing at this moment. The file is almost empty, so later you might just look at this. And we have additional file with the extension HDF, and this is also a relatively new feature in HECRAS. All the data and all the results produced with HECRAS are additionally stored in the files, binary files of this format. This is the HDF, means a hierarchical data format. Yeah? Hierarchical data format. Sometimes it's useful because we may have the access to the data and to the results with the Python scripts through these files. So it helps a lot a lot to just to automate some simulation. But this is more advanced option. So at the moment, I'm not going to talk much about it. This might be open in a specific software. The most simple is HDF Viewer. It's for free. It might be found in the network. So maybe later, if you want, you may just download and install it. Okay. So at the moment, we'll leave it. Okay.
Yeah.
Okay. Let's come back. Let's come back here. Yeah. We have reach. We have reach ready. Now, of course, we can just use this tool once again, river reach, and draw another reaches. But at this moment, I would like to avoid it because it caused the problem of the junction generation. So I would like to focus on the basic reach. At the beginning, single reach is enough. Okay. So when we have a reach, when the network is ready, our network is very simple, but it's ready now. We may just go here on the left to this toolbar. First icon is so-called junction for setting of the junction. But the second is something what we use is a cross section. Each reach generally includes several cross sections. So the shape of the channel and the flat planes we model with this additional option. Okay, so please press cross section and you should see this window. Okay, everybody?
Okay. Yeah. Okay.
Okay.
You can continue.
Now,
yeah.
In this window, what we have? First of all, on the right, we have the graphical part. The cross section we will create or we will look will be displayed here. Yeah? This part might be closed, but of course it's better to keep it open. So it helps us to understand what we really have. Yeah? The left part is for data, for preparation of the data, and this part is also split into two subparts. Here we have the table of points, which are used to create the shape of the cross section. Station is a horizontal coordinate, elevation is the vertical. Yeah, so these two coordinates will be used here, and these points which let us to draw the cross section here. Yeah, we are not going to make it manually. We just define the points, and the points will be displayed here and should be connected. Of course, the points should be connected, so the order is really important. Here we have additional parameters. I will tell about them a little bit later. Okay, so at the moment, this part we will leave. First of all, if you start, okay. Any questions?
I talk to my student, yeah, because station and elevation, it means XYZ coordinate, yeah? Latitude, longitude,
exactly, yeah. Not XYZ, but only two coordinates. So let's call them YZ, okay? Because X might be just assigned to the river. Yeah. So we have only a plain picture of the cross section. So only two coordinates, horizontal and vertical are here. Yeah.
Okay. Yeah.
Okay. Cross sections will be normal to the.
Wait a second, Thomas. I will explain to my student. Jadi kalau yang koordinat ini sumbu Y-nya aja, cuma dua, datar sama kedalaman. Nggak pakai tiga, ya, YZ aja. Yeah. Okay. You can continue, Thomas.
Okay. Okay. So now, if you would like to put any number here, like now, you should get such a message, because before we start, we need to tell HECRAS where the cross section is and how it is done. First of all, we choose the river and the reach, yeah, where the cross section will be created. We have only one river, only one reach, so the choice is done. But here we need also this variable, which is called river station. River station is a variable which works like a kilometer h. In the hydrology, such variable is used. This is, in the most cases, distance calculated along the river from the outlet upstream. Yeah, so if you would like to say, for example, that the dam is located in the 2nd kilometer of the river, it means that if we measure the distance from the outlet, after 2 kilometers we have a dam, you know, just going along the river.
Yeah. Outlet itu
So this is,
yeah. Cerita 2
this is so-called linear
okay,
referencing.
You can continue. Indonesia.
Okay. So river station is something what we will use like this. River station might be expressed in kilometers, might be expressed in meters. This might be even the numbers, but the relation between the numbers tell us what is the relation between the elements. So if the number is smaller, it's closer to the outlet. If the number is greater, is upstream, more upstream. Yeah? So it like in
But a second, I want to explain to my student. Jadi makin dekat dengan outletnya, pengeluarannya, itu nilainya makin kecil, makin jauh, makin besar. Kayak STA di jalan raya. Paham ya? Jadi ada STA. Ya, jadi station ada nomor-nomornya. Angka-angka aja. Kayak kilometer kayak di jalan. Yeah, okay, you can continue, Thomas.
We can use also this picture maybe for a moment just to make such a digression. So if we have a river, let's imagine that this is our river. Here we have a coast, yeah, the sea coast. So this is our outlet here. This point will be the kilometer, let's say 0, because this is the outlet. Yeah, this is the outlet. Then when we measure the distance along the river, exactly just going along the river, we have maybe here kilometer 2, and this might be our reservoir, our dam, or something general, something what we have. Yeah. So river station is such a distance calculated around the river. Yeah.
Kayak jalan. Yeah.
Okay.
Yeah. Okay. Very clear.
Okay. So we have to start.
Okay, you can continue.
Okay, we have to start with the just setting the river station. We do it in such a way. We have to go to the options, to this menu, and this is very common when we set other elements like the hydraulic structures, bridges. We also have options and add an element. Yeah, add an element. In this case, this is add a new cross section. In the new cross section, we have only one choice. We need to just write here what is the location using river station. And I would like to define the first cross section in the outlet. So the question is for the students, what should be the river station in the outlet?
Di tempat keluarnya, cross sectionnya pertama, yang kayak kita gambar di sana. Yeah, it's okay. You can continue, Thomas.
Okay, but I have the question. What they say? What is the river station in the outlet cross section?
Iya, jawabnya pakai jawab, pakai itu, pakai mic. Enggak, hidupin.
Okay, we have the answer.
Hidupin aja, udah kalau lampunya udah hidup udah bisa.
In the outlet, what we have? What should be the river station? Could you repeat?
In the middle, Prof.
In the outlet, what is the river? I don't hear.
Di outlet tadi itu kilometernya berapa tadi?
Okay, this picture explains in the outlet. This is beginning of our calculation, so this is 0. Okay.
0.
Okay, we just defined this cross section, which we should be located in the outlet. Okay.
Yes.
Okay. So here in this window, across the first river station is basically 0.
Yeah. Harus no.
Okay, and we press OK, and we are ready to just to proceed, just to make the next steps. We can use the description box here just to write short description, and we may just write outlet to know that this is the outlet. Yeah, outlet. And you should notice that when I write here, the color is something like red. Yeah, something like red. This color is specific because this color in HECRAS means that our data, this what we put in the window, is not still in the project. It still need to be set into the project. And in many windows in HECRAS, you find this button, Apply Data, which just move your data from the window to the project. Yeah. So if this button is active, it means that you have some data which are in the windows, in the boxes, but not in the project. Yeah. So this is important to remember, that we should just care about this button. Yeah. Okay. Okay. Can we make next step?
Yes.
Yes.
Yeah.
Okay. Please follow me and we focus on this table. Okay, just write the same numbers I write here, and in the moment you will just realize what these numbers are when the cross section will be displayed. So let's start with the station 0 to 12, 14. Such 4 points. 0 to 12, 14. Okay. And in the elevations, in the middle, we will have 0. In the left and right, or in the top and the bottom, we have 2. Ready?
Yeah.
Okay. If you are ready, you see that the numbers are also in red. So please press Apply Data to see the shape of your cross section. The cross section is trapezoidal, as you see here. Yeah? Everybody?
Bisa lihat semuanya?
Yes.
Kenapa gambarnya gitu?
Okay. We have
Yeah.
4 points. We may click on these points to see where they are in the table. This is the next point. Okay. Sometimes we need to click several times just to catch the point. Okay. If you have a problem, you may also use in any graphical window, you may use right button, and you have such options like zoom in, zoom out, full plot. You may use these options just to zoom in and select better the point. Yeah.
Yeah.
Okay. Let's use full plot to see the full plot, and generally this is what we have. Yeah. Okay. It's good time to save the cross section. It's not ready yet, but we can save now. And you may realize that we don't have any option saved in this menu, because this is not separate program. This window is strictly connected with the geometric data. Yeah, we save the cross sections, everything, every geometric information here. File, save geometry. The cross section is saved. Yeah. The window is still here. I can just look here. Okay, the cross section is displayed once again. If this is hidden, you can open anytime your cross section once again and find your cross section in the list if you have more cross sections. Yeah. So this is we can come back. Okay, anytime. Ready?
Yeah.
Now let's add flat planes to the cross sections. So let's go to the station elevation table. Let's select the cell in the first row, and here just above the table you see 2 buttons: delete row and insert row. Let us to just remove row and just put on another row. If the first row is just chosen, let's press insert row, this on the right, twice. Okay, twice. Okay, let's add 2 rows at the top. Ready?
Yeah.
Okay, now please follow me once again. Here we write maybe something like -1000. We may use negative values here also. It's not prohibited. -1000 and maybe minus. Okay, okay. I'm sorry. I need to come back when the zoom is used. Sometimes it's not okay. Okay. Now everybody see my screen?
Yes.
Okay. Now -1002. And let's write here in the elevation part, let's write 2.15, okay? 2.15 in the second row. And let's write here 3.6 on this elevations. Ready?
Yeah, ready.
Okay. To see what it means, let's press apply data. Okay. Apply data used. And here, okay. Here you see it, that this picture still looks like it looks before, but now we have small picture which tell us that there is some another part in the drawing. Okay, let's press right button here and use full plot. Okay, let's use full plot. Full plot, and you see that we have one flat plane in our cross section, and the channel is very narrow. It's not an error, because you should also notice that the scale, horizontal scale, is different than vertical. Different than vertical. So everything is correct. Generally, the cross section is very wide, but relatively shallow. So it's typical for rivers with flat plains. But of course, the picture we see here is scaled, and we have what we have. Okay. Let's add another flat plane, but we will use the symmetry. So this is artificial cross section. So we make it symmetrically. So let's focus on the station elevation. Let's add 1000. So we have 1014, and let's add 1000 and let's add 2 meters. So we have 1016. Yeah. And I rewrite the numbers from here. We have 2.15 and 3.6. Yeah, 3.6. Ready?
Yeah,
okay.
ready.
Let's press apply data, and let's use in this window once again full plot. Yeah, full plot. Now I will just maximize, because I would like to focus on this picture. Okay, everybody? Yes?
Yeah.
Okay, now let's have a look here in this part. This is the point we need to explain a little bit more. First of all, at the top, we have something what is called downstream reach length. Maybe I will use the magnifier. Okay, you see better?
Yeah.
Okay, we have downstream reach length. Here is the space to define the distances to other elements. I told you at the beginning that it does not matter how you draw your river reach, but because the distances are defined in other places. And this is the place where the distances to the other elements are defined. So we have the cross section, and we define the distance to the next cross section, which is downstream of our cross section. Yeah. So this is the idea. Because our cross section is the outlet cross section, so there is no downstream cross section. So generally the downstream element does not exist. So we may easily write here zeros. Yeah, does not matter. Yeah? Does not matter. If we use GIS data, it will matter a little bit, but the meaning of this number will be a little bit different. So I will tell you later how we should interpret this number. Okay. So at the moment we may just write 0 because downstream element does not exist. This is the last element and nothing more. Yeah. Ready?
Yeah.
Okay. And there is one more important element. Why we need to write 3 numbers. This is also important just to explain. Let me use this picture, or we simply refer, I think, to the HECRAS help, because in the HECRAS help, the explanation of this fact is quite nice. So I will open the document called Hydraulic Reference Manual. Yeah, Hydraulic Reference Manual. Let's go to the theoretical basis of 1D steady flow surface profiles may be enough. Let's look at the cross-section subdivision, and subdivision explains us. Okay, this is what I need or not. Let me find it, the proper picture. No. If I am not able to find, I'm sure that there is a nice explanation in this document, but I'm not sure if I just find it so quickly. Not here, maybe here. No. Division. Not this one also. So maybe here we will find it. No, okay. Okay, now I'm not able to find it in the manual, but I'm sure that it exists in the manual. So maybe I'll just prepare this picture alone. Okay, so once again, it should be okay. So what we have, if we have a river, let's imagine that we have such a channel with one bank and the second bank. So this is our river. Let's imagine that this is the inflow and this will be the outflow. Yeah. Okay. Now we have the river with the cross sections, and we have also the flat plains on the left, on the right. Let's just draw that this is our left and right flat plains. So these are some imaginary boundaries of the flat plains, just caused by the walls of the valley in this case. So when we define the cross sections in such a system, when we have the flat plains, the cross sections should be cross sectioned through the whole valley. Yeah, the whole valley should cross the channel and should cross the flat plain. So now we can just see that we have different distances. One distance might be calculated along the channel. So in the middle of the cross section, we have different distance, that the distances calculated along the flat plains, and the distances along the flat plains may also differ, may not be one, but might be different to different distances. So the HECRAS includes this problem, the problem of the flow in the channel, exchange with the flat plane and exchange back. So of course the flow in the flat plains is a little bit different than the flow in the channel. So the equations are composed in such a way that they generally includes these elements and this connection. But to model properly this flow, we need to define three distances. Okay. So the distance here is called distance in the channel, and many cases this denoted as CH or CHAN or something like this. Distance on the left is denoted with the letters LOB, and this means left over bank. Distance on the right is denoted in many cases as ROB, and means right over bank. Yeah, right over bank. Yeah. So the same system is used also to define the roughness coefficients, the coefficients responsible for the friction between the water and the bottom. And these coefficients in the most simple form are defined for a channel and for the left and right flat plane. Yeah, because the friction may work different in any of these parts. In the a little bit more complex cases, we may define the more detailed way. By the first approach, the most basic approach is such that we have three coefficients in the left, right flat planes and in the channel. Yeah. So this LOB, ROB means exactly this what you see. CHAN is a channel always. Okay?
Lihatnya dari arah arus. Wait a second, Thomas. I will explain to my student. Jadi arah arusnya itu, lihat ya. Jadi kita berdirinya, misalnya arahnya ini kan ke kanan. Kan berdiri ke kanan, yang sini yang LOB, yang sebelah kanan namanya RROB. ROB, ya. Right over bank sama left over bank. Tapi lihat arah arusnya kemana. Gitu ya. Oke, thank you, Thomas. Can
Okay,
continue.
okay. So this is why we have here these sections: LOB, ROB, and channel. No? So this means exactly this what is here. Okay, let's magnify. Okay, now we have Manning n values. Manning n is exactly roughness coefficient, because roughness coefficients appear in the Manning equation. So this is called also Manning coefficient, and I hope that you are familiar with the Manning equation. Yeah. Okay. So this is what we have here. But before we define the Manning coefficients, we need to also tell HECRAS what is the division of the channel into the channel and the left-right over banks, because of course we see it, but HECRAS does not know. HECRAS basically has numbers and nothing more. Yeah? So we need to say where is the left-right bank. So here we have the space to define the position of the banks. The position of the banks is defined with the stations. Some stations have to be chosen and just simply wrote here. If we are not sure what is the station of our banks, we may zoom. Just click on the bank, the left bank. I see that the first coordinate is 0, so I write here 0. No? And I click on the right. The first coordinate here is 14, so I write here 14. Yeah.
Bisa ngikuti?
And
okay. Bisa? Okay, you can continue. Yeah.
Okay. If we press apply data, you should see red dots in the points of the banks. Yeah. Okay. Later, I will show you another method, faster, but at the moment, it's enough. Okay, it's enough. Yeah. just to look at this. And now we have banks, left and right bank. We may just define the Manning coefficients. So in the channel, I suggest 0.025. What is the typical coefficient for the sand beds? 0.025. And in the flat planes, we may just add some, okay, I'm sorry for my screen. We may just write something like the, grass bushes, so 0.045 or maybe on the other, okay, I stop zooming because it's moving. So second will be 0.043 maybe, okay? So these values, I zoom now just to show you what values should be here. Okay.
But a second, Thomas, I will explain to my student. 0,045 itu biasanya apa? Kayak tadi rumput-rumputan alam ya. Kalau 0,025 itu cenderung kayak beton itu 0,02, 0,01, 15 ya. Di tengah-tengah, makanya kanan sama kirinya beda. Itu ya, lihat di tabel Manning roughness ada. Itu ya. Okay, you can continue, Thomas.
Okay. So at this moment, if the numbers are here, we press apply data, and we should see here in the top of our picture the zones of the roughness coefficients. Yeah. Okay.
Yeah.
Okay.
So sudah apply data. Yeah. Okay. Yeah.
The first cross section is ready. We may come back to the geometric data and save it, and use save geometric data just to have this cross section. Do not care much about this picture because the scaling is not proper because only one cross section exists. When we add another cross section, you will see the dependence between the scale and the size of the elements because they will be properly scaled. Okay. Okay. So let's come back here. Okay. Now let's define second cross section, and let's assume that second cross section is located 15 kilometers upstream of this cross section. Okay, 15 kilometers upstream.
Okay. Wait a second, Thomas. Jadi dia punya jarak tadi di muara 0, sekarang jaraknya di upstream, di hulu tadi, for example 15 km. Thomas mau jelaskan di sana ya. Oke, can continue, Thomas.
Okay. Now, of course, we can use options on the new cross section and define once again new cross section, but I would like to avoid it. I would like to just to make it faster and simpler. We can use this option, copy current cross section. We may copy, may copy this cross section and modify. We will modify it after copying. Okay, so please use the second option here from the options, copy current cross section. And we need to say where the copy should be located, in which river, in which ridge, and what should be the river station of this copy. So we can use the kilometer age, and we can write the river station in kilometers. So it might be 15. Okay. 15.
Yeah.
I would like to underline that we use kilometers in the river station, because when we use GIS data and we import the GIS data, the river station becomes in meters. Yeah, but will be in meters, so there will be a difference. But generally works the same. So we should not be scared of this. But at the moment we use kilometers. Okay.
Okay.
Okay. So if we write here 15, let's press OK. And you should see something like this. The same shape, but here you see in the list you have two cross sections, yeah, and they are exactly the same. So
Yeah.
it's not really good, because it means that the river bottom is plain. So it's not the case. First of all, this is not the outlet. Let's call it middle, because I would like to just define one more cross section. So this will be in the middle finally. Yeah, finally it will be in the middle, and we may press apply data. Yeah. Now we need to change the downstream reach length, because this is 15. So the distance along the channel is 15 kilometers. Along the channel, the distance given here should be in meters. So this is 15,000 meters. Yeah. So in the channel. Okay, ready?
Yeah, dari tulis 15.000.
Okay.
Yeah.
Now we have flat plains. Let's assume that river is meandering, so the distance along the river is larger than the distances along the flat plains. So let's assume that here we have 11,000 in LOB, and here we may have maybe 12 and 500 or something like this. Okay, so there is some asymmetry in our picture. We may just imagine we may use this here. It's not a problem. Generally, these distances are different. So we may just write something like this. Okay, so once again, I will just zoom in. We have such a numbers here. If the river station is 15, in the 15 we have in the channel 15,000 meters, in a LOB 11,000 meters, in a ROB we have 12,500 meters. Okay, ready?
Yeah, ready?
Okay, let's press apply data now. Let's press apply data now. And now we have a distance and we have a width of the cross section. So this is enough information to properly scale the picture in the geometric data. So let's come back for a moment here, and you should see such a difference. Cross sections are now in. And of course there are only two cross sections. So the HECRAS thinks that the whole reach is generally for these cross sections. One is in the beginning, the second is at the end. It will change later. Okay, but you see the dependence, how it works. Here you have quite interesting information in the bottom on the picture, especially the first line, that we have some problem with cutting of the elements which are in the picture, and we should of course repair this just to see the whole picture. How to do it? Let's press right button in the space. Yeah. Okay. Ready? You see these options like zoom in, pan. So these are typical options of the graphical window. But now I would like to focus on the last option: set schematic plots extends. Set schematic plots extends. Do you see it?
Yeah.
Let's open this window. Let us to set the extent of our picture. Let's
Perpanjang.
set the extent of our picture. We don't need to care now about the numbers which are here. If we use GIS data, this will be the coordinates, real coordinates of our data. But at the moment, these are only the numbers just to scale the picture. Okay, so to make the proper view, we should use this button, set to computed extent. So Hackers recompute the extent which should be used. I use this and press OK. You see the picture changed, and now we see everything.
Yeah.
Okay. Remember to save at this moment. It's
Simpan dulu.
important to save from time to time. And let's come back to the window of the cross section. Okay, the window of the cross section.
Ya,
First of
balik
all,
ke cross section.
okay, can we?
Ya, balik ke window cross section bisa. Okay.
Okay. First of all, I would like to narrow this cross section. So I will have the narrow cross section in the upstream, which becomes wider in the outlet. Yeah. So such a channel we generally model. So first of all, I will just shorten the flat planes. It will be not -1000 but -500, and I will change the same here. Yeah. I will shorten a little bit the bottom. It will be not 12 here but 10, and here I will have 12. Yeah. And I will also shorten this. This will be 512 and 514. Yeah. So these are the new stations. I will zoom. So this is what we have in the column station.
Bawah lagi, udah.
Yeah.
Ya. Oke, ready? Saya ngikuti.
Okay, ready? Now let's press apply data. And you see this message that something is wrong because the right bank is missing. The right bank was 14. Now 14 does not exist in the table, so we need to just to correct it. Yeah? So I press OK here, and of course now right bank is 12. So I will write here 12 and press apply data once again. Red bottom should be in the proper place. Yeah. Okay.
Okay. Diperbaiki.
Let's make full plot. Now, one more, okay, maybe not such, maybe greater, but not so huge. Now, one more feature, which is very, very useful here. We may see both cross-section in the same picture if we just check this box here, keep previous cross-section plots. Yeah, keep previous cross-section plots. And now, if we use these arrows, we may just navigate between cross sections, and you see both cross sections in the first in the one picture. So you see what is the meaning of our changes. Yeah. Okay.
Okay, masih
Everybody?
ngikutin. Yeah. Okay.
Okay.
Yes.
And now of course we see the disadvantage of this method because still both cross sections are in the same level. Yeah. So we need to change it. We need some slope between the cross sections just to model properly the flow of the river. So let's come back to the 15. Please take care that 15 is here, chosen here. Okay. It's really important to remove this double view. You may just uncheck previous and press this button, clear preview. You remove other cross sections and you stay only with the current cross section. Okay. We may now just use full plot just to see our cross section. Now we should change the elevations of this cross section just to move it up to generate some slope. And we generally assume some slope and recalculate what should be the difference in the elevations. Okay. Let's assume that our slope is typical for the lowland in Poland, because I will refer to the Poland data because I'm more familiar with Poland data. So generally, I'll just use this. As you notice, the GIS data which I put in the Google Drive are also the GIS data from Poland and Lithuania. Lithuania, our neighbor. I also made one project there, so I have such a data. Okay, let's assume that this is 0.2 promille. This is typical slope of the lower end rivers in Poland, but we need this slope in a dimensionless form, not in the promils, but as this number. Yeah, so this is dimensionless form of the 0.2
Same to
promille.
Indonesia too, Thomas.
Okay, so this is the
Indonesian
this
RENEC
is,
have a regulation the same too. The
okay,
same.
so we use this slope. Okay,
Yeah.
and if we multiply the slope by the distance, we have the difference, final difference in the elevations. So we need to just multiply by the distance, but in the meters too much. Okay, in the meters. Okay, so if you have dimensionless slope and distance in meters, we have this what we need. But of course we could use a little bit complex calculation, use the slope in promils and the distance in kilometers, but it's not the simplest one. So I prefer use the dimensionless and meters to refer to the base units. Okay.
Okay.
If I multiply, I see that the difference should be 3 meters. Yeah?
Wait a second, Thomas ya. Jadi dia cerita kemiringan kita pakai di Indonesia tuh sama, di Polandia sama di Lituania. Kita tuh pakainya 2%, 2/1000. Jadi 0,002 tuh persis sama kita pakai di drainase. Semua se-Indonesia aturannya segitu. Jadi dikalikan 15 kilo panjangnya, ya kan, kemiringan 0,02 itu dapatnya 3 meter. Itu yang Thomas jelaskan ini. Gitu ya. Oke, Thomas you can continue.
Okay, let me use this. This is our slope.
Yeah.
Slope 0.2 promille.
Yeah.
Promille.
Yeah.
This is our distance. So this would be the distance. In our case, this is
15 kilometer ya.
15 kilometers.
Yeah,
exactly.
Yeah.
Kilometers. Let me check. Okay, not this. This is okay. 15 kilometers. So this is what we okay. We have kilometers, and this is our difference in elevations. Yeah? Difference in elevation from the tangent from trigonometric function. You generally can recalculate this. Okay, so this is what we did, and we know that the difference should be 3 meters. Okay, so this is relatively simple. We assume that we have the constant slope between this cross sections, but it's enough for the first example. Yeah, as a first example. So we may now change manually. Okay, I'm sorry for a moment. We may change manually in this column all the numbers, just adding 3. But there is another option in HACRAS which help us and simplify this process. We should select all the column, just clicking on the head, on the top of the column, and in the options.
Okay.
In the options, we have adjust elevations. Adjust elevations. Okay. So let's use this option. We can add some value to the elevations. If the value is negative, of course, the elevations will be move down. If it's positive, will move up. Yeah? So in our case, I write basically 3 and press OK. All the elevations are greater, and the difference is 3 meters, as you see. Okay.
Yeah.
If I press apply data now, my cross section is escaping up. So I need to use full plot once again to see it once again. Yeah? If I check this box, keep previous cross sections, and navigate with these arrows, I see the difference now. Yeah? So one cross section is down, second is up. Yeah? Everybody?
Yeah, bisa ngikuti? Yeah, okay. You can continue.
Okay. Let's come back to 15, and of course let's uncheck clear preview full plot. So let's come back to 15. Okay, everybody. Okay. Let's remember that we need to save here in the geometric data. Let's remember that we need to save in geometric data, and then let's come back to the cross section. Okay. Now I left the roughness coefficients as they are. I don't want to change them because of course we may change, but at the moment we'll stay with this what we have. And I would like to make one more cross section. This time I will keep the same shape, but of course I will move up only just to make it faster and save some time. Okay. So let's have a 15 chosen. We should be in the 15, everybody. And let's use the same option copy current cross section. Okay, copy current cross section. Copy current cross section. And now I would like to move it 10 kilometers up. 10 kilometers up. So what should be the river station? What should be the river station now?
Berapa kamu?
25. That's good answer. Yeah, that's good answer. We add river station. We go upstream, so we always add the distance. Yeah. So this time is 25. Yeah. This time is 25. Yeah. Okay. 25. And let's press OK. 25. We have the river station 25. Now it's not in the. This is not middle. This is our inlet. This is our inlet. So we may change the description. Okay. Inlet is defined, so now we need to change also the distances, but distances always are calculated to the first downstream cross section. So in our case, along the channel, we have 10,000 meters. The river station is 25, but the distance to the next is 10,000. Okay. And left overbank, right overbank, we may just write such values a little bit smaller than previous values. So maybe something like this. Okay. You see?
Yeah.
25 inlet and these distances. Okay. And so let's press apply data. Let's close it. Now I would like to keep the width the same. So the station, I'm not going to modify the station. The left bank, right bank will stay the same, but I need to change only the elevation because this cross section should be also should move up because we need some slope. Okay, let's assume that this time the slope is 0.4, so a little bit greater, 0.4 promille. So this is 0.0004 in dimensionless form. The distance is, I have to multiply, distance is 10,000 meters. So the change in elevation is 4 meters. Okay.
Okay.
Okay. So this 4 meters we will add to elevations in our in this column in our cross section. We use the same option, adjust elevations, and basically use 4 here and press OK. And press OK. And all the elevations should be greater. Please check if your elevations are the same like mine to be sure that everything is correct.
Yeah.
Okay, that's good. So press apply data. Let's come back here. No? And of course, this is good moment just to press this to check this option, keep previous XS plots. Okay, this here, keep previous XS plots. Remember that XS in HECRAS always means cross section. This is abbreviation of the cross section. XS is cross section. Okay, so in all other elements of the menu, in other options, YX is also appear. So it's good to remember that this is cross section. Okay, let's check it and let's see what we have. Our channel looks like this. We have narrow in the inlet. It's constant till the middle cross section and wider in the outlet. Okay.
Yeah.
Okay. Now we can of course just change the position, and any cross section we may stay we want. And we may close at the moment this window and come back to geometric data. Come back to geometric data. Okay. You see that the picture here is different. It's different. The cross sections are smaller because the distance along the channel is greater. And we see 3 cross sections in the distance of 25 kilometers. it's too less generally. So generally the standards now in Poland, the standard is that the cross sections in the implementation of the FLAN directive should be not in the greater distance than 500 meters. So this is the smallest distance accepted in such calculations. So we should generate more cross sections, but of course, if we make it manually, even using the copy, it's really time-consuming procedure. So we will try to avoid it. We have a tools in HECRAS to generate cross sections artificially, just by interpolation. And we generally use these tools. Sometimes they are also useful if we use the GIS data. Sometimes they might be used in combination with GIS data just to produce some reconstructions of the bottom or something like this. But at the moment, we generally need these tools to generate our channel. So remember at the moment just to use safe geometry data. And let's have a look here in this menu, tools. Very useful menu. There are several options which let us to handle the data, geometric data especially. Now we use the first one, which is called cross-section interpolation, XS interpolation, so cross-section interpolation. Okay, everybody?
Yeah.
Okay, now we have two options. We may just make interpolation for the entire ridge in one time with one step, or we may just make interpolation between each two cross sections. So just go step by step from one ridge to another ridge between cross sections. We use the first one because it's simpler. So at the moment it's enough. So the first looks like this: cross section interpolation by ridge. Everybody?
Okay.
Yeah.
Okay, we choose the river and the ridge. This is chosen, as you see. We need to choose the upstream cross section. Our upstream cross section is 25. We would like to start interpolation from this. Okay, 25. Downstream is chosen by default, and we stay with 0. We want the interpolation over the entire ridge. And we need to just select only one parameter, the maximum distance between the cross sections. So the distance will be like we just write here, or will be shorter. We may write 500 meters, and it should be the really maximum, but I prefer in such computations to get the greater accuracy just to use 200, okay? 200 meters, okay? Ready? 200 here.
Yeah.
Ready.
Okay, and now we have such an option, such a frame here. If we use GIS data, we could use this the first option, just to assign to GIS data and make the cross sections in the shortest distance between the cross sections. But we generally use the line of the river, and we prefer to have the cross sections normal to the river. Yeah, normal to the river. So let's check the second option here. Second option here. So the interpolation will be done exactly along our river. Yeah. And now the accuracy of the interpolation, and supposedly this means that we will use the accuracy with the tiered place after the comma, after the dot. Yeah. So tiered place, and this is enough. Yeah, this is enough. If you use shorter accuracy, what should be consistent with the generally with our measurements, because we are the smallest unit we use in the measurements is 1 centimeter in the most cases, but in such case we will get some steps, so the accuracy of the interpolation will not be satisfactory. So let's use tiered place, but more is not necessary. Yeah, more is not necessary. So this option by default, or default option, should stay here. Okay. Yeah. And here, if we are ready, if everything is ready, I will just zoom to check if you have the same settings. Yeah. Yeah, sama setting semuanya. We press this button on the right, interpolate cross sections. Yeah. Interpolate, the effect is not seen until you use close, and then you should see such a picture. Yeah. Ready? You have several cross sections which were generated, and this is why they are orange, not brown. Yeah, the color is different. And close to this, to each cross section, you see the river station. Yeah.
Wait a second, Thomas. I asked.
Okay.
Jalan, Rifandi? No.
Oh, sudah. Oke.
Ada apa yang salah?
Benar.
Ya.
Klik
Sudah.
interpolate.
Okay, everything is okay.
Okay.
Yeah.
So the color is different because they are interpolated. And if you zoom in, you see that close to each cross section, you have river station. And in the case of the interpolated cross sections, the river station is with the star. No, you have small star close to the river station. No, you see. So,
Yeah.
so this is the distinction, the difference between the cross section just put manually and cross section interpolated cross section. No?
Yeah.
Okay. Okay, let's come back to the cross section, to this window. Let's go maybe to the upstream cross section 25. Yeah, 25. Ready? Let's check, keep previous cross section plots. And please go down to see what is the generated shape. You should see that when the cross sections are the same, upstream and downstream, the shape is generally repeated. But
yeah.
when the cross section, the shape is changing, the interpolated shape is also changing. Yeah. Okay, you see?
Yes.
Okay. Check one more thing here in the menu plot. Use plot profile to see how looks the profile of your bottom. Yeah. In the upstream part, we have greater slope. In the downstream part, we have smaller slope.
Yeah.
Okay.
Okay.
Okay, so this is consistent with this, how we just put the data and what we wanted to obtain. Okay, remember to save your geometry. Okay. Okay. If this is saved, let's close geometric data. Let's close geometric data. Let's come back here to the main HECRAS window. Yeah, everybody.
Yeah.
Okay, now let's go to edit and let's make the next step. Next step is just the choice of the method from this group. Let's start with steady flow data, the most simple. Okay, let's steady flow data. Steady flow data, such a small window should be open. Okay. Now, steady flow data, as I told you, the steady flow data is the calculation of the water surface profile. A water surface profile, the basis for the steady flow data is okay. Steady flow water surface profile. Let's look at the manual. This is the equation. This is Bernoulli equation. Bernoulli equation. Bernoulli equation basically is a balance between the potential energy of the stream, work of the pressure force, and kinematic energy. Yeah. Do you know Bernoulli equation?
Yeah. Yeah.
Okay. 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 Additionally, we have here. Yeah. Additionally, we have the losses. The losses are, yeah, this is the scheme which explains the elements, the profile, and here the method for calculation of the losses. This is the basic loss along the flow. These losses are generated by the expansion and contraction. Yeah, such local losses are also calculated here. So these two hydraulic losses are also included in calculation. Because the flow is in the channel and in the flat plains, the distance is weighted distance. It's weighted distance, so the distance is calculated in the weighted form, average form between different sections of the channel. You can easily read generally about the theory a little bit later. If you are familiar with Bernoulli equation, there are some a little bit more advanced elements, but supposedly it will be clear because this is not something which differ much from the standard Bernoulli equation. So we have Bernoulli equation. Bernoulli equation let us to determine the water surface profile along the channel, and we will use this exactly in this way. First of all, let's have a look here in this window. This is supposedly the most important part. You should remember that for Bernoulli equation, the parameter which led us to make the calculations is the discharge in the channel. So for each reach in our network, we need to define the discharge. We have one reach which starts in the river station 25. Yeah. So we need to put here the discharge, which will start in this cross section and will be just kept till the change or till the outlet. Yeah. So this is the philosophy behind this picture.
Discharge, the bit.
Yeah. Let's write here that our discharge is for the beginning. It might be 20 cubic meters per second. This is the interpretation, because we operate in the SI units. Yeah?
Yeah.
This is 20 cubic meters per second. Yeah.
Yeah.
Okay. At the moment, you see the apply button here, and the red color works the same. We may press apply button, or we may basically use save flow data. Yeah, save flow data. So let's call them flow 01 or something like this. This is the file name which will be saved. Of course, extension is F, and star means number. F01, F02, and so on. Yeah? Okay, so the file is saved. File should appear in our folder, and file should also appear here in the main hackers window. Yeah, steady flow. We have the file defined. Ready?
Yeah.
Okay.
Ready? Yeah, okay.
It's not enough. The discharge is not enough, because when we calculate the flow profile, we need some starting point. We need some boundary condition, the depth, water elevation, or something like this. Boundary conditions are hidden here in this button. And this button, reach boundary conditions. Let's press it. Okay, let's press it. So we have additional window. I'm not going to explain now what means the options in the top. It will be just presented later. Let's focus on this table. Yeah, on this table we have the list of reaches. And we may put boundary condition here or here in the upstream or downstream. But it's not so easy. It depends on what kind of flow we want to simulate. Are you familiar with the fruit number? Supposedly, yes. Fruit number. Yeah?
Fruit number. Fruit FR itu loh. Akar GH. Yes.
Exactly. Fruit number, let's find it. Fruit number is very important in our space. This is fruit number, the velocity, average velocity in the channel divided by the square root of the gravitational acceleration and the depth. L in this case is characteristic length, but of course in the channels this is the depth. Fruit number. If we have these numbers, okay, this is complex explanation, but I need something simpler. Fruit number. Okay, this is overview. Maybe overview will be better. Okay, this is the explanation. Fruit number, but this is square fruit numbers. I see this is an error. We have inertia force to the divided by the gravity force. So this is the interpretation. And what is really important? What is really okay? I will use my lecture. So please one moment. I will need to connect additional disk. It will help me just to explain one thing. Okay, let's use this. Okay. Okay. We have, okay. We are here and let me look. Open channel flow will be good enough. Okay. I'm sorry for the form of these lectures, but generally I use this kind of a lecture just to explain some things. So this is the derivation of the fruit number, but finally I would like to focus on this. This is the definition. velocity just divided by the square root of the J and H. So gravity acceleration, and the depth. First of all, it tells us, yeah, this is the interpretation. So this is what I would like to focus. Generally, the U is the velocity of the fluid, but this what is in the denominator, square root of the J and depth is basically called the celerity. So this is the velocity of the wave just traveling in the channel. So we have two cases, typical cases. Fruit number might be smaller than 1, lower than 1, and fruit number might be greater than 1. And these cases in the English literature are called subcritical flow and supercritical flow. Okay, you see the interpretation here. Yeah, the names. The interpretation is very simple. If we add something to our flow in the subcritical conditions, we generate two waves. One which is coming downstream, second which is coming upstream. In the supercritical conditions, both waves are coming downstream. Yeah, because the velocity is so huge that the waves are also coming downstream. Yeah? So it changes the way we simply put the boundary conditions. These cases. If we have this case, subcritical flow, we should add only the downstream condition because we calculate the water surface profile upstream. Yeah? If we have this case, we put boundary condition in the upstream because the water surface profile we can calculate is the downstream water surface profile. Yeah. So this is the difference between these two cases, and the flow regime it will be also chosen a little bit later and should be consistent with the method we apply boundary conditions. Yeah. So this is why
I will explain to my student.
Yeah. Okay.
In bahasa, I'm sorry. Ya. Jadi di gambar kiri dan kanan itu bedanya. Ini yang critical, ini yang supercritical. Ya, ingat belajar hidrolika. Nah, ketika dia ada ditekan sesuatu, dijatuhkan sesuatu, yang ketika subcritical, dia arahnya ke kiri kanan wave gelombangnya. Nah, tapi kalau supercritical, ya, supercritical cepat itu biasanya kecil, dia cuma satu arah. Nggak akan bisa dia naik ke atas. Tapi kalau supercritical, ya nggak gitu cepat arusnya kan, dia akan kiri kanan. Paham ya? Okay, you can continue.
Okay. Supposedly it's not something new, but generally we need to focus on this because in this moment this is really important. Yeah, to remember about these differences because they play important role here. Okay, let me just close. No, not close, but maybe just move down. Okay, let me just how to. Okay, I will close this one and move down this one. Okay, so I would like to simulate subcritical flow conditions in the channel because we assume that this is typical channel in the environment. So I will focus on the downstream. Yeah, so boundary condition is put in the downstream. Now, these are the boundary conditions I can put. Yeah, these are what I can put here. The last button is for deleting of the boundary conditions. So we don't need to explain this. So if the downstream is just selected, I may choose the boundary condition. At the moment, I will focus only on this one. I will just explain others later when we test different cases. This boundary condition is known water surface. So this water surface elevation is known, and we basically put in this place. Okay. So this is known water surface. What water surface we may put? I will put. Okay, let's press it. So you see, for this flow, we should define the water surface elevation in the outlet cross section because downstream of the channel means outlet cross section. Okay. I will write here 2.1, and I will explain why a little bit later. Okay, so for a moment, please follow me. For in this place 2.1. Okay.
Permukaan airnya 2,1 ya di tempat yang 20.
Okay.
Flow-nya 20, permukaan airnya 2,1. Okay, you can continue.
Okay. If I press OK, I see that known water surface is just put here. It's imposed. It's ready. If I press OK, this information was also just introduced, entered to this window, but I need to press apply data or basically save flow data. Yeah. Why I wrote 2.1? Let's come back to the geometric data. And let's open the last outlet cross-section. I can open cross-section from here, yeah, you know, or I can simply select the cross-section in this picture. And if I use left button, I have the option edit cross-section here. And cross-section is open, exactly this which I want. I don't need to search over the list, but exactly this which was selected is just open, okay? And look at the composition of the elevations here. We have 0 here, 2 meters here, and 215 here. If I put 2.1, it means that the flat plane in the outlet is a little bit inundated. Yeah? It means that we have some water in the flat planes. This is why I put 2.1. If it would be less than 2, it means the water surface in the channel. Yeah? In the channel. If this is above 2, it means water on the flat planes. And so I just generated such small.
Bikin 2,1. Itu kenapa dibuat 2,1 itu karena di 2,15. Yeah.
Okay.
Okay. Yeah. Okay.
So this is why I chosen this value 2.1, because I would like to just generate small inundation in my model and recalculate the water surface with such inundation. Okay, so you now realize that water surface should be just compatible with the geometry we have. Yeah, with the geometry we have, the cross section when we just put the condition. Of course, it should not be 100, for example, because this is totally above the geometry we have. So we always need to look at the geometry. Okay, so this is the explanation. We are here, steady flow data. Steady flow data are ready for the first competition. So remember to save before you close. You know, before you close this. Okay. Can we make next step?
Yes.
Okay. Now let's go to the menu run. And we are in the menu run. We have a data for steady flow analysis. Yeah, we have geometry and steady flow data, so we may run steady flow analysis. Okay, so let's choose the first option. Let's choose the first option. Okay, this is the window of our option. This is the window of so-called computational plan, because in HECRAS we work in a project which may store different data of different types, but the plan should combine, should connect only the unique set of data. So one geometry with one flow data and produces one results. Yeah, so this is the idea of the plan. In the project, you may have several geometries, several data for the flow, but in the plan there is only one-to-one. Yeah, one-to-one with unique set of results. Okay. So this is the role of the plan. Of course, there might be several plans in the project, but in our project there will be only one plan. Okay. We need to create plan at the beginning, so let's use file new plan.
New plan.
New plan.
Okay. Click new plan.
New plan. Let's give a name plan 01, for example. You see that the file name will be name of the project with the extension P from plan and the number. Yeah? Let's press OK. Plan needs to have short name, short identifier, and this identifier in many cases appears in the graphs and tables. So P01 abbreviation of the name is good choice.
Okay.
Yeah, and let's press OK. So we have name, we have the short ID. Yeah. Now we choose the geometry and flow file. We have only one, so we don't have any choice now. Now in this frame we have the choice of the flow regime, and this is you now understand why we should care about the definition of the boundary condition, because if this is downstream, flow regime is subcritical. Yeah. If we impose upstream, the flow regime should be subcritical. No? Flow regime should be subcritical. But if we want to simulate mixed conditions, we should put boundary conditions in both cross sections, upstream and downstream. So both conditions should be defined. Yeah? In our case, subcritical is a proper choice. Okay, ready?
Yeah, ready.
You may also add some short description to your computations if you wish. Yeah. We are not going to make flat plane mapping because the GIS data are necessary for this. So in our first case, we are not using GIS data. So basically we stay with this what we have. Remember to save before you press this button in the bottom, compute. Okay?
Compute.
If you press and everything is correct, you should see these 3 blue lines, blue bells. Okay. If not, if there are some errors, there will be the messages of errors.
Bisa semua?
Okay.
Yes. Okay.
Okay. Everything correct?
Yeah.
Okay.
Correct.
Okay. Let's close this window. It means, okay, here you see the time of computations. These are very small computations, so the time should be really short. This is less than 1 second, as you see that the computations, so it's okay. So let's press close here. Let's close this window also. Remember to save the project. And let's go to view to look at the results, the first results. First of all, let's use the second option, water surface profiles. Okay. Surface, and this is what you have. We may maximize this window. Let's let's look at the legend. Okay, legend is interactive. So if you choose any option, this option is just also shown. Just underlined, not underlined, but it's also just chosen in the graph. Yeah, we have such a lines. WS is a water surface, so this is generally what we want. You know, water surface. So this blue zone, of course, is a water. Is theoretically is our water in our channel. This line, green dashed line, denoted as EJ, is an energy grade line. So this is something what in Bernoulli equation is called energy line. So if we add the velocity hat, yeah, if we add velocity hat, we have this line. This line should be very close to our water surface. If you zoom in, you see the difference. Yeah? You see the difference. Yeah? Here we have also ground. So this is our bottom, minimum elevation in the cross section. Yeah? And this additional crit is the critical depth, critical water surface elevation, in fact, calculated in some cross sections. There are some criteria inside HECRAS, and this elevation is sometimes calculated. Yeah? Okay. Okay. In the most cases, we would like to have different variables displayed. So let's change it a little bit. Let's go to the options.
Okay.
And we have variables. So these elements which will be displayed. Okay. Options, variables, and we may choose what we want to see in our picture. Of course, I would like to see water surface. I would like to see field in water surface. So this blue zone is quite nice, so may stay. Yeah. But I don't need energy grade elevation, and I don't need critical depth elevation. Yeah? The rest here is not important because they do not exist in the project. So we may just leave them as they are. But I would like to check this too, because these are banks. So if I have banks in the picture, I see where I have inundation in the floodplain or when the water is in the channel. Yeah. Okay.
Okay.
Okay. So please check. Have the first 4 checked and the next 2 unchecked. Okay. And let's press OK. You see such a picture. You see that inundation is here. Water is above the banks. Yeah. But if we look at the upstream part, the water is below, so it's in the channel. Yeah. Okay.
Okay.
Okay. Let's just keep it here, and we may even keep it in such a way. Let's go to view, and the first option, cross section. Cross section. We see such a picture. This is we may just go from one cross section to another and look how the inundation looks. Yeah? If you go up enough, you see that the water is in the channel. Yeah? Okay. And one more thing, without JS data, good option is also to use in the view profile summary table. This is second group. These are tables, table presentation of the results. This is standard table number 1, standard 1 in HECRAS, the most typical table used in HECRAS. In this table, we have the information about the reaches, river stations, profiles. This is the name of our profile, PF1. And what we have next, we have a discharge. In our case, this is constant discharge along the channel. We have minimum channel elevation here. We have water surface elevation here. Yeah. And the rest is not so important now. So we may just stay with this, because this information with the river station led us to prepare water surface profile in Excel, for example, or other software. Yeah. So this data, it could be good to be able just to take this data from the HECRAS and put in another software. How we can make it? In many cases in HECRAS, where we have the results in the file, we have the option copy to clipboard. Yeah. So copy to clipboard. Later we may use Ctrl-V just to put the results in another place. Yeah. So this is the equivalent of Ctrl-C. In fact, if we use, for example, we can make the example. If we use copy to clipboard data and headings, and if you open Excel, for example, or other software of this type, and use Ctrl-V, you see all the results inside your spreadsheet. Yeah? And you may just handle the results. You may do whatever you want. Yeah.
Kalau dipindahkan ke Excel juga bisa.
Okay. Yeah. So you are free now, just flexible to make with the results whatever you want. Yeah. So whatever is the need. Okay.
Okay.
Okay. So questions at the moment?
No.
Okay. Let me show how looks the errors. If we run computations, how looks the errors, just to avoid any panic with the errors. Errors are not so difficult to handle. Let's I will just go, if you want, you may follow me. If not, I will just show very quickly what's going on. I just select any cross section, yeah, in the geometric data, open cross section, and for example, I forget about selecting or writing the roughness in this cross section. Let's imagine that I just forget this. Okay, so this does not exist. I apply data, yeah, and just close it. Just save it. So this is the error, really difficult to find if we use only this window. Yeah, if we use only this window, it's easy to find if you use, for example, from the table of the Manning coefficients. You can very quickly realize that one of the cells is empty. Yeah, but of course,
data nanti bisa kelihatan.
Yeah. But of course you can miss it. Yeah, you can miss it because such data, that there's a large number of such data in the project, and you may just not realize that such error exists. Everything we just set, and we just go to this moment. We are ready to set the computations, and we don't have any message that something is wrong. If you press compute, you get such a message. Yeah? So look, you have the information about what is the river, what is the reach, what is the cross section, and what is the problem. So everything is described. Yeah? Everything is described. Very easy. You can just open your project, and just let me just check what was the cross section, because I don't remember now.
Yeah.
Okay, this is 15. Okay, 15. So let's come back here. 15. I can find 15 or any of the cross section I need, and I see after the description that here I have missing data. Yeah, missing data. So we may even just change it into another value. Why not? Yeah, why not to change it differently? So if I just correct, everything should work fine, as you see. Yeah. Another error. Let's imagine that we make the error here in the steady flow data. Yeah, in the steady flow data, maybe I make such an error that I basically remove the condition from the downstream and put the same condition in the upstream. What of course is an error, but maybe I will not. I didn't realize that I made such error. I press OK. I save everything and run the computations. This is the message I get. Yeah, that the missing is the downstream condition. Upstream may exist, but for the subcritical, it's not used. Yeah, so this condition is not used. The hackers is looking for a downstream condition. So this is what we have. Of course, we should come back to the proper option. We should just open this option. This is general error because 2.1 does not fit the geometry of the channel, so I delete it. But here I can just put another value and maybe even just cause the greater inundation in this case, and just apply data, save data. It's really important to save the data and recalculate everything as I wanted before. Yeah. So this is how we manage the errors. The errors are in the steady flow conditions. We have the messages, very clear messages, and this is okay. These are the most simple errors we can manage. The errors which may appear in the unsteady flow computations are a little bit more difficult, but not the errors related to the geometries or flow conditions. But there are also specific errors related to the numerical methods. So this might be more difficult, but in this case, it's relatively easy. Okay. Questions?
Ada pertanyaan? Everything is clear.
Okay. To finish. Okay. To finish, I would like to show you a few things. First of all, let's come back here to the channel I just told you about. That this is ready. Our exercise is here in this video. Okay, if you just look at the video, you will be able to repeat even yeah, but you have also recording of this meeting, but this is additional source. I think it could be good idea if you try to use this video and to extend your project. These are next steps. These are next steps. I need to explain one more thing maybe. In the steady flow data, in the rich boundary conditions, we have also these conditions here, yeah, which were not discussed. Normal depth is the condition like a Manning equation. If you have Manning equation and the discharge, you are able to determine the normal depth. If you are familiar with the basic hydraulic, you know what the normal depth is, and this is the condition which might be put instead of the known water surface. Here we have critical depth. So the critical flow conditions without any parameter, and rating curve is the rating curve that the relationship between the water surface and the discharge. This is typical hydrological information just collected in the gauge station. So if you have such information, you may just also put it here in the table format. Okay, so this is what I need to add. In the video, you will see also the difference between the use of this option and this option. So at the moment, I will not explain it. I will let you just to play with this option. Okay. So this is what we have additionally in the video. So if you have time, you may, before the next meeting, you may just use this video also just to repeat the exercise and look at this video. Later, we may just talk a little bit about the inline structure, which is also interesting, but maybe a little bit more complex and more explanation will be necessary. Okay. Okay. And I would like to also tell you one more thing. I think that these channels will be quite useful for you. RAS solution, a lot of videos with the different options made by one of the HackRAS developers and supervisors, Chris Goodell. Yeah, so this is good channel RAS solution. You may also use this channel, basically HackRAS, made generally the main protagonista here, the main actor is Stanford Gibson, is also the developer of the HECRAS, current active developer of HECRAS, and is talking many times about the new options which are in the next releases of the HECRAS. And I can also recommend this channel, Australian Water School. They are giving different webinars. Some of them are free. Some of them are paid. So the free webinars are really good. So you find also the information about the HECRAS, HEC HMS, and other software. Yeah. So these links are generally in this file, link docx. Yeah. And this channel is also quite interesting, but this is not the HECRAS developer. It's a woman from Madrid in Spain, is giving short tutorials on short selected features of HECRAS. Really good examples if you need to find something specific and you are interested if it exists. It's good just to look at her channel, and very short, small exercises are presented here. So later I learned, for example, how to modify digital terrain model in HECRAS. It is possible. What are the options? She explained really good. The channel presents the videos in two languages. One of them is English, second is Spanish, but all the videos, all the tutorials are generally repeated. So if you find something in Spanish, it exists also in English. If something is in English, it's also given in Spanish. So this is the bilingual channel. In fact, I think this is really good. I used it alone. Sometimes I have impression, I don't know if I should admit, but she's better than me in HECRAS. If you look at this channel, so you see how deeply explain some things, but also in the level for the users, not for the developers, for the users. So it's really good. Yeah.
Yeah.
Okay, I think that for the first lesson, it's enough. I feel that this is enough after 2 hours. I don't know what you feel.
Hampir 3 jam setengah.
2 jam.
Wow, 2.5 hours. Make applause to Prof. Thomas.
Oh, thank you very much. Thank you very much. Thank you. Okay.
Yeah,
so,
I really appreciate Prof. Thomas.
It's really important to repeat, just to make the skills to be in your hands, and then in the next meeting, maybe next week, we will just focus on the GIS and also inline structure. In the time, if we have time, we just talk a little bit about the inline structure and maybe bridges. But the most part is the GIS data in the HECRAS. Okay.
Sorry, Thomas.
Yeah.
I'd like to explain you. Tomorrow in our next week is a national holiday. It means whole week. Next week is holiday. So in our university, there are no activities. Maybe next week, yeah, at 18.
It's okay.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
I need to check it, because I also have one conference, local conference. I will be here in Poznań, but I will be in the conference. So let me check my calendar. So next week you have week off, but okay. So in the week after your holiday, on Wednesday and Thursday, 17 and 18, I am in the conference. So these 2 days are I'm not able to make the course. So the only options are Tuesday, Monday, but in the Monday I have also one class. So we need to just to think about this hour is not available. So maybe Tuesday will be the best, or Friday.
Tuesday in 16.
16 or Friday 19. Yeah.
Okay. Tuesday is better, yeah. In 16. Okay.
Okay. Tuesday might be Tuesday. Yeah.
Yeah. Tuesday in 16 at the time, more or less the same.
Might be the same. Yeah.
Okay. Okay. Once more, thank you very much, Thomas.
Thank you very much.
Yeah, we are very happy. That's
Okay,
give
that's
a lot
good.
of question. That's because before this course we learn by ourselves, autodidact, yeah, just to get. But after you deliver this course, we get the real impression how it works exactly. For example,
Okay.
how to develop the model. I asked to my student how the model run. We still not understand how it works, how to input the model run. And so you show us we should first give look like one discharge, yeah, is special value and also boundary condition. That's why we still, yeah.
Okay.
Last year,
Okay.
just yesterday, one of my students say give the discharge 2,500 meters.
Okay.
And what happened? All of discussion flooding in this flood. That's
Okay.
why it's very funny. I'm not sure about your number. Now today we got the number. Okay. Oh, we exactly know how to get the input to run the model by special number of the discharge. Okay, really, really important for us how to make the model run. It's important. Yeah.
Okay. I'm really happy. So
yeah. Any questions?
With the unsteady flow, is there any difference with the unsteady flow simulation? Because from our scene, it's the steady one.
Yes. Steady one is the simplest option. Steady one is the simplest option. So this is why I start with this. Do you see my screen? Yeah. This is the simplest one, and this is always good start. Yeah, if you prepare the project, always start from the steady flow. It's relatively simple to make the configuration, to configure the model, but later you may change into the unsteady easily. Yeah, so easily, but of course the additional effort is necessary. We may just talk a little bit the unsteady also during the next classes. Unsteady flow here, if you open unsteady flow data, you will realize that this is our window. You need to put two boundary conditions, in some cases in the format of the hydrographs, not only numbers. Sometimes you may use normal depth or rating curve. These are the boundary conditions which can be used in different locations. Yeah, you need to put initial condition at least for one for the for like in the steady flow, but generally the conditions are more complex. Yeah, and you should be more careful about it. Run in the run, you have also more options like here. This is the plan of for the computational plan of the unsteady flow simulation. You need to decide what programs are run, but this is relatively easy. But you need to set the proper starting ending date, so the proper time horizon. And what is really important, you need to look at this parameter, computational interval, the computational step, which determines the stability of the computations. And in some cases, it's not so easy to set. So unsteady flow generates new problems. We may just talk about them, but it was good to start from steady flow, just to focus on the most basic elements, and then now we have the fundament, the base for the next steps. Yeah, to talk more about the unsteady flow also. Yeah. And if we have unsteady flow, we may just play with another results, because we may just look at the stage and flow hydrographs. You may realize also that here is the button of the animation. So if you have unsteady flow, you may animate your results. This is also possible. But the best, the most interesting play is if you run unsteady flow with GIS data, and you may just animate inundation in the terrain. So this gives you another opportunities, but also requires more work, more care, more problems may appear, more errors may be generated. No? Okay.
Okay. Ada lagi? Ya, hanya kasih saya. Oke. Besok aja pertemuan berikutnya ya.
And I also have a question. What are the different geometry in 1D or 2D can we use the next step?
I'm not sure if what is the difference between 1D and 2D computations? This is the question.
Yes, in the flow area.
Okay. Yeah, generally the differences in the model. I will just share the screen once again. In the model which is implemented, and this is visible in this and this pages. Let me just check. Yeah, the hydraulic reference manual. Here you see that we have such sections. Steady flow water surface profile. So this is what we just did today. So yeah, so this is our focus. Unsteady flow, you ask me about this, and unsteady flow, one-dimensional unsteady flow is based on the different equations. Equations, there are two equations. Continuity equation, which is I don't need. Maybe I will look at this. Okay, this is the picture I just searched for, just explaining the distances. Yeah, these are the equations for unsteady flow computations: mass balance equation and momentum balance equation in the partial differential form. So these are the equations with the time components, with the spatial components, one spatial component along the channel, another along the flat planes, and the distribution between the flat planes and channel is also modeled here. These equations are called sum-Venant equations. So this is the difference between one-dimensional steady flow computation and one-dimensional unsteady flow computation. But two-dimensional is the next one. We have another model here. Let's go here. Hydraulic equations. This is what we need. We have the mass conservation. This is the equation for the mass balance. Two-dimensional with time component and x, y components in the plane. Yeah, in the plane. And also we have momentum conservation as two equations: the x component of the momentum and y component of the momentum, which let us to simulate the flow properly. In the HECRAS, this equation is not the default equation, because HECRAS, as the first approach, uses the diffusive wave approximation, where the momentum balance is simplified. But generally, let us to simulate also two-dimensional conditions. Also, the boundary conditions need to be changed a little bit, because we just apply conditions not in a single cross section, but in a line along the boundary of the zone. And of course, we need the plane data. Generally, we are not able to simulate, as I can imagine, it's difficult to simulate two-dimensional flow without GIS data. We need some GIS data, because we need the spatial distribution of some parameters. So this is different level in general. If we have more time, if we have more meetings, there are also data for two-dimensional computations in the Google Drive. And here you also find the videos. So this is one example, but this is the example, the video which just fit the data. Yeah. So bridge 2D, this is the bridge in Lithuania. But I think that before you start working with the two-dimensional simulation, it's good to wait for the one-dimensional simulation, but with the use of GIS data. Yeah. With the introduction to GIS data, with the introduction also to unsteady flow, because two-dimensional computations are only made in the unsteady flow conditions, not with steady. Yeah. So this is the difference in the complexity, and finally the results we obtain are also spatially distributed, not in the cross sections. You have to also know this will be visible in the examples with the, okay, we may just look at this, but I will stop this. In the examples with the one-dimensional computations and one-dimensional data, sometimes you may obtain two-dimensional picture, but this picture is interpolated from one-dimensional results. If you use two-dimensional model, of course, the results are generated in 2 dimensions. So the accuracy of the simulation is also different, totally different, and the number of details you can model is different. But also the computational time is larger. Yeah, it's larger, and sometimes it's difficult to play with two-dimensional model, because if the computer is too weak. Yeah, so this is also problem which may arise. Okay.
Thank you. Professor Thomas, I have another question. Our team has already run a simulation. Can I show the result of our simulation?
Okay, just show. Okay.
But it's something that is from a YouTube tutorial, so we don't have the clear way to make it. So we just follow one certain video, like in this example that I have tried to look from one video. We are running an unsteady simulation, but currently at the moment we are confused with the terrain map because at the moment I took this terrain map from a website called Elvis, which gives you a free terrain data. But one of the problems that in Indonesia is that accurate with 8-meter grid, and we use the real bathymetry or elevation by measuring it in the real life location. How do we actually input the data into the terrain?
Okay, there are several methods to do it, but generally the procedure sometimes is larger and takes some steps. Because if you would like to be consistent with the digital terrain model, you need to interpolate the bottom generally using some interpolation methods and just connect with the digital terrain model. If I can just stop for a moment, yeah, can I share the screen?
Yeah.
Okay, if you look at the same channel, I just show you. You have two approaches to this issue with ArcGIS, made with ArcGIS, with the ArcGIS desktop. But there are also other opportunities in the HECRAS itself, in the RAS mapper. You need to assign the data, put your data into your cross sections in the HECRAS, and then try to build the digital tree model of your bottom. Yeah. So this is the method. If you need only one-dimensional computations, you may just avoid generation of the digital tree model of the bottom and only put your data directly to your model in HECRAS, not in digital tree model, in GIS model, but only in the cross section in HECRAS. But if you want to be more accurate, it's better just to build the digital tree model of your bottom on the basis of your data using the tools, specific tools in HECRAS, connect with the digital tree model, and then simulate once again over the combined bottom and digital tree model. Yeah. So such data, such measurements might be included. What is the format of your measurements? Are there the measurements in the cross sections, or are the measurements with the measurement device which you just show me the previous time with this sonar, small sonar?
Yeah.
Because if there are point measurements, and you have the map of the points over the bottom, you can use the standard interpolation methods in GIS software. If you have the measurements in the format of the cross sections, there are some specific measurement interpolation methods along the channel which let to interpolate better, just keeping in the channel the whole interpolation. So it depends on the format of the data also. Yeah, but this is typical problem. You have some measurements of the bottom, you have some digital tree model, and they do not fit. Yeah, they do not fit. Yeah?
Okay.
Okay.
I think maybe for the next meeting, we pair such as our bathymetry data in our two location that the student prepare it, and we will show you that we have 3D XYZ for the bathymetry data.
Okay.
Yeah, that is a good idea.
Okay.
How to input it. Yeah.
Thank you.
Anything else?
Okay.
Yeah, I think it's enough, Professor Thomas.
Okay. Okay. That's good. Okay.
Yeah.
Okay, thank you very much.
Sekali lagi, kalau how what your I think your traditional maybe in Germany, if the lecture is very satisfied, we should knock the table, something like that. But in Poland.
Okay, thank you very much. Thank you very much.
In Germany, if you are finished and the student like your lecture, and our student will be knock the door, something like that.
Thank you.
Follow them
Thank you
today.
very much. Thank you very much. Thank you.
Yeah, I think it's enough
Okay.
from us. I think we will be deliver the second course at the 16th of April. Yeah,
Okay.
and 8
Okay.
morning in Poland. Yeah, we also
Okay.
in Indonesia at 2 p.m. Yeah,
Okay.
it's okay from us. And maybe we should prepare about the bathymetry data. Maybe we also yeah,
Yeah,
it's okay.
but it's okay, but it depends. Okay, but
Yeah.
because if you look, for example, next time I will just share for a moment the screen. Next time I would like to focus on the something like this. Yeah, this movie, for example. If you look the RAS mapper to geometry, I would like to make this with the data we have. So it takes generally it takes about 1 hour and a half. So if we have more time, we may work with the bathymetric data. It could be good if you send me it before. I can just look at the data and just decide what to do with this data, because I also have some ideas about the data which are in the cross sections. I also work in the Lithuania, especially with the data which were point data. So it's important to decide what we should do, because if you have point data, supposedly we should use some QGIS procedures, and in the past I focused on the ArcGIS, so I need to check what procedures are available as an equivalent of the ArcGIS, just to save time, yeah, during the classes, just to show you the options which really exist and really work. Okay, so let me know a little bit faster. Okay, what you have. Okay.
Okay. Thank you very much, Thomas. Bye bye.
Okay. Thank you. Thank you. Have a nice holidays.
Thank you. Yeah, thank you. Have a nice day. Yeah, have a nice day.
Okay.
Bye.
Thank you. Bye.
cek satu, cek masuk. Dipin aja di sana tuh sama Michelle atau Richard. Dipin aja standby.
Cek, cek, cek.
Oke, masuk. Coba kamu Michelle. Iya, enggak. Maksudnya dicek ini. Kelihatan ada mic-nya kok.
Cek.
Nah, oke. Coba Ansel. Masuk. Udah hidup belum? Mic-nya hidup, klip-klip ya? Wah, udah sini saya tes dulu. Tuh mic-nya memang suka klip-klip. Udah, kebetulan kamu udah ngomongan sih. Wah, itu berarti ya nanti ke depan ya kalau nanya ya. Kamu nggak pakai laptop itu, susah itu. Mana? Oke. Ini paru tadi udah kecaspur kayak gini ya. Pas mau tampil dia suka gemeteran, grogian orangnya di mic-nya. Pas April ya, kita pas kemarin itu pas di sana, hari ini mungkin jadwal itu bergeser 1 jam. Jadi bedanya 6 jam, sekarang beda kita sama Eropa 5 jam. Jadi kayak gitu negara sana. Jadi kita nggak bisa punya jam dinding. Karena kalau punya jam dinding tiap 6 bulan digeser. Nanti Oktober gitu juga. Tiba-tiba itu gesernya Oktober ya, bulan Oktober itu pas apa nih? April ya, Mei, Juni, Juli, Agustus, September, Oktober. Nah, pas tanggal 16 Oktober nanti ganti jadi 6 jam. Sekarang sudah mulai musim semi, udah mulai bunganya mekar-mekar. Nah, jadi mereka geser ke Indonesia. Tadi kan Thomas kasih lihat, ini baru ditempatkan ini udah jam 8, kamu kemana? Kita bayangannya masih 6 jam. Ternyata sudah geser ke 5 jam bedanya. Wah, gesernya ya pas hari ini. Ah, Hah? Ternyata siap-siap ke Eropa ya. Dapat perbedaan waktu dulu baru. Nah, ya. Hah? Jadi, ya. Tadi dia bawa mahasiswa satu, tapi kok masih muda sekali. Mahasiswa S3, cewek. Lihat tadi belum? Udah lihat ya? Tadi udah gabung sama kamu, Hansel. Ada cewek, masih muda sekali, udah S3. Hmm? Mungkin aja wajahnya enggak boros kayak orang Indonesia gitu ya. Ada yang nonton bola kemarin. Kalau nonton bola kemarin, wajah pemain Qatar itu tua-tua, tapi kok umurnya di bawah 120 ya. Kalau di Indonesia udah. Iya. Waduh, itu dicurangi wasit beneran itu. Wasitnya berat sebelah ya. Mas, sudahlah. Capek-capek latihan, capek-capek apa dikerjain sama wasitnya seperti itu. Yang kemarin berarti kira-kira udah paham ya. Itu dasar sekali yang kemarin itu kan pertemuannya kan ya, prinsip dasarnya nggak terlalu ribet ya, belum ada. Nah, cuman digeser ke sana sini, how it works-nya jalannya sekarang baru masuk ke ini. Ya itu tadi kan kelihatan mana yang banjir kan tinggal ditambah. Jadi logikanya gini, kalau debit banjir itu kan ada yang 5 tahun, 10 tahun, 20 tahun, bisa nanti sampai 100 tahun. Artinya apa? Misalnya debit banjir 100 tahun, kalian artinya tahu apa? Hah? Bukan. Aduh, misalnya debit banjir 10 tahun aja, artinya apa? Hmm? Hmm? Tidak. Debit banjir, misalnya 5 tahun, saya kecilin lagi. Artinya apa? Enggak. Enggak. Jadi misalnya prediksi 100 tahun ke depan itu sama kayak debit banjirnya dipakai yang 100 tahun, artinya apa? Enggak, enggak. Waduh, gagal kami mengajar hidrologi waktu itu. Ayo, artinya apa? Debit atau banjir yang terjadi kemungkinannya kalau 100 tahun ya 100 tahun sekali. Bisa terjadi kapan? Ya bisa jadi besok. Nggak mesti 100 tahun lagi baru terjadi. Polanya itu ada maksimum dengan debit banjir yang 100 tahun. Nah, itu kejadiannya 100 tahun ini bisa jadi ya dalam 100 tahun nggak terjadi juga ya bisa jadi. Tapi kejadiannya 100 tahun sekali. Makanya kalau orang desain misalnya nanya, Pak, desain drainase, iya mau debit banjir berapa tahun? 10 tahun, 50 tahun, 100 tahun. Biasanya yang di fisik di lapangan apa yang kalian lihat? Katakan desain drainase. Apa? Misalnya debit banjir saya desain untuk 10 tahun. Dibandingkan desain yang 20 tahun. Kira-kira besar yang mana? Apa yang kalian lihat di lapangan misalnya? Yang gampang aja desain drainase misalnya. Dengan kualitas bahan yang sama, apa yang akan bedanya nanti hasilnya gimana? Lebih besar, pasti. Kenapa? Kenapa? Ya dulu saja. Berarti kalau 100 tahun, besar lagi. Penampangnya, ya terjadinya kapan? Ya dalam kurun waktu 100 tahun, bisa jadi kapan? Ya bisa besok, bisa 1 bulan lagi, bisa bulan yang ke-11. Tapi dalam kurun 100 tahun, di situ dia debit maksimumnya. Jadi ketika diprediksi 100 tahun yang akan datang ya bisa kejadiannya besok ya bisa, sangat mungkin sekali. Ya. Ya itu ujian ekstrim tadi, propaganda enggak, itu kan cerita. Saya ceritanya kalau ilmu lingkungan toh. Di sini belum kalian belum. Itu salah satu ujian ekstrim itu terjadi kenapa? Apa sih yang kita ngomong? Ya perubahan cuaca itu apa? Sekarang lagi seluruh dunia cerita itu apa? Pemanasan global, pemanasan global. Coba sekarang kalian siang-siang ini di luar berapa suhu sekarang? 38, 40. 1 tahun, 2 tahun yang lalu segitu enggak? Enggak, paling 35, 36 tuh. Sekarang udah mau 40, bener kan? Nah, terus ketika suhu panas berubah 1,5, sekarang mungkin bisa katakan 1,5 sampai 2 derajat Celcius, apa yang terjadi? Ingat belajar ilmu hidrologi, siklus hidrologi masih ingat enggak? Ayo, siklus hidrologi. Pelajaran paling gampang, mendasar mulai SD, SMP, SMA, kuliah, saya tanya lagi. Bener nggak? Masih ingat nggak siklus hidrologi itu apa? Ya, hujan air, enggak, itu kena hujan itu namanya apa? Bahasa hidrologinya, ayo. Masa nggak ingat lagi, ayo konsep. Oke, terjadinya hujan harus apa dulu? Pengapan dari mana? Hah? Daerah laut disebut evaporasi. Dari siapa aja yang menguap? Air dari mana? Ya, air yang menguap pasti air dari mana aja? Sungai, oke, apa lagi? Danau, ya, jangan cuma itu, apa lagi? Tumbuh-tumbuhan juga semua. Ketika suhunya berubah 1,5 sampai 2 derajat Celcius, semua siklus itu makin panas, makin cepat atau makin lambat? Loh, makin kena panas, makin cepat. Terus hujannya, tadinya curah hujan makin lama, makin besar atau makin kecil? Makin besar. Itu makanya dulu nggak banjir, sekarang banjir itu. Terus sekarang itu kita sadar nggak sadar kita sedang mengalami yang namanya efek pemanasan global. Makin panas suhunya, evaporasinya makin cepat, curah hujannya akan jadi makin tinggi. Paham ya? Loh, yang kalian kerjakan tuh itu sebenarnya. Ya, jadi bukan cuma hujannya, airnya kok jalan-jalan ini enggak ya, fenomena alamnya dulu, pemanasan global itu terjadi ya ini, contohnya tuh ya ini. Sampai kemarin ya, sebelum liburan, sempat kita main banjir-banjiran dulu di sini tuh. Nggak ngalami, nggak ke kampus, nggak ke lab kali. Udah bimbing yang praktikum, sambil banjir-banjir di sini. Wah, banjir, ternyata kampus kita banjir juga. Masuk, Bapak Ira. So, ya, loh, kenapa kok sekarang kalian pikir tadi, oh kenapa kok desainnya desain 100 tahun bukan 100 tahun disimulasi? Enggak, itu terjadi siklus 100 tahun sekali terjadi. Nah, itu dia kayak seperti itu. Itu dasarnya apa? Sekarang kenapa berubah ya? Pemanasan global, evaporasinya semua jadi cepat, lebih panas, lebih tinggi. Nah, lu kemarin ke lapangan, udah cerita kan ke lapangan sedih ya, bingung. Loh, rumput lautnya kok nggak ada semua? Ya kenapa pemanasan global? Suhu naik sedikit, rumput lautnya nggak hidup. Orang sekali nebar misalnya 1 sekian hektar itu, mereka nanam rumput laut kan. Itu kan pakai duit. Hah? Oh iya. Ya, jadi, halo, good morning.
Hello, good morning. Good morning.
Sorry, yeah, about the time mistake for
No,
change in Europe.
not a problem. No, not a problem. Yeah, we have these changes of the time, which just disturb us a little bit, and we still wait that this will finish, and we have one time all the year, but it's still kept, and every year we have such 2 changes in Europe of the time. Yeah. Okay.
Thomas, I have a question. Do you have an objection if our course today record and also have streaming in YouTube?
Stream? Do you want it really? The
Yeah.
okay.
One of my students, Hansel, can you raise your hand? Yeah, he's a operator. But if you are okay, we will share. But if you're not okay, we just in our, I think in our people who attend in this this course.
But the question is, do you really need this stream in the YouTube or not? Because this is educational material. We may just make it later, and I think about preparing more professionally the channel in a YouTube. You know my channel in the YouTube, which is generally very pure and simple. So
Yeah.
so at the moment, sometimes I don't want to make something like this during my classes, just to control how this stuff is distributed. Of course, this is all available for the students, for the participants, but if we put it in YouTube, generally all the audience may use it, and honestly speaking, I don't know. I don't know how to answer. Maybe this is good idea, but still, I haven't considered this. So if we can not do it now, it could be better. Of course, I don't mind if you record this just to have the content for you. It's okay, but I don't know if I want to share it with the whole world.
Yeah. No.
It's completely different.
Okay.
Yeah,
We
okay.
restrict
If
it
I may
our
ask for this,
community here. There's our colleagues in Petra too. Yeah. Maybe if you are okay, maybe I will use this record too. Maybe for the next student can see our course in YouTube.
Yes, of
They
course,
look like
of course. Yeah, okay.
video library. Okay.
Okay.
Yeah, we have a friend like now, your student, yeah, one of.
Yes, Tropica is with us, so I don't see Giovanna and anybody from Giovanna's side. Maybe they don't have a time. It happened. People are occupied. Hello, Joanna. Another Joanna Jaskua is with us also. This is our colleague. Joanna Jaskua, because she participated in the meetings on the Marie Curie project on Horizon, and was involved in the discussions. And maybe she also look at our classes on our lessons. This is I think quite interesting, might be useful, especially that this is a little bit different than the content which is in my YouTube channel, because today I would like to use QGIS. As you asked before, QGIS might be better, so we will focus on QGIS and we will make this exercise with QGIS. Okay. So I think we can start. Yeah, so everybody ready? Okay. So I will share the screen. I will share the screen, and okay, we have I hope that you see.
Okay, excuse me, Thomas.
Yeah.
My student said, could you louder, please? Because the sound is still not so
Louder.
Yeah,
Okay, what do you think now about my
that's much more.
my talk? Is it better now? Maybe you should change the volume in your computer, because generally I can change the volume of my headphones, but not microphone. Microphone has constant volume, and the volume is changed in the receiver in the other computers. Yeah.
Okay, let me check first. Video setting.
Okay, maybe I will check the settings also in my side. Maybe there is something what I can do. Microphone is set to the maximum volume, so I can't do anything more at this moment. And I have microphone close to my mouth, so yeah, and nothing could be better, unless my microphone is not working well. So it's also possible.
Yeah, it's clear now. I change my speaker. I transfer to our LCD and better now. Okay, time is yours. Yeah.
Okay, that's good. Okay, so first of all, we start working with the hackers with GIS data. So I ask you to download this file, exercise 1D file1 zip from the link which was given as the in this file, in the links to our classes. You have the data. So this is in the Google Drive. This is the data for the classes today. Yeah. So please you should have it in your disk. We are going to build a model, and the final version of the model is here. Yeah, it's here in the model 1D version 1. This is expected result of our processing. So finally, you can also check that the model in this in this link. But for now, we just focus on the data. Okay. So I suggest, as previously, just to prepare one folder for the classes today, and at the same location where I have the exercises, the folder for the previous class, I will create at the beginning the folder for the class today. Exercise 02, something like this, and generally this is my workspace for processing. You should remember that I advised you before that the location of the workspace should be specific, because we should avoid in the path to the location, spaces and any kind of national letters different than the pure Latin letters. Yeah. So remember about this, because this might be problematic. Also for Joanna and Tropike, this message, if you are going to choose the location, take care about the whole path, that in the whole path, in the whole address, you don't have national letters, especially Polish letters like chi and other letters, and don't have spaces. Yeah, don't have spaces. It's also important, because some parts of the hackers may just find it as an error and may not be able to read the content of such folders. Yeah. So the location should be chosen carefully, just to avoid other errors. Next problem I will remind it. We talked about it at the beginning, but I will remind. We need to set this. We should do it at the beginning. We need to change the settings of our operating system, because normally operating system Windows is installed with the language and the settings, national settings. In Poland, this is Polish. In Indonesia, this is Indonesian. In Kosovo, this is supposedly Kosovian. And in any country, we have different settings. But generally, Hekras works well with United States settings, because of the format of the date, because of the format of the number, and such things. So the pure way in the operating system is to find control panel, just in the search engine, control panel. Okay, should I repeat something?
Yes, it's okay.
Okay, so control panel. In the control panel, we should have clock and region, and in the clock and region we have region. And this is what we really need. if you plan to work longer with HackRAS and you have the need to change the settings anytime you stop and start working, it's good to have a copy of this icon in the desktop. In the desktop, it let us to access the settings as quickly as it is possible from the desktop. So this, yeah. Okay. Okay, so if you have whatever is the way, if you have, we open this, and here in the format, we should have English United States. It's the best way because all the settings are just changed into the settings which are in the United States, and generally we have the proper format of the date, proper format of the number, decimal symbol is properly chosen, and this all things should be just ready before we start working with HackRAS. So English United States let us to avoid all the errors related to the wrong format of the of many numbers and descriptions in operating system. So if you change it, just press OK, and it should be OK. I press cancel because I have this setting. And we should remember that this setting is not changing the keyboard in our computers because keyboard is changed here. And as you see, I still have the Polish keyboard, but the settings are United States settings. Yeah, so it's possible just to use the keyboard from the different country, settings have of the different country. And finally, I have also the operating system, just as you see, in English, and all the descriptions are in English. So everything what I show should be readable, should be understandable for us. Okay. Ready for the next step?
Yeah.
Okay. Now, if we have the workspace, the folder for our working, it could be good to just create a folder, subfolder, which we can call data, just to store the data. Yeah. Just to store the data, and to the data, we should just extract the content of the exercise 1D V1. Yeah, the content of this in Windows it might be done very easily. We may just go into the zip file and just select all with Control A, select all, and move them like we copy the files. This process generally extracts all the files, and we have everything now in our disk, but not zipped, but just outside of the zip. Yeah.
Okay.
Yeah. Another method, if you have the problem, another method should be also easy. If you click right button, you have the option extract all, and if you carefully choose the location, this will be also extracted. Yeah.
Yeah.
Okay. Ready?
Yeah. Ready.
Okay. Let's go now. Let's go up to the folder of our exercise. It could be good also at the beginning prepare the next folder, which we may call results. Results. We will just store the process, the GIS layers. If we just change something, prepare something, we put it here because we work in QGIS and we avoid connection to the geodatabases. So we will work with the base locations or in the disk. So such folder may help us to store everything what we just produce in QGIS. Okay.
Yeah. For the result.
Ready?
Yeah. Ready.
Okay. Let's now start with QGIS. We will look at the data we have. So supposedly you should have the QGIS icon here, or you may find it in the start menu in somewhere here. Yeah, QGIS. I prefer to work with the new version of QGIS 3 with some numbers, but of course, yeah, you may use the version you like, but it at this moment does not matter supposedly what kind of version we use. So if you have 3 point something, it should be okay. Yeah.
Punya berapa versinya?
Okay.
Sama. Okay. I'll send the same version to you. Okay.
Okay. Okay. So let's open this. Let's open this. And we should start with the new empty project. New empty project. New empty project. I have some problem with the font, but I don't care about it much, so I will stay with this. And generally, we should be sure that the view is exactly what we have. Okay, let me check because the I don't know if you see the toolbar of the Zoom, which is just here, covering some space in my QGIS. Okay, I will hide it, or I will show video panel. Video panel is here. Okay. This is I can hide it, or maybe I will move it. No, it's okay. Okay, do you see my screen correctly? Yeah.
Yeah, you can see your
Okay,
screen.
I wanted just to focus on the QGIS because I need the access, especially to the vector and raster methods. Today it will be necessary, and it was just covered with the video panel, so I needed to hide it. Okay, so QGIS is like a QGIS. If you are more familiar with me, supposedly everything is clear for you. I'm rather accidental user of QGIS, so I needed to check all the options because mainly I work with ArcGIS. But I suppose that we'll manage to make this exercise, and all the options which are necessary in ArcGIS are also available here. So we managed to work. Here we have the location, generate the browser or the locations in the disk. Here we have the layers which will be displayed. So first thing is just to maybe we save the project, because if we save the project, the home folder or the project folder will be just here, and we have the easy access to the data. So I think that in QGIS, according to my experience, is the best way is to start with save project. Save project, and we should just navigate to the location of our exercises, to the exercise, and save the project here. Project GIS, I will call it in this way, and maybe I will add the date. I like to add the dates to my project in GIS because it always tells me when I work on the problem, and in many cases it helps to recover the processing, the information we need. Okay, so let's call it and press save. Yeah. This is quite simple. In this folder, our working folder, we should see the file of the QGIS. But what is really important in QGIS, we have the folder project home, and we can open it, and we have the easy access to the data we need. Yeah, so the data are also here, and we don't need to search over the disk to find them. Yeah. Okay.
Okay.
Everybody, okay. Now, I think it's a good idea to start with okay, you see that what kind of data we have. We have digital terrain model in the format of TIFF. So this is the file. We have also some vector data. These are lines, a line of the river center of the river, of the banks in the river, cross sections, and potential flow paths. Flow paths, I will explain this term a little bit later. This is specific for HECRAS, but it's also necessary to build the model. Yeah, we start with the digital terrain model DTM. So we can just add it easily to our project, just moving to the space of the map. Yeah, to the space of the map. Just drag and drop. Yeah. Let's move it to the map. Ready? Okay, let's save the project, and we may also check if here we have the proper coordinate system. It should be Polish coordinate system 92. So if we just check, we see that this is exactly what it is. The coordinate system is taken from the first layer added to the project, like it works like in ArcGIS. So this is now our coordinate system. Yeah? We should see also the location of our zone in Poland, but the location we will check also with some background map, and the background maps we just add in a moment. Yeah. Okay, let's close this window. Let's close this window. Now we have such a space. You guess that this is the river we modeled. This is the river. Of course, the view is not perfect, so we will change the view. But at the beginning, we start with the change with adding some background maps. Background maps, it means the map in the background, which let us to identify the area which is investigated, which is modeled in this moment. I don't know how you are familiar with this kind of the methods, but generally we use for this purpose WMS, WMTS servers, which let us to add the maps from the internet and display the information about the Poland, about the whole world in our project. Yeah. So this is what we use here in the list of the folders. We have such an option WMS, WMTS. Yeah? Or the same list might be found here in the layers, not the same list, the same option. We have the add layer and we have the opportunity add WMS, WMTS layer. Okay. Okay, let's open this. The window looks like you see here. We have we need to just create new connection. We need to create new connection. And there are two options, but generally we need the web browser to search for a data in the internet. As I remember, open street map QGIS. It should help us. Okay, we have some description how to. Okay, but this is in Polish. But I will change the language to English.
Bisa buka.
Okay. Quick query. No, this is for. Okay, maybe not the OpenStreetMap. I don't remember the link now, but maybe it will be easier to find the data for Poland, and I will send you quickly the link to this data in the chat. Okay. In Poland, we have such a folder, such a server which is called GeoPortal. And in this GeoPortal, we have services, and the services means exactly the access to the WMS and WMTS maps. And we will use these maps as a background because I think these are the best background maps for Poland. But of course, if you want to do the same for any other location in the world, it could be good to find the opportunities, similar servers for the world. And one of the most popular is OpenStreetMap. Yeah? I will show you how to connect OpenStreetMap if you don't know it, but maybe later because it needs some search over the internet. I expected that I will have the link here, but I see that this is the new installation in the new account of my computer, so the links are not here. So maybe later I will find the link to OpenStreetMap, but for the moment we'll focus on the Polish side. Yeah. In the services, I go here to the services and copy this link to our chat. So we should be here. Yeah, please use it. You should see the link. And in this list, in this page, we are going down to this information, to orthophoto map. Orthophoto map could be something good for us. WMTS, I checked it yesterday, was not working well, so maybe we focus on WMS, not WNS. So let's choose the second option here in the table of orthophoto map. Okay, should I repeat something?
Excuse me, Thomas. The link that you have sent to us, my student cannot open it.
This link in the chat? This link?
Yeah, in the chat, we cannot open it.
Okay, let's try with another link. Maybe we'll try the access, pure access from the GeoPortal. Okay.
Saya buka ya. Hah? Bisa.
Okay.
Ansel bisa, Ansel? Bisa, Pak. Ada VPN. VPN itu harus virtual.
Okay, what about this link? Simpler.
Ada, coba link yang baru coba. Coba ada link yang baru. Sama, nggak bisa juga. Also the same, we cannot to access this link.
Okay, maybe so it might be the problem with the
Probably the
access.
IP is not the same, and it's problem for them.
Okay. So they block the access from other
Probably.
sites. Okay, let's find the OpenStreetMap. OpenStreetMap WMS QGIS terrestrials. I remember terrestrials. Okay, so it should be this link. I think we will be able to just to add the OpenStreetMap. It should be available in any location in the world. Okay, let's check this.
Bisa yang ini ya.
Okay. Okay, this is okay. We will use this link. This link. This is different. This is a link for OpenStreetMap. Okay, the third one for OpenStreetMap. Yeah.
Yang baru.
Okay, you have this.
Yeah.
Oh, okay, we don't need to open this link because this link is for QGIS. If you want to look at the website where the link is located, so you have the link here and the description how to add the WMS server to your QGIS. Yeah. So generally I will copy this link, and this link is necessary for me now for QGIS, the previous one. Yeah, the previous one, the short one, HTTP or WS terrestrials. This is what we need. If you have such a link, copy it. Let's close it. If you have such a link, copy it. We come back to the QGIS. Okay, everybody.
Yeah. Okay.
Okay.
Yeah.
Let's use this window. If you have this window WMS WMTS open, we can just go further. It's not. I will remind that this is open from many layers. We have here add layer and add WMS WMTS layer. So this option is used, and we are here. We click on the button new. We use the button new to create new connection, and in the cell URL for the address, we simply paste the link copied previously. This link.
Link yang tadi dimasukkan.
Okay.
Okay.
I will just zoom. Here you should see it. We should call our connection, and as I remember in this web page, it was advised to give this name. Okay, to give this name. I'm sorry for a moment. Okay, this name, yeah. But I think name is not so important. But we may just follow the steps which are advised there. And I think it's enough at the moment. There's nothing more really necessary. We may press OK. Of course, connection is not so easy. We may try now connect, but sometimes it fails. So to be patient. Okay, but I think we managed to connect. Yeah, we managed to connect. Connection is working. Do you see this?
Yes.
This list of the layers which are available.
Lihat semua. Bisa?
Yeah.
Okay. Yeah.
Okay. So let's close it. Let's close it. And if connection is correct, here in the browser, we should see that we may open our connection. We see the connection terrestrials, I'm sorry. And in the terrestrials, we see generally that we have a layer OpenStreetMap, which should be easily added. No, we should choose one of the layers, maybe this one. Okay, and this is our layer in our map. Yeah. If you double click on the second one, for example, you have the layer added. Okay.
Bisa ngikuti? Bisa?
Okay. It's good to move this layer down in the list of the layers just to see the digital terrain model over the background map. Yeah.
Okay.
Over
Overlay
the
ya.
background map. Yeah. Okay. if we uncheck digital 3D model, we see what is the area we model. This is small town in Poland called Wronki. In the north from my location, from Poznań, if you zoom in, zoom out, you will see that Poznań is here, yeah, and the location of the digital 3D model is here. Oh. Okay, so this is you may also see the countries in the Europe. This is exactly our location, that the space which is used to be modeled today. It's relatively small, but we produce simple models, so it will be good for us. Yeah. Okay.
Bisa ngikuti? Hah? Bisa? Hah?
Okay.
What a second. What a second, please, Thomas.
Okay.
Hah? Tanya aja. Ansel bisa. Problemnya apa? What a second, Thomas, because one student can have the same layer with you, and another one still. Oh yeah, time consuming. Yeah.
Okay.
Not directly as fast as you, but and your laptop need more or less 1 minute. Yeah.
Okay. Okay, that's good. That's good.
Bisa, Richard bisa. Bisa. Rifandi? Bisa. Yeah. Takes time. Yeah, not another laptop. Maybe they have a different spec. Yeah. Of course,
Okay.
the
Sometimes
time consuming, but often is okay. Yeah.
Okay.
Yeah.
Sometimes background maps cause a problem with the connection to the internet. If this is slow, we may have a problem with the slowing down the processing in the GIS. So in such cases, it's good to uncheck the background map and just check it only if we need it. Yeah. So the background map might be connected to the project, but may not be displayed, and the project should work faster in this cases. Yeah. So if this is a problematic, so keep the background map but unchecked, and the QGIS should work better in this moment. Let's zoom to our zone. Okay, so let's go to the first layer, digital 3D model, and use the menu from the right mouse button and use this option zoom to layer just to see digital 3D model in the whole space for mapping. Okay.
Okay.
Okay, let's change it a little bit because the colors we see are not very good for looking at them. If we want to work with this map with digital 3D model, what is quite common during the preparation of the model, we should see it in better way, just better for our eyes. So let's change the colors. The colors might be changed in QGIS by clicking right button on the layer and going to the properties. You know? Going to the properties. In ArcGIS, it's a little bit different. So sometimes I need to repeat these comments for me because I need to be accustomed to QGIS. So at this moment I need it. Okay. This what I am talking about QGIS is something known for you or something new?
Ditanya itu. Something new.
Okay, new. So let's carefully look at the QGIS and let's explain all the options to be sure that everything is clear. Okay, so we spend some time. I suppose, Tropika, that this is not new for you, the QGIS.
I've been used before, but mostly, we are using ArcGIS, not
ArcGIS. Okay, so generally, supposedly you are in the same level like me. So let's go farther through this software. Okay, so we should see this window after clicking right button on our digital 3D model, and in this window, in this left side navigation panel, the symbology should be chosen. Yeah? Symbology should be chosen. Okay. If you have symbology chosen, we are working with the digital 3D model. Let's change the render type from single gray to single pseudo color. We would like to see the colors in our digital 3D model. So we need to change this option to single band pseudo color. Okay. Ready?
Yeah.
Okay.
Okay. Yeah.
Now we should be able to change the color ramp here. So let's click this small arrow here, and let's go to all color ramps at the bottom, because the color ramps which are presented here in this list are not something what you want. I would like to go to red, yellow, green. Yellow, green. This is the scale of the colors typical for topographic maps. The red is for the mountains, tops, the green for low areas. So this is something what we want. Yeah, red, yellow, green. Okay.
Okay.
So if we choose this option, supposedly we need also to invert this, because now the red is for the low areas as you look at this. So let's go once again here, and the first option here is the invert color ramp. Invert color ramp. We set the color scale exactly as we want. That the green is for the low elevations, the red is for the high elevations. Okay.
Yeah.
Ready? And I would like to also change one thing. Let's use this arrow, minimum, maximum value settings. Let's open it, because now the scale is just for the entire raster. Sometimes I would like to use the same scale when I zoom in, zoom out. So I would like to make such dynamic scaling of our colors. What is more convenient is better when we work with large rasters. To change it, we should just, if this frame is open, we should change the statistics extent. The whole raster is chosen by default, but for us, the better option is updated canvas. Updated canvas. It gave us this effect of zooming in, zooming out with the rescaling of the colors. Okay. Please check if all the options are the same in your computer. So single band pseudo color ramp, red, green is chosen and inverted. And here in the minimum, maximum values, we have updated canvas in the statistics extent. Okay.
Okay.
Okay. Let's press OK. Let's press OK, and we should see something like this. These are the colors. The colors. So here you see the high areas. Here we see the river and low elevations. Yeah. If we zoom in now, we'll see that the colors are changing because they are scaled. And anytime we zoom in, zoom out, and we see that, for example, this something is higher than the rest of the terrain. Yeah, than the rest of the terrain. So it looks like a dike, exactly like a dike.
Apa, Devandi?
Yeah, like a dike. If we now check in the background map and uncheck the digital terrain model, we should see that we are here in close to the bridges in the Varta, and here exactly is a dike. Yeah, this is what we have here. Yeah, so sometimes we may use digital terrain model, sometimes background map, just to look what is in our terrain, what we really
tanggul
see.
Ya, yang cetan tanggul.
And just have a look in the zone. Sometimes you see a specific object. Sometimes you see the bridges. This is also the bridge. If we check here, we should have the bridge. You know, these are the sides of the bridge. And generally, this is the river, as you see, with some additional tributaries, and this is what we are going to model. Yeah. Okay.
Okay.
Can we make next step?
Yeah. Okay.
Okay. Remember to save the project. Now I would like to have also the layer which is called hillshade. Hillshade is a layer used to model the shades and give us the impression that we look at the real terrain. It's also good to have such a layer. Just cover the digital terrain model. So we need to produce this layer first. Okay. So let's go to the menu, and in the menu we have a raster menu. As I remember, this option was here in the analysis. We have a tool which is called hillshade. Hillshade. Do you see it?
Check. Yeah.
Okay. Let's open hillshade, and we should see such tool. Okay, everybody?
Yeah.
Okay, input layer is chosen by default because we have only one raster, that this tool works with the rasters, one raster in the project. So generally this is chosen at the beginning. If there are more rasters, we have opportunity just to change to choose other ones. We can also choose the rasters from the disk using these three dots. Let us to choose the layers from the disk. We have number of bands is chosen. Rasters sometimes might be composed of the different bands, especially satellite images, but digital 3D models always are one band raster, so only one band is chosen. We have here the azimuth and altitude. This is the position of the sun to model shadows. So the position of the sun, position of the light source is important in this case. We will leave it as default. Default values are good enough and give us what we really need. But what we want to change is this element, Z factor. I prefer to work with something greater, what generally produces greater contrast and better view. So let's change Z factor for multiplying the elevations into 5. Yeah? Into 5. Okay.
Okay.
Okay. So Z factor is 5. Scale stays 1. Azimuth altitude stays as it is. We are not going to change it. Okay. Now we have to go down to this zone, hill shade. Here we should choose the result, the file which will be produced. I don't want to have temporary file. I would like to have the file in the disk. So let's click on these three dots on the right and choose the option save to file. Save to file. Let's go to, let's find our location. We need to do it. Okay, I have this location. Okay, I have here. Let's go to our location, and we have a folder result here. So it's good to choose this result. Just go to the result, and we'll keep all the layers produced in our project exactly in this folder. Yeah? We can call our layer hill, and the extension, the default extension should be TIFF. If this is different, just check it and select. Okay, we may select TIFF with double TIFF. Yeah? So it will be similar to the digital 3D model.
Udah? Hill?
Ready?
Yeah.
Okay, let's press save. And if everything is ready here, we may press run. Let's press run. After a short time, we should see this.
Yes.
Okay.
Okay.
So you see some terrain forms, quite nice, but you don't see digital 3D model, what is not good at this moment for us. So we need to make one small change in this, because it is possible to see at the same time digital 3D model and hill shade. Let's select hill shade, which should be in the top, just above your digital 3D model. Yeah. Let's select it. Let's press right button on the hill, and let's choose properties. Let's choose properties. The properties should open the same window as previously, but now this window is for hill shade, and we should be in the symbology like previously, but we are going to the next option, which is called transparency. Transparency. Now the transparency is 100%. Let's change it into 50%. Let's change it into 50% and press OK. And press OK. And this is what you should see, that you have the colors like previously, but in the colors you also see the forms of the terrain. Yeah? So it's now better to look at what we have, what kind of data, what is the digital 3D model, the terrain we are working with. Yeah? Okay? Everybody?
Ya, saya ikuti. Okay.
Okay, now I would like to make a short overview. If we just look at our digital tree model and go to the right, here to the right, and we just zoom in, we see something different. We have a zone like this. This is typical effect of the LiDAR scanning, that we have the water surface only. But here we have the river bathymetry. This was produced with measurement data and added to the digital tree model. So it's not something what is easily available. This is after processing that we have the digital tree model with the river bathymetry. Yeah, the river bathymetry. It's not so not so easy. We may just focus on this aspect later and explain how to do it. But at the moment, I would like to work with the digital model, which includes the river bathymetry. Yeah, so I would like to have something like this and just make the next steps, which are simpler with this kind of data. Okay. But remember that it's not typical. Normally, digital tree models are distributed without river bathymetry. Okay. So the end of this ridge is here on the left. Here we have the same situation. So in this zone where we have, where we have the river bathymetry, this is our ridge for modeling. We would like to focus only on this zone where the bathymetry exists. Where the bathymetry exists. Okay.
Excuse me, Thomas. I have a question. That you show us the difference between the previous one, that by of measurement data, and another one when the river bathymetry information is not good. It's mean is from the dam data. It's true?
Okay, I will show you what is the source of the data. Generally, the source of the data is digital tree model. Now, it's geoportal. We have the geoportal in Poland, which let us go to the mapping service also. And in the mapping service, it's possible to download the data.
Yeah.
This is the link you were not able to open. The link.
Yeah, we cannot open it. Yeah. Okay.
But I will shortly show you. We have such a portal with the several data which can be downloaded from this portal, and this data, the publicly available digital tree model, might be seen here also. We have the data for 5 meters grid and 1 meter grid with different coordinate systems. And here you see what is the coverage of the country for 1 meter with the old the coordinate system. We can basically just zoom to this data, and I will show you this zone. This zone is split into several parts, and each part might be downloaded separately as a single digital tree model. This digital tree model. Yeah.
Excuse me, I should discuss with my student a second, please. Yeah.
Kotanya Indonesia itu memang kayak gini Pak, sama di kota-kota. Cuman pemerintah Indonesia itu lagi ngetutup webnya itu, nggak bisa dibuka.
Oh yeah, that my student give you information. In Indonesia, they have same information data too. Look like block 1. Yeah, every single location have like a one block, but the website right now still under construction. No, we have still the same problem. We cannot access it. Our government, yeah.
Okay, but generally you have the data. I prepared the data and we may work. I just explained the source of the data, and I would like to show you also where the similar data exists in Indonesia, because the similar data existed for Indonesia. They are a little bit different, but you can also download the data from your side. Yeah? So you see, this is the origin. Yeah, this is the origin. I can easily download the data and then combine them in any GIS software. But this data, which are available in Poland, basically are data of this type. If I have the river, I can see only the surface of the water. The surface of the water, because additional measurements are necessary just to interpolate the river bathymetry. I made such interpolation on my own on the basis of publicly available data, but there is no site for this data, for the bathymetry data. We basically need to ask for this data in the institutions which made the measurements. So at the moment I don't want to focus on this data. They are point data, point measurements, which let us to interpolate the river bathymetry. Okay.
Okay.
So, but if we look here, maybe, oh yes, I have the Indonesian geoportal. Here you have similar data like the Polish geoportal, but I need to log. It's possible to access the data in Indonesia.
Pernah nyoba ini?
This is the geoportal in Indonesia, and you have digital elevation model national in Indonesia also. Yeah. And you can download from them national. Okay, I need to log in once again, but it works well.
Kalian nggak bisa login? Oh, excuse me, Thomas. My student said to me that they are very surprised why you can log in it. They have tried to so many times. They cannot log in that you have show to us right now.
But I'm showing you your own geoportal in Indonesia. I have account there because I just created it. Nobody said me that it's not allowed. So I managed to create the account. I can log in, and I can download the data from here. If you wish, this is the site we were talking last time. Yeah, and you can easily download this digital terrain model for this site. Yeah. So it is possible in Indonesia also to download such data. The resolution is a little bit different because this is 8.5 meter resolution, not 5, not 1 meter, but generally it's possible. This digital terrain model is created on the basis of satellite images. It's not LiDAR scanning. These are from satellite images. The accuracy is a little bit different, especially in the urban areas, but generally some data may be downloaded for Indonesia. Okay. Do you want the links to this data?
Yeah, of course.
Okay, okay, I will just open it here. This is the.
We have one question, Thomas. When you actually register your account?
Okay, you have the link account. You have the option register, and I use this option. I use only the available options. Register, I registered the account, and generally I was able to log.
Nggak bisa. Yeah, so many times my student try to log in, and they are filed.
Oh, really?
Even to register, they're not allowed to.
But you see, I'm here, and I can download the data for Indonesia.
Oh, lucu. Okay. It's very funny, yeah. You are very far away, maybe the 1,600,000 kilometers. We can even ask them from Indonesia. We cannot.
Okay.
Yeah, no access to this portal. It's funny. Why?
Okay. Okay. So this works in such a way.
Okay. Thomas, is it allowed for you? Maybe you can lend us your account so we can use your account to enter this website. Yeah, to get this data.
Yes, we can, but okay. Let me. Okay, but maybe I will send you the information to the account because I will change to the password for something simpler.
Yeah.
And then I will give you the access to this account, and you may download the data. Okay. So after the class, I will remember just to send you the access information, and you will be able.
Thank you very much.
I have some data. I have some data downloaded because I started to download the data for Indonesia when we talk about the project. So maybe I will share some data But if you have the access to this portal, it should be easy to download them, supposedly faster than in my than from Poland. Yeah. Okay. Okay. Let's come back here. Okay. Let's come back here. So we are now in the QGIS. In the QGIS, I think it will be good if we see this model. It could be good also to create in QGIS a group just to keep the terrain, the hill shade and sheltering model in one group. Okay, so please press right button in this zone and use the option Add Group, and change the name of the group to something like terrain. Something like terrain, because we are going to add new data, and it will be good just to have terrain. Maybe we'll put the terrain just somewhere. Okay, let's make an order, some order. I would like to just put into the group terrain, hill, and DTM. Yeah. So just by moving, selecting, and moving, you may easily move your layers to the group. If you uncheck the group, all the layers vanish. Yeah? So this is the advantage of the group, that you may control the display of elements in the group just with one click. Yeah? Okay.
Okay.
Everybody.
Yeah.
Remember to save. Remember to save from time to time.
Save.
And let's come back. Let's come back to the data, to our data in the project home. We have more data. First thing I would like to look now is the river center line. Yeah, river center line. Let's move it to the map zone, and the line should be displayed. Okay, if this is in the terrain, just move it outside of the terrain. Outside of the terrain, maybe here or maybe, but in the top. I would like to see it in the top. Okay, let's move it in this way. Okay, now I have in the above the terrain. Okay, because this is river center line, it's good to change the color to something what is better visible. So let's use right button on the river center line and properties as previously. Properties, and we should open similar window with the symbology chosen here. Let's choose let's change the colors. Let's go to this the bottom level in this window, simple line. Let's change the color to something closer to blue, like a blue, something what looks like a water. Okay, something what looks like a water. And let's change the stroke width, the extent, the width of the line, maybe to 0.66. Okay, to see it better. And let's press OK. Let's press OK. If we press OK, we should see this blue color here. If this color is not visible way, we may just change it, maybe to something darker. Maybe to something darker. Should be better. Okay, not. Okay, I destroyed something. I need to, something is not working well. Simple line. What I did. Okay, I see what I did. I hope so. Simple line. It's okay. Who knows what I destroyed? No, okay, no dash pattern. Okay. So if you don't have a problem, you don't need to correct, but supposedly you should see something like this. Yeah, the line with the blue color and visible. This is our reach. Yeah, this is our reach. Okay. Ready?
Ya, bisa ngikuti? Yeah, okay.
Okay, I would like to also check one thing, because it's important for hackers to have a line which should be drawn from the upstream side to the downstream side, so in the direction of the flow. For HECRAS it's important, so we should take care about it, and we should be able to check it if the line is prepared correctly. If I check for a moment the terrain, this is our river, and the flow of the river is from the right to the left, from the east to the west in Poland. Yeah, so this is Warta River. Here we have the inflow, and the water is coming here. Yeah, and the line of the river should be also prepared in such a way that the drawing started here and goes here. Because we were not preparing this line, so it's good to have a control to check if it's prepared in this way. How to check it? You should have this river center line just selected, and here you should have the option to open editing mode, to open editing in QGIS, to be able to edit. Yeah? Let's press this pen, this small pen here. Okay. If the pen is chosen, we should be able. Okay, we should be able just not create. We should be able to choose from here something what is called vertex tool. Let's choose the vertex tool for the current layer. Okay, vertex tool.
Vertex tools.
And if we just select the line, we see the vertices. Okay, let's select the line. Okay, I don't want to. Okay, so we see the line. I will select. Okay, we have the vertices chosen. Okay, how to do it? But I should see also the list of vertices. No, it's not working this way. Maybe this should not be chosen. Okay. Okay, honestly speaking, I need to find how to use this feature. Okay. Does Joanna knows what to do? Joanna knows what to do in this case?
Buat apa dia ini?
Okay, let me. Okay, one moment. Okay, it's not so simple. In the previous test, I was able to display the table of vertices. Yasia, I would like to see the table of vertices and select the vertices to see which vertex is which.
I am not also using QGIS, to be honest, but
oh, okay.
So
I know how to do it. I know how. We need to click right button in the mouse. Okay, we need to click right button in the mouse, and then we see the table of the vertices. Okay, so this is something what was missing.
Di bawah itu loh.
Okay. Should I repeat this?
Yeah, it's okay.
Okay. So we have the vertices, and we see the table of the vertices. If we select the first vertex, we should see that the first vertex is selected, and this is the vertexes in the inlet. Yeah. If we go in the table to the end and we select the last vertex, we should see that the vertex in the outlet is selected. So the line is drawn in the correct way from the inlet to the outlet. Yeah? First vertex is in the inlet, the last is in the outlet. Yeah? So this is what I wanted to check, that the direction of the line is correct. The direction of the line will be important. Generally, the directions of the lines are used to interpret the direction of the flow. Yeah? Okay. We are not going to change, so it's good to close the editing mode as quickly as it is possible when we know that everything is correct. So let's uncheck this pen.
Excuse me, Thomas, I have a question. Because in our research location that you shown us before, the water depend on the tides. It means inlet and outlet should be different in all a day. What should we do?
Okay, so we may even look at this because
Yeah.
this is good. Yeah,
Yeah.
this is the example. The water
Yeah.
depends on the tides, but the tides just cause the effect of the high water level and low water level. If we have the model of the river here, so this is the boundary condition, the downstream boundary condition, and this way we model the effect of the tides. We still assume that the tides is not causing the inflow of the water here into the river. Is it true or not?
Yes, but in the day should be mixed. Maybe
Should be
yeah.
mixed.
Yeah, should be mixed.
I think it should work correctly. I think it should work correctly if we just consider this the downstream boundary and the boundary with the different levels of the water. And this, for example, we consider inlet boundary with some flow which is just coming down. Yeah. So in this case, we should just draw the river from this side to the outlet, yeah, and should be the correct direction. Okay.
Oke, itu dua arah ya.
Oke.
Bikin kan ada pasang surut kita, lokasi kita ini kan beda. Ini cuma dari timur ke barat, selesai kan dia ngeceknya dari yang paling awal sama yang akhir. Kalau kita kan nggak bisa. Bisa yang akhir juga bisa ke belakang, bolak-balik. Pasang surut. Nggak sama kondisinya. Ya, it's okay. Yeah.
Okay.
You can continue. Yeah.
Okay. Now let's uncheck the pen in this toolbar just to stop the editing mode. We don't want to change anything, so the editing is stopped. Let's remember that we should save the project, and now let's go to the next data we have. Okay, the next data we have. The next layer I would like to add is the river banks. So I will just put into my zone. We should see that we have such small line here. These are the river banks. Yeah, these two lines. Let's change the color to something red. This is typical. Maybe we'll change to yeah, red. Okay, something like this should be okay. Okay. And then if we display the digital tree model, it should be visible. More or less, we should be able to identify the banks. Yeah. Ready?
Bisa? Bisa semua? Okay.
Okay. Let's go next to the cross sections. Let's add cross sections. And if the cross sections are not visible well, we should also change the color of the cross sections. And maybe this time we use black. We use black, maybe such a black. Okay, oh, maybe this black. Yeah, and let's make it wider, and we have the cross sections. Okay.
Okay, bisa.
So these are our cross sections, and let's add the flow paths. Flow paths will not be explained now. Will be explained a little bit later. And these are also separate lines. If I uncheck the digital tree model, I see here the flow paths. Yeah, flow paths. And one flow path is exactly like a river. So we have 3 lines. If I uncheck river, we will see the flow path, which is just hidden by the river. Yeah. Okay.
Okay.
If you need, you may change also the color of the flow paths. In the standard way, the flow paths are more or less blue. Yeah, more or less blue. So it may be blue. This is typical standard of the colors in use for the creation of the model. Yeah, model in HackRAS. Okay, so we have such layers. Okay, everybody.
Yeah.
Okay, now let's have a look here. If we click river center line and use right button, we have the access to the attribute table, to the additional information which is just added and kept with the GIS layer. So not only coordinates, but we have also some additional information. Okay, in the case of the river, additional information is the name of the river. You see. Name of the river is the Varta. We have such an attribute, and we will just care about this attribute later in HackRAS. Okay. Let's have a look in the river banks. What are the attributes? So let's open the attribute table. We have the additional attribute which is called tape. and we have two lines. One line is called right, the second is called left, like left bank, right bank. So this is exactly what it means. Yeah. Okay. Now let's have a look in the cross sections. In the cross sections, we have attributes, additional information, which is called section number. So all cross sections has generally its numbers. Yeah. So each cross section has some number. So we may use these numbers a little bit later. Okay. And in the case of the flow paths, and this is quite important because attributes will be necessary for us. In the case of the flow paths, we have also attribute tape, which let us to distinguish between the line which is in the channel and lines which are in the left flat plane and right flat plane. Yeah. If you select them in the table, they are also selected in the map, so you see which is which. Yeah.
Bisa ngikuti?
Okay.
Yeah, okay.
Okay, and remember I mentioned it now that in the HECRAS we need only left and right flow paths, but not channel, and we need to reduce the flow paths important in the HECRAS. But we will just make it later. It should be clear. Here we have also the option to deselect all, just to see this picture without selection in the map. Okay, everything clear?
Ada yang mau tanya? Bisa ikuti?
Okay.
Mik, second, mik, kemudian kasih Rifandi. Nggak ada. Bisa? Coba.
I have a question about the projection.
Projection.
Can you hear?
Oh yes, I hear projection. Projection, we checked projection at the beginning of our work with QGIS. When we added digital 3D model, the projection in the project was set to the projection of the digital 3D model, the first layer. Projection may be checked here in the right bottom corner. We have EPSG code. Yeah, EPSG code. If we click on this code, we have the information about the projection. Projection is Poland CS92. This is one of the coordinate systems used in Poland.
Sorry, not the project.
Ngomong apa kamu?
About the projection.
Cross section.
Cross section. Okay. And what about cross section?
Huh? Oh, he want to know how to determine the distance between the cross section.
Okay, so this is the question which is going further, because the flow paths are exactly for this purpose. These lines I wanted to explain when we just import them to the HECRAS. You should remember that in the first exercise we needed to define the distances between the cross sections. This time we use the flow paths. We import the flow paths to HECRAS because HECRAS is able to calculate the distances along the flow paths, and the flow paths are exactly for this purpose. Yeah? So flow paths will be used in HECRAS to define the distances between the cross section. Okay. Unless you want to measure it in the map now. So now we should be able to find, not calculator, measure. We have measure here. Yeah. If you want to measure distances in the map in the QGIS, this tool might be used. Yeah.
Can I ask you something?
Okay.
It is the lines is measures, or we did automatically based on the
if we talk about the cross sections and the building of the model, the distances will be calculated automatically in the HECRAS just in a moment when we start importing. But very important for the proper calculation of the distances is the direction of the lines. If the lines in the opposite direction, the distances are calculated with the negative values. So it caused the error. So this is why I cared about the direction of the line at the beginning, the direction of the river, but also the direction of the flow path should be in the direction of the flow. No?
Ya, kebayang nggak? What second, Thomas, I will explain to my student. Jadi ini ada riverbank. Riverbank itu sungai yang batas-batas ujung kiri kanan. Jadi cara ngelihatnya dari mana? Cara ngelihatnya itu dari yang tadi dari 0 ke 1 yang bawah paling atas. Jadi kan alirnya ngalir gitu tadi ya, air sungainya. Nah, jadi cara membayangkannya, ngelihatnya kita dari bawah gitu. Jadi air ngalir. Jadi mana yang kanannya, mana yang kirinya riverbank itu, batas sungainya. Gitu ya. Jadi jalan, riverbanknya itu di situ jalan, terus cross section datangnya dari mana, itu otomatis. Jadi ada flow path tadi dari hackrasnya. Ya, bisa ngikuti? Paham ya? Jadi caranya itu otomatis dari hackrasnya. Oke, gitu ya. Oke, you can continue, Thomas.
Okay, I would like to say also one thing before we start working with Hackers. Now we have some layers which are ready, which are prepared for this project, but I would like to prepare separate data for all of you and leave the problem of creation of these layers as a homework. Okay, so I will give you the opportunity to prepare such a layers, but this is time-consuming procedure. So supposedly we will leave it for 1 week and check during the next meeting what is the result of your processing. Okay, but for the preparation of the model in Hackras, we need to have such layers ready and prepared in GIS software. You know? So at the moment we assume that these layers, these lines are ready. But later I let you also to prepare such lines to work with the pure data in QGIS, just drawing the lines and preparing the model. Okay, but this is a little bit longer task, longer exercise. So it will not be effective to make it now during the classes. Now we assume that we have these layers, and later you just try to prepare them. Okay. Okay, so we have such a layers. We may also notice one thing. It's quite important to look at the cross sections. The cross sections are the most this is important information in QGIS. You should notice that the cross sections are normal in the 90 degrees to the river, more or less, because this is these are natural data, so they are never exactly 90%, 90 degrees, but we try to keep them in this way. They should be also normal to the river valley, not only the river channel, but also to the river valley. Sometimes it requires that the cross sections need to be broken. This cross section is broken also because of this tributary. The tributaries should not be crossed by the cross sections, but should generally represent the information in the single river with the single valley of the river. Yeah. So this is the idea of the cross section. The cross sections should be also prepared in such a way that they start on the left bank. In this case, this is the left bank, and end in the right bank. Yeah. And in the right bank. So remember about this rule. This will be necessary for your separate task. And we should also remember, if you look at the cross sections start in high zone on the left bank and end in another zone, high zone on the right bank. So we have such a valley in between. So the water may be collected and kept inside. So none of the zones should be open. No, should be open. Should end in the low zone, but should just end in some higher ground. Okay. So this is important to remember about this. Sometimes we have also such a situation that if we have a dike, we may stop the cross section on a dike. Yeah. So if you do not predict the overtopping of the dike, it's okay. If the dike is overtop, we should model this area with separate two-dimensional model, for example. Yeah. So at this moment, this is correct approach that the cross section is finished in the dike. Yeah? And one more time, we start the model we start building very simple model. So we avoid creation of the bridges at the moment. So in the place of the bridges, we have only cross sections. But generally, in more advanced model, the bridges should be modeled as a bridges. So here we should have bridges, and always we should remember that one cross section should be upstream of the bridge and one cross section should be downstream of the bridge. Yeah. So this is also the rule. If we have a bridges, we should take care about the bridges, and the bridges should be modeled in this way. Not only bridges, also inline structures. Also inline structures should be treated in this way. Okay. Okay, so for the moment it's enough. We may also notice one thing, because the bathymetry is interpolated. At the ends of the bathymetries, we may have a problem that the values are not correct, and you see here that there are some disturbances, some obstacles here. In HECRAS, we simply move this cross section inside this zone, just to avoid this problem. Yeah, and we are going to do the same with the cross section here. It should not be located exactly at the end, but just move inside the ridge, yeah, to avoid all the disturbances in the end, which are caused by the wrong interpolation.
Yeah.
Okay. Should I explain something more?
It's enough. Good.
It's enough. Okay. Let's save the project in the QGIS, and in this moment we just minimize this project, come back to the main window, generate to the desktop, to the tower folder, and we may just click on the HECRAS 6.5 or any version of the HECRAS you have. I have icon here. If the icon is not here, we should go to the start menu and find HEC in the start menu and start working with HECRAS. Okay. So let's open HECRAS. In HECRAS, if HECRAS is open, we always look here in the unit system. In the unit system, the unit system should be SI units. Everybody see SI units?
Okay, yes.
SI units here.
Yeah.
Yes, it's already.
Tropica, do you see SI units? You are muted. You are muted.
No, I don't have SI units.
SI units.
US
After the installation,
units I have.
US customary. Okay. In the options, just look at the options. The tiered option unit system is for change of the unit system, and change it for the system international. This is typical for Europe, you know, system international, and check this option set as default for new projects to have it as a default option for new projects. Okay, and press OK, press OK, and every new project should start with SI units. Okay.
Yes.
Ready? Okay. Yes. Now let's start working with HECRAS. Work with HECRAS just starts with the file new project. File new project. File new project. We should create the project in our folder. So we need to find this folder. Maybe we should change the disk if this is necessary. We should just go to the proper location. Open the proper location. Okay. Now we should give some title to our project. I will call it Model 01. It should be okay for me. Okay. Model, you should look at the file name. So the file name is the same like a title with the extension PRG. Yeah, PRG. Okay. Let's press OK if everything is correct. Project should start. This is the window to confirm the settings. And we should see in the first line the title of the project and the location of the project. Yeah? Location of the project. Here we have the file Model 01 with extension PRG. Everybody see this extension PRG? Okay, it's okay. We should also look at the data folder, because we have also here some files with the extension PRG, but these are different files. PRG here means project. In the data, in the shapefile, PRG means projection. So this is coordinate system. No? So take care about it, because this difference is important for us also when we choose the next files. Okay. Okay. So let's stay here. Now We have HECRAS, we started project. Last time, we just went to edit and geometric data to prepare geometric data in this way. We are not going to do it this way now because we have some GIS data. So we start with GIS tools, okay? We go to the GIS tools now and we choose RAS Mapper.
RAS Mapper.
RAS Mapper. RAS Mapper. Let's open RAS Mapper, and this is separate GIS module, which is just part of the HECRAS system. Yeah, HECRAS system. You see the zone for mapping, for maps. You see the zone with the layers. Layers will be just displayed here, added to these elements, and we have some zone for additional information. Yeah, so additional messages, parameters, and so on. Yeah, clear? Okay, we should start with definition of the projection because this software is not working yet like a typical GIS software. So we need to define projection at the beginning when we start. Let's go here to project, and we have the option set projection. Project and set projection. Okay. Project and set projection. And this window, you should see this window, okay? Now,
okay.
we should just find the file with the correct projection, proper projection for our project. So here we should just select the file for this cell. Of course, the first option should be selected on the left, projection. Let's press this button on the right, and you should see your folder where the project is defined. We are not going to choose this PRG because I just told you that this is wrong PRG. This is PRG of the project. We go to the data folder, and we should see here the projections of our shape files, of our lines. All of them are the same, so it does not matter which of them is chosen. Yeah, please select one of them, any you want. Yeah, and press open. And press open. And press open. And you should see the content of this file. This is the definition of the projection, exactly the same coordinate system as previously, Poland CS92. You see? Okay. If you are ready, you may press OK. And projection is selected for our RAS mapper. At the moment, and from time to time, you may save. In file, you may save. This save produces new file in your folder with the extension RAS map. So all the information is stored here. All the information about the mapping, is stored here in the RAS map. But let's come back to the RAS mapper. Ready?
Saya ngikuti. Yeah.
Okay, let's now select terrain. We will create terrain for our model. It's not exactly digital terrain model because we need to have digital terrain model and transform it into the format which is used in the HECRAS. So this is the idea. Let's select the section terrain and click right button here. And let's choose the option create new RAS terrain. We will create new RAS terrain, okay? Let's choose this option. And you should see this window. Ready?
Udah? Yes.
Okay. Now, we may add several layers to create one terrain, just to combine them. These are the buttons which are used. Add, plus, and remove this cross. Yeah, and we can also move the layers up, down. It is necessary when we have overlapping layers where the information might be read from different layers, and we need to define what is the sequence of reading the information. We will use only one, so it's not important at this moment. Let's choose this plus. Let's choose this plus. You should see the folder of our project. Let's go to the data and we should see only one file which is ready, which is correct to build the terrain, and this is our digital terrain model TIFF, DTM TIFF. Yeah, let's select it. Ready? Okay, let's press open, and this file should appear here. Should appear here, and we are almost ready. You may only check this file name. You see that the terrain will be created in the folder terrain in the file terrain HDF. HDF is a specific format, so-called hierarchical data format, and might be read by the specific software. It's generally this conversion is done because HDF files are faster in the processing. So hackers using this use this feature just to make computations more effective. You know? So this is why we use why hackers uses this format. Okay. Ready? Everything?
Yeah.
Let's press create. And now the processing takes some time, but should be rather fast because the digital terrain model is not
Ini buat
large.
layar ya. Buat. Kamu gimana?
Okay, and after 7 steps, you should see something like this. When I close, I see my digital terrain model in the specific colors in HackRAS. Yeah? Do you see it?
Yeah. And so the yes, okay.
Okay. Okay. Now, of course, let's save. Let's save it, and let's go to the geometries. Geometries here, the second options. Let's choose the right button, and we have 2 options: create new geometry and import geometry. We will create new. Okay, so we'll create new. You know, let's choose this option. We should call our geometry maybe geom001 or whatever name you want. Okay, and let's press OK. Let's press OK. At the beginning, HackRAS is asking about assignment of the terrain to the geometry. Terrain will be used just to read the elevations. If we have some land cover layers, we may also assign them just to determine the roughness, but we don't have any, so this is empty basically. Yeah. So this in this window, in the most cases, we should just confirm, or if we have different terrains, we may change the terrain. Yeah, but now we have one, so it's okay. The choice is done, and we should only close this window. Yeah? Okay, now our geometry is empty, and I would like to import the information I have, the information which is stored in the GIS layers. So I should start editing of the geometry. Editing is done when we select the geometry with this button here, with this icon, start editing, as you see. Or this option, if I click right button, is also available here. Yeah, edit geometry. Yeah, so whatever you use, just start editing geometry. Ready? And this is the list of possible layers, possible options. Of course, we are not going to use all of them, but only some of them. But this is what we can do. Yeah, this is what we can do in HackRAS. Let's select first reverse. Okay, and let's select reverse. Let's check and select. Okay. If this is the option just to create river, we may use this tool just to draw river in a HackRAS. It is possible, but we have the line of the river, so I don't want to draw the line here and spend time on preparation of each line. So I click right button on the rivers here. And you should see, in any case, for any layer, we have such an option: import features. Import features, okay? Let's choose it. Let's choose import features. And this window is also common in HackRAS for importing of the information, especially from the GIS layers. we should choose proper file name, which stores our line of the river, the center line of the river. Okay. Do you see this window?
Yes.
Okay, let's press the button on the right for the folder. We open the folder in the Windows. We should go to the data. We should go to the data. And in the data, you see four shape files, and the river, of course, is river centerline. These files were used before in the QGIS, and these are exactly the same data. So let's select river centerline. Let's press open. And the river is drawn here. The available options are presented in the map. Here we have the list of the attributes. Some attributes were not displayed in the QGIS, but it's okay. We need the attribute name to select properly the river we want to choose. Yeah, so this is the Varta River, and I would like to also transfer this attribute to like a name of the river to my model. Yeah, like a name of the river to my model. Okay. I don't have separate attribute for reach, so this place may stay known, so the automatic name will be given. So it's not a problem that we don't have the name, that the HECRAS just select his own name. Okay. And at this moment, when Varta is selected, here we have the name. We may press import. We may press import.
Cool.
Okay, and the river should be added to our view, to our map. Okay. Okay, now let's go further. Just let's press this cross close to the river. We should see that we may add something to the river. We may add bank lines first. Bank lines, okay. Let's select bank lines, and the procedure is exactly the same. Let's click right button and let's go to import features. Import features. We see a similar window. We see similar window, and we should just go to this button on the right. Click this button, and let's go to the data. Okay, let's go to the data. You remember that our banks, this is the file river banks. It's called river banks. Okay, this time let's select river banks. Should I repeat something?
Apa? Bank itu pinggiran sungai. Ya, ya tadi kan di overlay, keluar sungainya dulu. Dia tadi kan diimpor, jadinya enggak ada, jadi ada gitu. Mau pengen datangnya dari mana? Oh yeah, my student have a question. What is the source? Do you got the information about the figure? Look like a river, gitu ya? Lines.
Okay. Source, generally we use QGIS to display the information, but these layers were prepared manually. I just draw them in the QGIS. I prepared them in the QGIS.
Okay.
I will let you to do the same as a homework, okay? Because I told you that this is really long exercise, yeah? So such layers needs to be prepared by the modeler, but it takes time. It takes time, so it's better to leave it as a homework and later try this data, yeah? This data, your own data in the new model, okay?
Yeah, okay.
Okay, so at the moment, we also have the option in HECRAS just to draw the lines manually, but once again, it will take time. So if the lines are prepared, you just see what kind of the layers are necessary to prepare the model, and then we may focus on the more heavy procedure, just drawing them and preparing step by step what is maybe not so inventive, but gives you the contact with the real work. Okay.
Yeah, okay.
Okay, so at the moment, let's choose riverbanks. Okay, can we? Riverbanks to import them. So let's press open, and you should see also that some lines were added. it's good to now to select the proper attribute which let us to identify our lines. So I change the attribute here to tape and press this button select all, because both lines should be selected if you want to import them. Yeah? So both of them should be selected. We may use the button select all. Okay, and at this moment we may press import. We may press import. Okay, let's press import. And you should see that the banks are also here. No, also here. Okay.
Bisa?
Okay. Now I like to import next as a next layer the cross sections, because this is the standard method, standard sequence when we prepare the layers. So we start with the river, with the banks, cross sections, and at the end we draw the path lines. Yeah. So now let's go to the cross section. Okay. Cross section. Let's click right button on the cross section and let's go to import features once again. Import features, and of course once again we should go to the data folder and select cross sections. So let's press the button on the right, and let's go to the data, and we have the file which is called cross sections. Yeah? Cross sections. Let's press open, and you see that some cross sections are added. Now let's change the attribute to section number, because we know that this is the number of the section. And we see the numbers of the cross sections. Sometimes we can just select some of them, remove others, so we can handle this. But in this moment, I would like to select all. So I press select all, and this is everything what I want to do. I don't want to import the attributes. I prefer just the attributes to be calculated automatically by HECRAS. So I select only here the section number. Okay. If we are ready, we may press import. And you should see the cross sections in your model. No? Okay. Okay. Can we go further?
Yes.
Okay.
Of course.
Okay. And the last line, flow paths. Let's select flow paths. Let's press right button. Let's go to import features. Let's go to the data folder like previously. And we should select potential flow paths. Okay. Let's press open. Okay, we have 3 flow paths because it was the standard of the previous versions of the HECRAS that the flow path for the river was also created. In the new version of the HECRAS, the flow path for the river is not necessary, and if we import this, it will cause an error. So we need to identify this line and simply just omit this line. So let's change the attributes to the tape. This is quite easy because now we have the names: channel, left, right. You know? So only left, right with the control button should be selected. If you press control and just use the mouse, you may select 2 of them and leave channel not selected. Okay. And if you select left, right, you may press import. And you should also see left, right flow path in your model. Okay. The flow paths are the most critical when you prepare the lines. In general, idea is such that we draw the flow paths through the center of the wing, left, right, may more or less through the center. So this is the idea. Okay, I'm sorry for a moment. Okay, just short break. Okay.
Masih bisa ngikuti?
Okay. Okay, I'm back. Okay, we can continue. Okay, so this is the general idea for the flow paths. Flow paths are ready, so we may just go further. Okay, everything clear? Okay, so for a moment, this is not the end, but we will finish at the moment because I want to show you the geometry which was prepared in our in HECRAS, how it looks in geometric data. To explain other elements, it would be good to see the difference between this stage and the next stage. Yeah. So at the moment, if you want to finish the editing, we should use this button, this icon here, stop editing. Okay. And if we press this button, HECRAS asks us if we want to save the edits. Of course, we won't. Up to now, this is the only option where the edits are saved. So you should be careful just to press yes here, not to lose your job. Yeah. So it's good to remember about it. Yeah. And you see that our geometry now is not empty. It's not empty. We have the geometry. This is displayed in the map, and the geometry also presented here is not empty. Okay. Let's remember that we should save RasMapper, and at the moment, for a moment, we may close RasMapper. Okay, we may close RasMapper. Okay, let's close RasMapper and let's come back to the main window of the HECRAS. Here in the main window of the HECRAS, you do not see the geometry, but it does not mean that the geometry does not exist. If we go to edit and open geometric data, the standard editor for geometry, you see the digital 3D model, but the geometry still is not here. To see our geometry, we should go to File and use Open Geometry Data. And we see that we have some geometry in the project, but the geometry is still not active. So we need to choose it and press OK. Yeah? And press OK, and geometry is loaded. Ready?
Yeah.
Okay. In the geometry, we see the line of the river and the lines of the cross sections, but some information is missing. And if we press cross section on the left, we should see that we don't really have cross sections. Don't really have the information about the cross sections. We have only the information about the distances. And here, what we see here is not the cross section. It's only the terrain in the location of our cross section. Yeah? So some information should be uploaded to the geometry from the digital 3D model. So this is important, and this is what I wanted to show you, why the computations which we are going to do are so important. Without these computations, the geometry does not exist really. Okay. So let's close it. We see that it's not ready. We may of course save the geometry and close. The geometry is activated. Yeah, but we have to come back to the RasMapper. Okay, and this is our review in the RasMapper. Yeah. Now in the RasMapper, let's select geometry once again, and let's press right button and use the option Edit Geometry. We should come back to the editing mode. Yeah? To the editing mode. And we have the geometry open for editing like previously. All the possible options are ready, but we are not going to add any layer. I would like to focus on the right button menu for each layer. Okay, let's open on the river. In the river, we don't see any specific, but if we go to the banks, we see this kind of the options with this lighting. Yeah, this lighting. This means the recalculation of the parameters of this layer. So up the bank stations let us to calculate the points where the bank stations are located. Yeah. So let's choose it. Let's choose it. You see here the information that the bank stations were computed. Yeah. Now, if we go to the flow paths, we have similar option. Just update reach lengths, recalculate the lengths between the cross sections. Yeah, let's choose it. The calculation was done, and the large number of the options is here in the cross section. We have also update cross sections, but here we have the options which are available. There are several parameters which should be calculated for the cross sections. These parameters, strictly geometric parameters, might be just done with this option. All cross-section attributes. Yeah? So let's choose this option first. So you see the river stations are recalculated, but it's not the end. We need to use also this option in the second group, read elevation from the terrain. So the elevation is from the terrain is taken just to define the shape of the cross section. Yeah. So the first option from this group, because we would like to take the terrain for each part for the entire cross section in each case. So let's choose this option. And after this option, we are really ready to close editing, to save the edits, of course, and come back to geometry. Okay. Okay. So if you just finish with this option here, with this option, you may just press this red dot here, red dot, and confirm that you want to save your editing. Okay. Let's save. Let's save and let's close. Let's close RAS mapper, and let's open geometric data. Let's open geometric data. Okay. This is our geometric data. Now it looks a little bit different because you see bank points. Bank points denoted as these red points for each cross section are here. Yeah, are here. So if I use shift, we should see we have these red dots in banks. Yeah, so banks are identified on the basis of the bank lines. Yeah, so the shift let us to move the map. Okay. Let's go. Let's open cross sections. Let's open cross sections. We see something like this. So the cross section is defined. We see the points of the cross section, and these points are exactly along the terrain. So this is current terrain, and this is our ground in the cross section. Yeah, exactly the same. What means also that the number of points is really large. We should reduce this because this is too much points. We don't need so many points in the shape of the cross section. Yeah. So this is one of the modifications we have to make. Another modification is also very important. You see that we don't have the roughness values because HECRAS by default wants to read the roughness values from the information about the land cover. In our project, there is no land cover because I would like to make a simple model. So we need to come back to the previous option just to define the roughness in the channel and roughness in the flat planes. Yeah. So we need to just correct this option and remove this column from our cross section. And this will be the first modification we are going to do. Okay. So let's close cross section for a moment. And for this moment, let's have a look at the tables. I am not sure, but previously we used the tables. No, I think not. This is the first time we open the tables. Yeah, tables, and the first table which is available is here is the Manning and values. Manning and values is basically the roughness of the surface, of the bottom surface, which defines the friction for the flow. Yeah. So let's use this option, Manning and values. And this is what we see. This is the table we have. Each row in a table is a cross section, separate cross section. And this means that we are not able to define the values now because the values are still read from the land cover. To change it, we should select all cross sections, just clicking on the left top corner. Yeah? Click on the left top corner and all rows are selected. And use this button, reduce to left channel right. Yeah, to the 3 zones, left channel right. Okay, so select all and press this button. Of course, I want to do it. And you see that you have 3 columns open. First is for the left, second for the channel, and third for the right. Yeah? Okay.
Kiri, tengah, kanan.
Everybody?
Yeah.
Okay, now let's select the middle column for the channel. Let's select it. And we just set one roughness coefficient for the channel using this button, set values. Set values. Okay, let's press it and just let's write 0.025. This is typical for the sand beds in Poland, 0.025. So we may use it. Okay.
Sama. Punya Michelle tadi ya, Michelle.
Okay. If you are ready,
Yeah.
you may press OK. And you should see that all roughness in the middle column are the same, and this is the value you just selected. Yeah. On the left, let's select in the same way. Let's select the value which will represent some grass, some bushes, so maybe 0.045. Yeah, 0.045. Here you see the value selected for the left.
Ada rumput kiri kanan.
Okay, and let's press OK. And on the right, you may select the same value, like for the left, or something similar. So it's up to you. Maybe I will change a little bit because these settings are simplified for simplified model. So we don't need to care much about it. So I select 0.045. Yeah. Okay. Okay. And let's press OK. Let's press OK. Let's press OK. Now, remember to save geometry. In the file, you have saved geometry. And we may open cross-section, and we should see the change. We don't have the column for the roughness, but we have the roughness defined here, yeah, in each cross-section.
Yeah.
Okay. Okay. So this is done. The first modification is good for us. Now let's reduce the number of points. The number of points, hackers generally accept 500 points in cross section, but it's too much generally and makes the computation longer. So it's better to reduce it. Okay. To this kind of manipulation, to this kind of changes, we have some tools in the menu tools. Okay. In the menu tools, we have the tools. You should remember the interpolation of the cross sections from the previous class. But now I would like to use this option, cross section point filter. This option, cross section point filter. Okay. Cross section point filter. Let's open it. And this is the window for cross section, for filtering of points in the cross section. Okay.
Yeah.
We have two tabs, single location and multiple location. I don't want to reduce in section by section. I would like to make it for all cross sections in my reach. So I go to the tab multiple locations. Okay. Now I can select the cross sections here, but I prefer to select all of them. So I stay with the first option, all RS, and just press the arrow to have the list of the selected cross sections. Yeah? Ready?
Yeah.
Okay. Now here in the bottom, I have two options. Near and collinear filter is a little bit more complex. The second is just simpler. We need to give the expected number of points. So 100 is enough. And the change of the shape will be done in such a way the cross-section area is more or less similar to the original. Yeah. So generally it's something what we can accept. Yeah. So the second tab here and the number of points is 100. Ready?
Yeah.
If you are ready, let's press filter points. And you should get such an information. What was the original number of points? What is the number of new points? And how many points were removed, reduced? Okay. If ready, just press close. Remember to press here OK, because in this moment you confirm this operation. The reduction is still not done. You only get the information about how it will be done. But if you press OK, the reduction will be really done. Okay. Now, if you look at the cross section, any cross section, you should see small changes. Especially if you zoom, you should remember that if I press right button here, I can zoom. You see the difference between the terrain and the difference between the shape of the cross section. Yeah? This is cross section and this is the terrain. You see that the shape of the cross section is good. It's good enough for the hydraulic computations. Yeah? For the hydraulic computations, if we use full plot, we see the entire cross section. Okay. Do you understand these steps?
Ya, beda terrain sama apa?
Okay. Okay. Any questions? No. Okay. Let's close it. Okay. Let's close it. Let's save the geometric data, because geometric data at this moment are more or less ready. I told you that we should shift the first and the last cross section, but at the moment we leave them. There should be some small errors at the beginning and at the end, but we just correct it later, because all the procedures are automatic. We can make such corrections a little bit later. So now we are not going to just to take care about it. Okay. So for the moment we consider the geometry to be ready. Yeah. So if this is saved, we may close it and we come back to the main window of the HECRAS. It's time to compute something. Are you ready?
Yeah.
If you want something to be repeated, to be answered, it's good time also before we just go to the next step.
Ada yang mau tanya? Okay. It's enough.
Okay.
Yeah.
I would like to remind you also one thing. If we go to the YouTube channel, we have the channel HECRAS na UPP. Na UPP, this channel with the videos of the exercises. This what we are doing today is presented in this video. 08 RAS mapper to geometry. Yeah? But this is done with the ArcGIS. So the GIS part is a little bit different, but generally should be also clear. And okay, in this part we have the ArcGIS. So these two videos are this what generally is the content, the additional information for our exercise. Okay, so 08, 09, these two videos may be used later when we want to repeat this exercise. Okay. Now let's focus on the main HECRAS window. You remember that the next time when the geometry was ready, we just went to the edit and steady flow data, and we are going the same. We are going to navigate the same way, the same direction now. So let's open edit and steady flow data. Yeah, edit and steady flow data. Now we have the window for steady flow data, and here we should define the discharges. The discharges, you remember that here we just put the value in cubic meters per second for the reach. I would like to make not one profile, but 3 at the same time. So I change this number here, the number of the profiles. And if I press apply data, I have the space for 3 data instead of 1. Yeah? 3 data, 3 discharges. Okay? Ready?
Ya, saya ikuti. Sudah.
Okay, let's now select the first one. The first one, as I remember, this is not the exact value of any specific discharge, but let's for the test use 350. Okay.
Sorry.
For this river, it's
again, if it's possible.
Okay. Again, let's make it again. I will just come back to the stage, previous stage. We started with edit steady flow data. Edit steady flow data. Here we change the number of the profiles from 1 to 3. Okay, and here we see the number of calculated profiles, number of calculated inundation maps. In fact, should I repeat something more?
Yeah.
Okay, and first data is 350. Second, let's make it twice, 700. And let's multiply it once again, 1,400. Okay, so this is relatively low flow for this reach, and this flow is about 100 flat. So we have quite nice range of the flows for testing for our reach. Okay, let's remember to use file save flow data. File save flow data, and let's call it data flow data 01 or something like this. Okay.
Datang dari mana angkanya?
Okay. Can we go?
Okay.
Next step. Let's press OK. And now the discharges are defined, but we need to define boundary condition. You remember from the previous exercise, we need to use this button, reach boundary conditions, and go to this option. Yeah. Ready?
Ya, bisa ikuti. Yeah.
Okay. Now we may use the option in the top. If we change, we may define the boundary condition for each profile separately. But at this moment, I would like to set one common boundary condition for all profiles, the same for all of them. Yeah. So I will keep the option here just checked. Okay. Now, boundary condition I would like to impose here is not known water surface like previously, but I assume that the outflow from my reach is just free. So I use the condition which is called normal depth. Normal depth. Okay. This condition, we should also remember that the condition should be imposed for the downstream, not for the upstream. Yeah, only for the downstream. It's affect the flow regime in the reach, and we want to simulate the subcritical flow regime. So we generally set the condition for the downstream in such case. Yeah. So let's select downstream. Let's press normal depth, and here we need to just provide the bottom slope for the downstream cross section. I don't really know this bottom slope. We can check in the geometry, but I don't want to do it. I just put here the average bottom slope for a lowland rivers in Poland, just to value which is close enough. Okay, so this is what I'm just going to write here. For our test, it's enough, and this is the bottom slope. We'll just test. If you want to have more accurate data, we should just check this slope in the geometry. Do you see it?
Yeah, the same.
Okay, so please write it and press OK. Write it and press OK. Let me come back to the previous view. Okay, so the normal depth should be chosen here. Okay. Okay, and if you are ready, we may press OK. We may press OK. And we should remember about saving flow data. Okay, saving flow data. Okay. Okay, let's close this window because the data are ready for computations. Let's go to run like previously. Now we are going to start computations. Yeah, in run. We should choose steady flow analysis because we have the data for steady flow analysis. So let's choose it. Steady flow analysis. This is the window of the computational plan. So we need to start creating new plan, file new plan, like a new simulation. File new plan. We should give the name to our plan. Plan 01, for example. If we press OK, we should give the short identifier of our plan, P01, for example. Yeah. So such names should be defined. If I press OK, I see the name here and the short ID here. Yeah. Short ID is important because short ID appear later in the results windows. So this is the method to identify the results. Yeah. Okay, so we have the geometry file just selected. We have the steady flow data selected. Flow regime is subcritical and boundary condition is downstream. So it's correct. Yeah, so this approach is correct. So we can just remember about saving plan and we may press compute. We may press compute. We may press compute. And if everything is correct, after a short time, you should see the result that the computations just stopped. Yeah. Okay. Okay, let's close, everybody.
Yeah, bisa.
Okay, let's close this window. Let's close computational plan. And you remember that the first view of the results is very simple. We should go to the view and look at the water surface profile. Water surface profile to be sure that everything is correct in our view. If your legend may looks different, so if it looks different, let's go to the options and the variables. in the variables, check it. The first two options should be checked to see the banks. These are the bank lines. So this is useful information for us. Water surface, this is also something what we want to see, and filled in water surface, this is this blue color, which represent the water. And the next two options, energy grade line and critical depth, may be unchecked. We don't want to see these lines, these are not necessary to interpret the results, okay? So just check if this is correct. First four options selected, next two unselected, and the rest is not important now because we don't have the data for the rest. Yeah. Okay, and we see the first profile. The reach is rather short, so the profile is not impressive. We just focus on the maps. The maps will give us better information. But I would like to see also other profiles, and to change the profile, I need to use this button, profile. Yeah. And I can select profile number 2, profile number 3. If they are not displayed correctly, I can click right button and use full plot. Okay, so you see larger discharge, larger water surface. Yeah, so higher water surface. Okay, correct?
Correct. Bisa,
okay,
gitu.
So this is first check. Let's close it because this is not, as I said, it's not very impressive. Better view of the results now is in the RAS mapper. We may look at the maps, in the maps of the inundation. So let's come back to the RAS mapper. Yeah? Let's come back to the RAS mapper. And this is what we have in the RAS mapper. The previous view of the geometry. And now I would like to uncheck geometry. I don't want to see geometry. But you should see that we have new folder here, which is called results. And in the results, we have some results. You know, after computations, the results are not empty, are ready to be displayed. Let's select the plan P01. We have the short ID here, P01. And let's select in this plan, the depth of the profile number 1. You see the map of the depth just presented here. We can zoom to some specific zones. We see that some areas are inundated. Some quite interesting results are obtained here, where we have the tributary with the lower zone, and this is also interpreted as inundated. Yeah, as inundated. But we should also notice that we have some a little bit difficult to interpret zones like this one, where the water is outside of the river. These are some misinterpretations which should be corrected in the GIS software. Why we see this? Because if you just compare, here we have also the geometry. If you compare with the location of the cross sections, we realize that this map is produced by the interpolation of the water surface between cross sections. So if this zone is below the water surface in the cross section, this is interpreted as being inundated. But of course, it should not be inundated because the water is here in the river. Yeah. So some errors still exist in this map. So this is why we need also GIS software to correct such cases, such errors. Yeah. Okay. Now I will just uncheck the geometry, and I would like to add the next maps, the profile number 2 and profile number 3. But I would like to know if you have any questions now.
Ada pertanyaan? No, still no.
Okay, let's add the other profiles, because by default only the first profile is displayed. So let's select the computational plan, the name of the computational plan, and let's click right button here. Okay. We have the menu with the option create new results map layer. Create new results map layer. Let's select it. This is the window for adding results to our map. Let's select depth. In the hydraulics, we have the depth. Yeah. And here we have the profiles which might be displayed. So let's select PF2, profile number 2, because the first exists in the map. So we now want to display the number 2. Okay. And if number 2 is displayed, we may press add map for a moment, we do not care much about these options. We leave them default, so we only press add map. Add map. And you should see, if I close, you should see, and I uncheck the PF1. This is the map for the second profile. We remember that the first was produced for 350 cubic meters per second. The second was created for the greater discharge, 700 cubic meters per second, and inundation zone is greater. Yeah, is greater in this case. Okay. And now let's come back to the name of the computational plan. Let's click right button and let's go to create a new results map. Just to add the last profile, so let's select depth and let's choose PF3. PF3. And let's press add map. Add map. And this one is the greatest, as you see, the greatest profile with the greatest inundation zone produced on the basis of the computations. Okay. In each case, we still have a problem in the RAS mapper. For example, this is typical for this kind of the computations that we see the water just beyond the dikes. This is the effect. This is the effect of interpolation between the cross sections. You know, exactly linear interpolation is used. So this kind of the elements should be corrected in QGIS, for example. This is why we also need QGIS in the post-processing phase. Yeah, this is also an example. We have a dikes and the water in between without connection with the river. Yeah? So this map is still not perfect, but you have the view, the insight, what can be the inundation in the model zone, you know, in the investigated zone. Okay. Okay, let's save RAS mapper. And at the moment, I would like to show you only, I think it's a good idea because the huge content was presented. So maybe we will show only how to save this single inundation map to the disk and move it to the QGIS. Okay. Can we do it? Yeah.
Yeah. Okay.
Okay. So how to save single inundation map to the disk? Let's select maybe profile number 2, or okay, you can select any you want. Okay, just select any you want. I want to choose PF2 or PF3 because I see many such elements which should be reduced in QGIS. In the profile number 1, the number of this kind of elements is not large, so PF1 is not very interesting. So maybe PF2 or PF3. Okay. Now, if we select the map we would like to move to the disk, we should just click right button on this map. We should select it and click the right button and use the option edit map parameters. Edit map parameters. Okay. And we come back to this window, which let us to add the results to the map. And now we focus on this on these options. Yeah, on these options. Here you see that the first option which is selected is to generate the raster to memory. Yeah, to memory. So the raster is still saved in HDF file. A specific algorithm just translate it to be displayed in the RAS mapper. The second group of options is to save to disk. Save to disk. So we produce the raster in a disk using these options. So let's use the raster based on terrain. The first option, and the terrain should be selected here also. Yeah. And now we may press save map. Okay. So this option raster based on terrain, and then we press save map. Okay. Let's make it. And the map vanished. It's not error, it's correct, because you see here the disk icon, which suggests that the map is in the disk. But if you see this red star, it means that the map should be recalculated to be really stored in the disk. Yeah. So if you see this map with the disk, press right button, and you have the option here, compute update. Use this option. Okay, use this option, compute update, to recalculate the map. and after a short time, you see your map once again. Yeah? After short time, you see your map once again. Okay. And if you look at your folder, one microphone should be muted because I hear my voice in my headphones. Okay. Okay. If you look at your folder, maybe I will use the list. You have new subfolder here with which is called like the short ID of the computational plan, and in this folder our map just exists. Yeah, this is the place where the map is saved. Yeah, okay.
Yeah.
It's correct. Okay. Now let's save RasMapper and let's come back to QGIS. QGIS. Yeah. QGIS. Now, in the project home, we also can see this folder PO1. Here we see the depth map, yeah, based on the terrain, and we may basically move it to our project. And the map is ready to be processed, to be changed, to be handled, in QGIS. Okay. Okay, and at this moment, because we have more than 2 hours of the class, and so this is a little bit exhausting. Maybe it's good time to have a break, to stop and come back to this during the next meeting. What do you think?
Iya, udah nggak kuat ya.
Yeah. Okay,
Yes.
it's enough. It's enough for today. Yeah.
Yeah. Okay.
Okay. That's good. Okay, so you see how to prepare the model on the basis of the GIS data. I would like to put in the folder in the Google Drive. I would like to put some data for you for the homework, and maybe I will make it today or tomorrow. Okay, I will let you know. So please download this data and try to prepare your own lines, your own river, your own banks, your own flow paths and cross sections. Okay. The base rule you knows, and you should follow them. If there are some problems, you should not be depressed. We will discuss all of them, all the problems during the next meeting. So these models, by my assumption is that the first version of your models will be just for correction. Yeah. So you can make as many errors you want. The errors are very common at the beginning, and this is the process of learning. So this is quite normal. Yeah. So just make first trial and first attempt and try to do whatever you can, and later we will explain the rest and try to correct it. Okay.
Okay.
So such lines will be prepared, and new model will be just presented for a little bit different zone, not exactly the same. I just put new digital terrain models to the Google Drive, and you will be able to work with this. Okay. So this is my conclusion at the moment. And the next meeting, I would like to, of course, I would like to focus on your models, look at your models, but I would like to also show you how to work with the map in QGIS, how to correct the map to have the correct map without these elements which should be removed. I don't know how many time we need for this, but maybe 1 hour will be enough. So in the next hour, we may just focus on your models and all the specific problems you have, and we may also make some plan for the future. If you need more, we may just focus on the next task and try to discuss this task. Okay.
Yeah. Okay. Ada yang mau tanya?
Questions? Any questions?
Yeah.
Okay.
I have some question about the cross section. You tell me about you make one cross section and you make another one again. The cross section cannot be interpolated in HECRAS.
Cross sections might be interpolated in HECRAS if we don't have the GIS information or we just want to produce very quickly cross section. But if you have GIS data and the terrain anytime is a little bit different, you just move several steps and you may have a little bit different configuration of the terrain. So it's better to base on the terrain and make the cross sections manually. There is no effective and correct method to interpolate the cross sections in the GIS software, because it's a relatively difficult task that the human needs to identify the topography and properly just put the line in this topography to have the cross section. So at the moment, there is no automatic method, no automatic algorithm for automatic generation of the cross sections on the basis of GIS data. Maybe machine learning will change something, but as I know at the moment, that there are no method, no applications of this type.
Okay, thank you.
Okay.
Yeah.
Okay, more questions?
Yes, I think it's enough, Thomas. Thank you very much.
Okay, thank you very much. Okay, thank you, thank you very much. I remember also about the digital terrain model for Indonesia. I will send you the data for the account just to be able to download this data. Okay.
Yes, we really need it. But we should know exactly what is the problem. Why when we try to log in, we cannot log in. And what time? When do you register actually to?
I don't know, but it means that I'm really lucky internet navigator. Because yes, I'm looking for data for several countries, for Portugal, also Brazil, Colombia, and I managed to download whatever they have. So maybe I'm lucky in this moment that I managed to find such I don't know. I will give you the access to my account, and you should be able to look and download. Okay, so it should be correct, because I don't see any reason that you don't have the access to your own data. So it's really strange in this moment. So yeah.
Yeah, it's okay.
Okay.
Yeah, I think. Yeah, how about our plan to make look like connection by WhatsApp? Yeah, do you have WhatsApp?
I think we can just plan. We can make the similar plans like previously, but now the proper hour for you, as I know, is 9 o'clock in Poland. Yeah, is it true?
Yeah.
9 o'clock. I don't have any other options, any other plans for the Tuesday next week. So if you want, it might be Tuesday 9 o'clock next week. It's almost the same like today, yeah.
Apa mau jam 8? 9 is okay, or 8?
9 is okay. 9 is okay. It's even better, because I have more time. 8 o'clock was chosen just to not to take too much afternoon time in Indonesia, just to make it easier for you. But if 9 is okay for you, 9 is also okay for me. Yeah.
Okay. Mean next meeting is 23rd of April. Yeah.
Tuesday. Yes, exactly.
Yeah, Tuesday 23rd of April at 9 CET. Okay. Wait a second. Gimana? Dia bisa? Yang masuk ke download. One second, Prof. Thomas, because one of my student actually, yeah. Oh yeah. Can you share to Prof. Thomas? Share the link, yeah. Yeah. And finally, one of my student can enter the geospatial. Yeah.
Okay. Okay. So you have the access. Okay.
Yeah. We have access.
Okay. That's good.
Yeah.
Okay. That's good. Okay.
Okay, that's good idea.
So okay, so we have everything set. So I need to prepare homework, and just we have the next meeting next week, and we continue our work with Kekras. Okay.
Okay. Udah cukup semua. Anything else? Yuk ketuk mejanya sama rame-rame. Okay, Prof. Thomas, thank you very much for today. And ya let's come up with our table. Yeah, thank you very much.
Thank you.
See you next week and give my regards to Joanna and Nazo.
Okay,
Tropike.
thank you.
Yeah,
Thank you.
Tropike. Nice to meet you, Tropike.
Okay. Bye.
Yeah,
Thank
okay.
you.
Bye-bye. Thank you very much. Bye-bye.
Thank you.
Bye-bye.
Thank you. Bye.
And
Ya, siang Rifandi. Kawan yang lain suruh masuk aja Rifandi. Ya, siang semuanya. Ini yang belum gabung, Richard mana ya? Kok nggak ada kabar ya?
Ini Pak, sudah di
Oh, udah di
lab
lab.
Pak. Iya, di depan saya ini Pak.
Oke, oke. Belum gabung aja ya.
Iya Pak, lagi buka laptop, baru menyalakan.
Tapi kalau run di laptop ada masalah nggak?
Saya nggak ada sih Pak.
Hmm?
Kebetulan
Yang
ada.
lain
Ngeran nggak masalah, nggak ada Pak.
nggak bisa ya. Berarti kan ringan ya. Memang nggak seberat tiap ya. Oke.
Iya Pak. Cuman ini sih Pak, yang punyanya Okta nggak tahu kenapa cross sectionnya selalu error Pak. Jadi harus kayak buat 2 kali gitu Pak.
Itu mungkin coba SI unitnya periksa betul di awal, betul nggak? Dari awal periksa dulu step by
Udah
stepnya.
bener Pak. Cuman mungkin ininya apa? Iya nggak tahu itu Pak. Antara memang laptopnya yang terlalu besar resolusinya atau gimana. Karena
Ya, nggak
saya
mungkin.
sempat
Nggak ada hubungan
saya
sama resolusi.
nah itu Pak.
Setting biasanya,
Tapi
sama
sudah
setting.
sudah settingannya sudah benar semua Pak.
Setting biasanya. Coba di, nggak tahu ada yang salah.
Iya.
Ya ini kita coba latihan dulu singkat. Coba saya kemarin itu. Nanti kalian kan delivernya pakai bahasa Inggris ini. Siapa yang mau coba latihan duluan? Yang kelompok 1 siapa? Yang tugas 1? Tugas 1 siapa yang ngerjakan?
Saya Pak, saya kerja 1, 2, sama 3 Pak.
Nomor 3, 4.
Nah 4 ini ternyata nggak ada Pak. Ini
Hah?
Rifandi kan tugas nomor 5. Terus
Hmm.
Richard tuh ternyata nomor 5 juga Pak.
Malah
Hansel
nggak dibagi kemarin.
Oh Hansel kerja nomor 4 Pak. Ya itu Pak
Oke,
Hansel Pak.
nomor 4. Lo Angel, kamu gimana? Bisa ngomong apa enggak? Masih gimana ceritanya? Hansel gimana? Hansel bisa ngomong apa enggak Hansel? Nanti.
Yes, oke, suara saya masuk, Pak.
Iya, sudah. Iya. Ya kameranya di on kan semua, nggak enak nanti. Kamera. Oke. Ya. Richard, pimpin dalam doa, Richard. Kita mulai, Richard.
Teman-teman, mari kita berdoa. Tuhan yang di surga, terima kasih Tuhan atas berkat pada hari ini. Tuhan, maka Tuhan mengumpulkan kami di tempat ini dengan keadaan sehat dan selamat Tuhan. Mohon Tuhan, semoga meeting ini hari ini dapat berjalan dengan lancar. Di dalam nama-Mu, kami kita berdoa. Haleluya. Amin.
Oke. Ya. Okay, let me try to speak in English because this course will deliver in English. Actually, we have 5 projects, and project number 1 will be delivered by Michelle. Number 2, also Michelle or Okta, yeah, should be, and the project number 3, also Rivandi. In which project do you take? Yeah, project number Rivandi. Okay, if you have problem, answer project number 4. Yeah, and then the last one, Richard, project number 5, and also Rifandi. Okay, Michelle, time is yours. You should prepare and share maybe just 3 minutes. Okay, give information about your project. You are still in muting, Michelle. Okay, time is yours.
Okay. Good morning, Professor Thomas and friends. Today I will present about my homework. I choose data 1. This is my data, and I get first the river, and then I make a bang line in right and left, and then flow paths. This is the flow path in the right side and left side, and then cross section. Wait.
Yeah, because you have if someone talk, I wish another should be muting, yeah. When Michelle talk, just Michelle. Okay, time is yours, Michelle. You can continue it.
Okay. And then I make a cross section, and this is my cross section. So this is my cross section too in geometry data. See cross section. Oh, this is my cross section. So the water in there, and like and then I choose the sebentar Pak. No, just elevation. And I saw remaining redness 0.025 and then 0.045, like Mr. Thomas. And the final result, this is the in the tab 1, no, this is the error, and then this is the tab 2 and tab 3. The floating air in this area. Thank you.
Okay. The project number 2, please. Okta. Okta, time is yours.
Okay, good morning, Mr. Thomas and everyone. I'm gonna present my homework with the data too. So we can see in the RAS mapper with the same process as we shall have already tell us before. I put all the data like terrain, many roughness, flow, and many else. So it can shown in the screen, the cross section, the bank line, the river, and else. Sorry. Ini suara gua kan?
Cross section.
So this is the from geometric data, and we can see from the cross section, it shows like in the screen. So for
No
the
flood in
result,
location, yeah. No flood. No flood in this area.
There's a flood we can see in the RAS mapper. You can see in the result.
In tab 1, no flooding.
Yeah, in tab 1 no flooding, but if we input the tab 2 and tab 3, there's a flood. It's finished for me. Thank you.
Okay, let's come to the project number 3.
Rifandi, makanya tadi Rifandi dipanggil.
Kenapa?
Kamu tadi dipanggil sama Pak Surya, ditanyain kalau kamu pakai data 3 gimana.
Oh,
Terus kamu
aku nggak paham data tiga.
Nah, itu.
Aku nggak paham data tiga.
Data 3 itu yang ngerjain Okta, Pak. Cuman ya itu masih error itu, Pak.
Berarti data 3 belum beres.
Belum beres, Pak.
Kamu harus data berapa?
Ada hasilnya tapi salah, Pak.
Lo kemarin janjiannya gimana?
Hasilnya berantakan.
Kemarin kan kerja sama saya, Pak.
Ya, Pak.
Sebenarnya sudah oke, Pak. Tapi begitu di save ini, terus dibuka lagi, hasilnya langsung berantakan semua lagi, Pak. Makanya saya bingung kenapa laptopnya Okta itu, Pak.
Tadi malam nggak, Pak?
Ya, punya saya, Pak. Geometriknya
Saya
error,
kerja
Pak.
sama
Jadi
kita.
kalau saya buka geometriknya, ya saya nggak bisa dibuka, Pak. Tapi di rasmappernya keluar, Pak. Kan ini
Coba,
rasmappernya.
coba aja.
Tapi di geometriknya,
Ya ditanya, justru itu masalahnya. Memang sengaja kadang-kadang dikasih error itu.
Hitam.
di geometriknya error, Pak.
Ini layarnya masih hitam. So,
Oh,
let's
sebentar.
come to the
Screenmu hitam.
Sebentar. Nah,
ya pakai bahasa Inggris. Ya, let's come to, ini project number berapa berarti?
number 4.
Oke.
This is the first we made the reverse flow and the bank line and the cross section. And in the geometry we have made before, but in the geometry, in the cross section, the data is error. I don't know why the save or what, but the geometry is error until after we save, but the result we get is like that, like that. Gitu, Pak.
Kenapa kok error? Berarti kan ada yang salah, mungkin satuan.
Waktu nge-save-nya mungkin, Pak. Jadi
iya. Kok nggak ulang lagi?
belum sempat membuat ulang sih, Pak. Karena baru kejadiannya ini, Pak. Jadi
Kamu buatnya mulai kapan ini?
kan kemarin saya buat ulang kan, Pak, cross section-nya. Itu bisa, Pak. Terus tadi pagi waktu saya buka ulang, tiba-tiba error gini, Pak.
Loh, gimana? Berarti kan nggak simpannya ditumpuk-tumpuk, nggak simpan 1, simpan 2 gitu loh. Nggak ada cadangan, jadi waduh. Ini salahnya kan bukan di program, kan, salahnya di human error kan?
Di waktu saving-nya, Pak, mungkin, Pak.
Ya itu salah di human error kan? Aku ngerjakannya baru kemarin. Wah, ini repot ini.
Kemarin bisa, Pak. Kemarin keluar itunya, Pak. Yang tadi
Ya, tapi orang kan enggak lihat itunya, lihat yang terakhirnya. Enggak peduli kamu bisa enggak bisa, kamu bilang orang kan lihat hasilnya.
Iya, Pak.
Okay, project number 5.
Okay, hello, Professor Thomas. Today I would like to present my homework. Here, as you can see, oh, hitam. Coba. Kelihatan. As you can see, this is the geometric data that I use, and this is the cross section that shows station and elevation of each cross section. The many value that I use for the left bank is 0.045 and the right bank is the same, while the river flow is 0.025. Now I'll show the result. This is the rest paper. This is the result of the first simulation with the discharge of 350 meter cubic per second. This is the one with 700. And the last one is 1,400 meter cubic per second. The flow discharge that I use is the same from the YouTube tutorial. That's all. Thank you.
Okay. What we miss is now project number 3 and project number 4. Ya. Kok bisa kemarin dari awal janjinya gimana? Kok bisa 3-4 lewat itu gimana ceritanya? Nggak dikerjakan, Mas.
4 itu
janjian
kemarin
sih, Pak.
bisa,
Hah?
Pak. Cuma kemarin error, Pak. Cuma ada pagi tiba-tiba error, Pak.
Tadi
Ya kan?
kok bisa tadi pas presentasi tadi pagi itu?
Nah, waktu dibuka lagi kayak gitu, geometrinya nggak bisa kebuka, Pak. Jadi nggak tahu kenapa, Pak, di correction-nya, Pak.
Sekarang, oke, sampai pertanyaan saya. Kalau sekarang kan berarti udah, setidaknya kalau langsung ke kasus masing-masing udah bisa toh, tinggal masukkan data hujan. Saya lihat di YouTube banyak itu, masukkan data hujan bagaimana kan? Seandainya ketemu hujan, terus ketemu lagi kasus sebenarnya, terus yang data yang belum bisa tuh data itu ya, data pengukuran ya. Ada kan di YouTube juga banyak kok saya lihat kok cara masukkan data pengukuran. Ya, saya lihat sekilas cara masukkan data pengukuran lapangan di misalnya di apa di server kita ini banyak kok ya. Saya rasa minggu depan kita udah bisa ngebut ya. Cuma nanti nggak tahu Prof Thomas mau diskusi apa lagi. Kita nggak tahu ini bisa apa enggak. Tapi sepertinya kayaknya dia minggu-minggu ini pas lagi chaos juga. Ya, kemarin ada janji sebenarnya hari Jumat ya, dan ternyata dia ada conference. Nggak tahu sekarang bisa apa enggak gabung. Mudah-mudahan kita tunggu 5 menit aja. Kalau 5 menit nggak ada nanti salah. Tapi intinya sudah bisa ya. Kira-kira sekarang kalau misalnya kita ke proyek kita masing-masing, masalahnya apa? Surat ke ininya kemarin Bakas Bangpol udah jadi diurus belum ke Pak Tommy?
Sudah, Pak.
Udah keluar. Udah
Morning,
ke
Tommy.
Bakas Bangpol belum? Karena kalau udah ke Bakas Bangpol itu baru nanti bawa proposal aja biasanya. Kalian buat proposal, nanti kasih surat, itu baru bisa kita ke lapangan. Mau ke PU ya, nanti bilang, oh tujuannya kemana? Ke PU, ke Beda gitu ya, yang masing-masing lokasi. Jadi baru enggak masalah. Oh, ini udah ada yang gabung. Oke, rasanya udah cukup, enggak apa-apa tadi. Berarti yang ada yang miss tadi ceritakan aja ya, enggak apa-apa. Yang project 3 berarti yang betul-betul belum dikerjakan kalau gitu. Okta dikerjakan Okta tapi gagal gitu Okta, gimana Okta?
Iya, Pak. Jadi sama kayak Hansel, Pak. Jadi yang waktu di cross sectionnya itu tampilannya kacau, Pak.
Tapi ada hasilnya.
Tapi hasil depth-nya dan lain-lain tuh bisa, Pak.
Oke, ya nggak apa-apa ya. Ya nggak apa-apa, yang penting sudah bisa ditampilkan. Ini mahasiswa S3-nya siapa namanya kemarin? Ya, morning Tropika.
Good morning.
Yeah, can you hear us?
Yes,
Yeah.
now yes.
Yeah, nice to
Hope
meet
are
you.
all okay. Nice
Yeah.
to meet you also.
Yeah, actually, my student right now I've already did 5 exercises, but 2 projects they found some problem. Maybe they can share yeah, after waiting from the Prof Thomas joining us. So, in what year are you in right now, Profika?
Once again, please, this,
What year
last
are
one.
you in? Right now you are PhD student, that's right?
Yes, I'm a PhD student here, and at the same time, I'm giving lectures which are practical classes of teachers who are giving lectures over here.
Okay. How long you work with Mr.
In the
Thomas?
second year.
Oh, the second year. Okay, that's good.
Yes, second year.
I think a second year is quite a lot experience, huh?
To be honest, pretty much. Now, if I will close my eyes and think about 2 years, I will be scared.
Okay, it's good. Yeah. Yeah, Mr. Thomas, I think he is still joining with us.
Probably, now it's connecting to the audio,
Yeah,
so
yeah.
probably in a few seconds he will be.
Yeah, that's true. How about the weather in Poland right now, Tropika?
Sorry, sometimes your voice is not coming in the correct way.
The weather, the situation like now in Poland. Because in Indonesia we have this the same weather to raining and yeah, sunny is a lot in Indonesia, but in Poland, of course, in April since a ruling is like yeah, the season is time change, yeah, because the times different from last week, yeah, last 2 weeks is 6 hours, right now 5 hours difference to our country.
Yeah.
Wow. Do you know why Mr. Thomas is quite long
I
to
will
join?
contact him. I'm afraid that because of
Yeah.
connection, internet,
Oh, yeah.
it can be. Sometimes we are having problem in our university.
Okay,
But
okay. But it's
I'm not
fine now.
sure. It's okay.
Okay. Hello, I'm
We
now
are missing
connected.
you, so.
Okay, I knew that you did not start without me. So hello everybody.
Yeah, hello,
Okay,
morning.
okay.
How are you?
So we will continue, as I understand.
Yeah.
Or maybe okay. I see that we have the individual screens now, so maybe it's better even that we can talk. Especially that first of all, I would like to ask about the homework. Yeah, because the homework is crucial. The first thing we can talk if everything is okay. With the homework, we can continue. If not, we just look at the homework and we may try to make the exercises together today. Yeah, is it a good plan for today? Yeah.
Yeah, it's good. I think. Yeah.
Okay. So let's start. Okay. So my first question, because we start very fast. I'm still in rush today morning. How is homework? Is it done? Can we just look at this, or we should start doing homework and we should talk about something else? Maybe you have some questions.
Yeah, I think we can start one by one. Yeah. I think last a half hour ago I discussed with my student. Not all of the 5 project or exercise can be done already. They have two project have a problem, but they still didn't know why they cannot finish the homework. Maybe we can discuss after that. Maybe we can start from the project number 1. Michelle, time is yours.
Okay, I will just look project number 1, data number 1. Yeah, we are talking about this. Okay, okay. Let's have a look.
Okay. Good morning, Mr. Thomas and everyone.
Good morning.
This is my homework in Nurse Mapper.
Okay.
Okay. I make a geometry to first refer. And then I make a bank line in the right side and left side, and then I make a flow path and make a cross section manually.
Okay, that's really good.
And then wait, sorry. Okay, and then in the geometric data. Okay, this is the cross section.
Okay. Yeah, it looks good. And as I see, this is after filtering the points. Yeah.
Yeah.
Okay.
Okay. That's and then the floating area in tab 1.
Okay. So it's ready, as I see.
Yes. This is
Okay.
tab 2 and tab 3.
Okay, that's good. So I see that you repeated all the steps with the manual preparation of the lines which were necessary. So it's correct. It's it's ready. And okay, maybe some corrections could be done because, for example, in the right part of the screen, on the right flow paths, we see some break of the flow paths. If I don't know if I can have a control over your. Okay, I will request the control over your screen.
Oh, okay.
If you give me. Okay, do you see my cursor? My mouse? Yeah.
Can you?
I moved it.
Yes.
I move it.
Okay.
Okay. I'm talking about this region. I'm talking about this region. This break of the line is not necessary really. You may just connect through this wings of the cross sections, right wings of the cross sections. In my opinion, the line should just go through these lines, more or less straight, without this. Yeah.
Okay.
This is not necessary here. Here, if we have such breaks, it's okay, but the wings, the parts of the cross section also change. So this is okay, and it works quite well. I think so. Yeah. So this is only my remark. This is my only remark. This okay. Of course, this is your choice, and any time we prepare the model just makes his own choices, and this is not generally the density of the cross sections is quite good in this case, so we don't need to think about any serious errors in this case. However, I would recommend a little bit greater density of the cross sections where you have a meanders like this. Yeah, and this. So supposedly I would add one cross section here, and I would add some broken cross sections here and here. Yeah, just to model the change of the direction a little bit better way. Yeah, but at this stage it's also okay. So I'm talking only about the improvements. If we see that something is wrong and some competitions are not giving us the physically reasonable results, we may just add cross sections. It should be also it could make the results better. Yeah. So such kind of corrections might be done. Let's have a look. Okay, closer. I see that you follow a little bit the banks which are presented in the example for our tests. Honestly speaking, the banks there which are there are a little bit too detailed. So it may be good. Okay, I'm talking about this. It's not so necessary to draw a banks in so detailed way that you take care about any single change of the direction in the bank, because what really matters in the model is the crossing of the bank with the cross section. So generally, I prefer just to put one line in such cases without these disturbances. It's not really necessary unless you want to put the cross section here. Yeah, unless you want to put cross section here. But finally, what you get from the banks are the bank points in the cross sections only. So this is not visible really. But of course, you spend some time just following each single structure in the banks, and it takes the time. So for the future, just remember that it may not be so necessary as you think. Yeah. Okay. So it might be simplified, and but of course it's still good, and there are no, I should not expect any errors because of this. It's also quite interesting. We see it after the competitions that some cross sections might be shorter. For example, this one could be just broken here. It is visible. This zone is not the zone where we have a flow from this cross section, but this is something inundated after the spread of the water from other cross sections. But of course, once again, we may just leave it this model as it is. It's quite good. It's quite good, and we may talk only about some details, some corrections, maybe some two-dimensional areas also, because this is quite complex structure which never be modeled one-dimensionally in the correct way. So at this moment, at this stage, it's really good. Yeah? Okay. Thank you. Thank you. I will. Okay, I need to change. Okay, give up the remote control. Okay.
Okay. Wait.
Okay. Okay. Next one.
Okay. Wait.
Yeah.
Okay. Wait.
Okay, we have next one.
Okay. Good morning, everyone.
Good morning, but I have first remark. When I see your main window in the HackRAS, please avoid in the future, avoid the spaces in the paths. You look at the right side of your window, you have a spaces in the names of the folders, and avoid the dots which are not necessary, like
Okay.
one COBA and one professor and so on. These spaces may broke some simulations, especially unsteady simulations are very sensitive for this. So supposedly at the moment everything is okay, so we may follow, but for the future just remember about this. Okay.
Okay, Professor.
Okay.
So first, take a look at the RAS mapper using the result of the data 2.
Okay.
And we can see the geometry that I did for the river. Same as Michelle, I start drawing with the river, bank line, the flow paths, and the cross section.
Okay.
With the same process.
That's good.
And then we take a look at cross section. It can show like instrument.
Okay, looks good.
With the same process.
Okay. One more thing, it was also visible in the previous example. Could you close for a moment the cross section and zoom in, zoom out your reach in the geometric data? Close it, okay, and try to zoom in, zoom out. I wonder if the terrain is loaded in the geometry or not. No, zoom. Okay, so just zoom in. Let's see what happens. No, the terrain is not loaded. So for a moment, let me explain one thing, but I need a short remote control. Okay, for this. Okay, let's close for a moment the geometric data. Okay, and let's go here to the RAS mapper. This is important to take care about assignment of or adjustment of the RAS of the terrain to the data we generally work with. So I don't know. Okay, my remote control is working slowly.
Okay.
Okay.
So, Professor. Let me take the rest paper. This.
Okay, okay, you have rest mapper. Okay, if we look at any of the high-level options like the terrains, for example, and click right button, we always have this option, manage terrain associations. Manage terrain associations, and this is important because the elevation data are taken to build the geometry just to interpret the results exactly from the terrain. So it's not possible to generate the depth maps, for example, to generate geometry without terrain associated. By default, the terrain is associated, but sometimes we need to look at this window just to confirm only to see terrain in the geometric data. You saw that in your geometric data, terrain was not available, but it's good to look at the geometric data and look at the terrain at the same time. So at this moment, I really don't need to do anything more, but I need to only confirm, okay, there should be a button close. I don't see this button. But supposedly, if I close with this cross, after checking only, terrain should be associated. Yeah, terrain should be associated correctly. So now, if I look at the geometric data, and I zoom in, zoom out. Okay, just zoom in, zoom out. No, it's still not associated correctly. Okay, so we have some problem with this. Of course, all the computations are correct. Everything is correct, but only the visibility of the data is a little bit different and may not be convenient for us. So this is why I care, because of course, anytime the view of the terrain with the geometry is better. So supposedly, okay, I need to close it for a moment. Maybe it could be better if you try to do from your level. So I will stop the remote control, okay, and try to open RAS mapper and manage terrain associations. Just open this window in RAS mapper and you should see the button at the bottom, close. Just this button confirms that the terrain association is correct and is transferred also to the other elements. Okay. If you wish, I can open in my window the HECRAS, the previous exercise, and maybe I will show what I mean. Okay. Yeah. So for a moment, I just share the screen. Okay. Do you see my screen? Yeah. Okay, so now I open the HECRAS like previously, and this is the previous exercise. So the project might be open in HECRAS. I don't know if I show you this trick. If we just keep the PRG file in HECRAS, project file in HECRAS, and move to the first line, the project is open. This is very fast, so we don't need to use the open. We don't need to use the list. Just from the window explorer, we very quickly open the project. What I want to have is this effect that in the geometric data, I see also the terrain. Yeah, so it tells me also what is the connection of the data with the terrain forms. So it's not be surprised that here, for example, the cross sections are broken. Yeah, because I see that we have some tributaries. So this is the effect which is useful for modeler. If we don't see terrain, the geometric data, what we have to do is such action. We need to open RAS mapper. We need to open RAS mapper, and we can do it in the geometries. We can do it in the results, or we can do it in the terrains. The same option is available here. Yeah. So if you open this option, you see what you see, that we have the geometry and assignment of the terrain to the geometry. So this is the source of the elevation data for this geometry. This is the source of the geometric data for these results. What we have to do, of course, the assignment is correct, but should be confirmed with this button close. I was not able to see this button when we just have the remote control. Maybe when you open HECRAS on your own computer, you will be able just to handle effectively the window and see this button close. If you do it, supposedly, and remember to save RAS mapper, supposedly everything will be correct. If you open geometric data, you are after reload. Reload means that you need to zoom in, zoom out, just to make the picture once again. You should see terrain just in your data. Okay. okay now?
Yeah.
Okay. Okay, so I will stop sharing the screen. I hope that everything works correctly. So we may just come back to the homeworks. Yeah.
Ya, silakan selanjutnya. Next.
Okay, let me share here. So this is the homework for data 3.
Okay.
Still have error here. This is from the last member. With the same process.
The most difficult case with huge meander, I think. Okay. Okay. First of all, no, one problem is this the end on the left, the end of the channel, because supposedly the model should be just finished earlier. It should not be very close to the end of the digital tree model, because we don't have a data. Sometimes it may appear that some inundation zones are generated outside of the, or wants to be generated outside of the digital tree model. So if we have digital tree model, generally we always choose the area which is greater than the model we want to build. So if you have the digital tree model at the beginning, you need to just have your model, hydraulic model, inside this zone without any extension. So just be a little bit far from the end of the terrain. Yeah. So I suppose that I will finish the model in the cross section, which is 6798. So this is tiered cross section. It's good end of the hydraulic model. We should not go farther. Yeah, we should not go farther. It's enough. Even if you finish the model in 6592, it will be also good. Yeah, it will be also good because we should not be very close to the end of the elevation data. So this is the first remark I have. Second remark, we have some problem with the direction of the cross sections, especially 6592 and 6798, because in this zone the cross section should be broken generally, or no, even 6592 should be not broken, should have basically different direction, because if you look, there should be more or less 90 degrees. The angle should be 90 degrees. Yeah. So to the river, to the valley. So you see that it should be just moved. Yeah. So
can it be zoomed?
Okay, Tropica, do you ask about?
Can it be zoomed? I mean, just a bit more zoom.
Okay. Okay, we are talking about this cross section, yeah, this cross section. But I think zoom is too large now. If we just zoom out a little bit, it's visible better that we have some skewness of the cross section to the valley and to the river. Yeah. So I think we should just care about it and change this direction, change direction of the cross section. Yeah. It's better, for example, the next cross section, if you zoom out for a moment. But who is making this exercise?
Octavianus.
Me.
Okay. Okay. It's better, for example, if you look at 6092. Okay, but I see there is one error, and I know why it's not working. The direction of the river is wrong. Yeah. Look at the river stations. The flow is from the right to the left, and the river stations always increase in the opposite direction to the flow. And now they are just increased from the right to left. So the direction of the line is wrong, and I'm sure that the results are wrong, because in such case the river is flowing just upstream. So it's not what we really want. Yeah. Do you see this? The inlet should be on the right. So it's necessary just to change the direction of the lines. I don't know if this is possible, if it is possible to make such a change in the RAS mapper, but I hope that it is possible to make such change in the QGIS. Supposedly you do not need to draw the line once again, but only just process this line to change the direction. So this is supposedly the error, the problem we have. Yeah? Okay.
Wait a second, Thomas. I talk to my student. Okta tahu salahnya di mana?
Arahnya, Pak, nggak sesuai.
Iya, arah harusnya salah ya. Dari mana buatnya?
Saya dari kiri ke kanan kemarin, Pak.
Iya, tapi katanya kan salah karena ini dari naik ke gunung. Udah lihat RAS mappernya enggak arahnya? Ya.
Iya.
Balik ya. Oke. Oke, Thomas. Ya.
Okay.
Continue. Ya.
Okay. This is the main problem. Yeah. This is the main problem when we look at this. So maybe, yeah, for a moment, but I see that you managed to generate some results, but I also expect that this zone, for example, is more inundated, and supposedly this is the problem. This is the problem. Can we look at another kind of results? Can we close the RAS mapper? Close RAS mapper, okay. And can we look at the view, the main window, and look at the water surface profile?
It is.
Okay, and these are, yeah, this is what we have. These are the errors, yeah. These are the errors, so the results are totally unphysical. So and this is the effect of the wrong direction of the river and wrong direction of the flow general. Yeah. Okay.
Yeah.
Okay.
So Mr. Professor,
let's yeah.
I have a question about.
Okay.
So we must start to draw the section from right to left, right? I mean,
no, not only cross sections, but we have the problem with the river center line at the beginning. The direction of the river center line should be different. The river center line should start on the right and should be drawn to the left. Yeah, or just in the ArcGIS, the tool which can let us to change the direction is called flip. So I don't know what is the tool in the QGIS, but supposedly it's possible to find a tool which can just change the direction of the line. But if you change the direction of the river, supposedly you need to change also the direction of the flow paths, and the bank lines should be changed also. So this is all the generally I recommend that all the lines are in the direction of the flow. The river and flow paths needs to be, and it's not possible to build correctly model if this direction is not kept, the direction of the flow. The banks are not so crucial, but it's better also to keep the direction of the flow in the case of the banks, because sometimes we replace the banks with the flow paths in some analysis, some interpolation of the bed elevation and this kind of the issues. So it's better to have all these lines, river center line, banks and flow paths in the direction of the flow in the river. Yeah, direction of the flow in the river in this case, in all cases, is from the right to left, because this is the same river but different reaches. So in all cases it will be the same. But now, if we talk about the cross sections, this is another issue. If we talk about cross sections should be drawn from the left side to the right side. Okay, yeah, from the left to the right. Left, right, we determine when we face in the direction of the flow. Our left is the left of the river. Our right is the right of the river. Yeah. So from the left to the right, and this is the idea. The idea that these are the main rules which needs to be completed, which needs to be satisfied if you want to create the correct model. Okay.
Okay, understood. Thank you.
Yeah. Okay. So this is for needs to be corrected. Okay. Do we have more?
Stop. No.
Okay. No more.
No more.
The project number 4. Yeah.
Number 4. Okay.
I have same problem like Okta maybe about the river flow. That's this is the geometry data.
But the cross sections are a little bit too short, in my opinion. If you want to simulate greater flows, supposedly the inundation can be generated outside of the extent of the cross sections.
Oh.
So the cross sections, especially you see here, such a light green belt along the river. This is the river valley, which supposedly will be inundated during the high flows. So the cross section should be larger, should spread over the valley, the river valley. Yeah.
Yeah.
Okay.
Okay. Could you zoom in? Could you zoom in this picture? And we don't see the river stations. Just to check if everything is correct. I don't remember the option to display the river stations in this picture, but supposedly there is an option in the layer properties. Okay, but yeah, it's the only problem now. Have you tried? Okay, and this is the depth PF3. What is the value of the discharge for the PF3? Because it looks like a very small zone. We have some unsteady computations here.
Yes.
Okay, quite interesting. And so this is why you have only one. No, these are not unsteady, but these are selected profiles. Okay, selected profiles. I see. Okay, and this is the smallest, and PF3 is the greatest.
Yes.
Okay, I understand. But you see that even in this picture, the PF3 is beyond the cross sections. Yeah, beyond the cross sections. So the cross section definitely should be larger.
Okay.
Could you show me the steady flow data? What are the data? What are the discharges in the main window of the HECRAS? Let me just look and edit steady flow data. Okay, 1,400. This is relatively small with this discharge. So please show me the water surface profile, okay, like previously, because I'm afraid that we have also the problem with the direction of the lines. This zone seems to be too small, unless this is too small because it's cutted because of the too short cross sections. So it might be also possible. Could you open the view in the main window of HECRAS and use the water surface profile view? No. This is geometry.
But the
geometry is also
geometry is
strange.
error. But after I open the geometry again, the cross section is error. I don't know why. But
okay.
in the first map,
could you give me the remote control? Okay. Okay. Let's check. Okay, I would like to check something before we just look at the geometry. This is the steady flow, quite large steady flow, and let's have a look at this. We have cross section, and let's check layer properties. And what I would like to display here is options, features. Okay, we have some. Okay, but some cross sections are interpolated in this case. I see. It's not recommended if you have GIS data to interpolate cross sections. It's better just to build cross sections on the basis of your terrain. Symbology. Okay, I would like to use symbology by attribute column, and I would like to display the river station. Oh no. Okay, this is not symbology, but label by columns, and I would like to see not feed, but river station. Okay, and we see the river stations. The direction is also wrong. This in this case. exactly the same problem like in the previous example, that the direction of the flow is wrong. You see that the reverse tensions are increasing in this direction, but they should be increasing in the opposite direction.
Oh.
Yeah, so this is supposedly this is the reason for this. And of course, if the river is flowing upstream in the opposite direction, the zone is very small. The inundation is very small. So this is what we see in this case. If we look at here in the view water surface profiles, yeah, we see such a very strange picture, which is difficult even to interpret in this case. Yeah. So we should just change this element. Okay.
Okay.
Okay. Let me. Okay. Please stop the sharing screen for a moment. Let me show you one thing.
Thank you.
Let me. Okay. Thank you. Thank you very much. This is the last presentation.
No, there is another one.
Okay, so let's have a look at the another one, and then I will talk a little bit about this. Okay.
Okay. Hello everybody. Today I would like to present my result of the simulation. As you can see, this is the geometric that I use roughly.
We have the same problem. We have the same. Look at the river stations. Yeah, river stations are in the opposite direction. Yeah.
Yes. Yeah. That's
okay.
That's what I said from the
Okay.
Google
Yeah. Okay. So the direction should be generally changed. Yeah.
Right.
Okay.
So this is the cross-section.
Supposedly this is the same
Yes.
problem. Okay. Okay. I would like to show you one thing, something what is available for you generally, but one more element I need to change in my screen. Okay, I need to change this. This is okay. I will share screen for a moment. Okay. And for okay, for the moment I will close this. This is our previous exercise. Let's have a look. Maybe okay. If you look at the not exactly at the data, but in the models, the folder models is available in the Google Drive. You have the model which is called Modelo 1D version 2. Version 2 is extended version is greater than the version 1. And let's have a look for short time into this model. So I unzip this model in my exercises. Size O2B, okay, might be O2B. It's a model a little bit larger, but you will see some features, some common features which may help you just to compare with your model. If we look at this model, we have okay PRG. Let's move it here, and this is the model. This is the model. You see, this is the reach model. So your reaches, your homework is these are the parts of this model. In fact, yeah. So you may find your zone in your model. This is larger reach about 50 kilometers, as I remember. And if you look at this geometry, you may just find the cross section. This is my concept. Yeah, how I model this reach. Yeah. So if you have any concerns, if you doubt how it should be done, you can compare. For example, this zone. This zone might be compared. This is how I solve the problem with the location of the cross sections in my case. Yeah. In my case, and this is what I really prefer to do. The flow paths are not exactly visible here because the model was prepared with the old methodology using the ArcGIS desktop with the plugin HackGeoRAS. So the flow paths and this kind of lines were prepared in the ArcGIS, but the cross sections are still visible. Yeah. So this is what you have. If you want to see all the cross sections, flow paths, and this kind of content, look at the data, because data for this model are also there in the Google Drive. This is exercise 1D version 2. Yeah? So you can just follow the steps from the previous exercise, building this large model, and then you see all the flow paths, bank lines, and this kind of content. Yeah. So just you have the stuff, we have the content for comparisons with your solution. Especially, I would like to look at such regions like this one. You see, we have a meander with the river valley, and you see what I generally did and what I recommend for you, how to build the cross sections. That I have main cross section to the top of the meander, and also some cross sections broken. We just move into the straight cross sections so before the next meander. Yeah, so it let us to smoothly move over the different boundaries in the river, building the one-dimensional models in sometimes very complex topography. You can also see how to solve the problem of the bridges like this one. So you may look at this also is relatively good, rather detailed approach, because I used in my papers this model. So I cared about building this as accurately as it was possible. Yeah? So please look at this stuff, this content exercise version 2. 1D version 2 is especially put there in the Google Drive just to give you the example and some content for comparisons. Okay, so
Yeah.
I wanted just to mention this, and I think it could be good help, good support for improvements for next activities with the one-dimensional flow. Okay.
Okay.
Do we have more questions? No more concerns about this exercise, the build, the creation of the one-dimensional model at this moment? No, everything clear? Okay, I think I remember that we stopped with the model, one-dimensional model, before we created a real depth map in the QGIS. The real, I mean, that the depth map, which is just remove, clean, without all the small disturbances and place.
Ya, excuse me, Mas. I want to ask my student. Any question? Ada pertanyaan nggak berkaitan dengan modelnya? Kita arahnya kebalik semua ya. Berarti ada yang benar tapi. Ada ya.
Okay, we have question.
Sekarang
riset benar sih Pak.
terus yang dijelaskan tadi ada yang masih ragu nggak? Apa udah jelas semua?
Saya ada bingung dikit sih Pak.
Oke, apa langsung aja langsung ya.
Tapi saya bingung bahasa ini ya, gimana Pak? Bisa dibantu?
Ya gimana? Bingungnya kenapa?
Jadi itu yang menentukan dari flow path-nya, dari garis rivernya ke kanan ke kiri itu lihat dari map-nya atau gimana maksudnya?
Okay, my student have a question, Thomas. How to determine the flow direction if you see the flow path?
Okay, flow direction. Just generally, if you look at the map, you see where the months of the river are. So it's good to use QGIS. Okay, let me use QGIS for a moment, and let me share the screen for a moment. Okay, so okay, you see everything. This is our previous project in QGIS in the stage we just finished last time. So if you have, yeah, generally this is our zone. Yeah, so if you look at this zone and we don't have any other data, what you can do is very simple, just to check the values, and we should have the tool here to check the values. But let me just change one thing. Okay, no, this one, show video panel. Okay, now I see also the full screen. So this is what I wanted to do. First of all, we have the pure terrain, and let's just uncheck this elements. We have the pure terrain. So first, the very simple thing we can do is to use the tool, this tool, for identification of the elements in QGIS, in general in the GIS software. So if you use it, generally it should work this way, that if you click in any element, for example, here, this is my potential inflow, inflow, I check the value, I see the value of the elevation, basically. I see the value of the elevation, and this is what I have. No, okay, no, this is not the value of the elevation. This is the value of the depth, but I would like to see not the depth. I would like to see, okay, let me check it. Expand, not expand. I need to change the layer which is used to be read. Okay, so maybe for, okay. Supposedly if the layer is selected in the layers here, we may just use, yes, exactly, it works this way. I need to just to learn this, because normally I use it in the ArcGIS and I have the option just to display the values in all layers which are visible. Here it works a little bit different. So in the layers, you need to select the digital terrain model, because you want to just realize what are the elevations in your zone. And of course the flow is always from the zones of the higher zones to the lower zones. In general, in the rivers we have the gravitational flow with some impact of the pressure, but gravity plays the most important role. So we need to just determine what is the difference in the elevations, in which direction. So this is quite easy. So we need the tools just to check the elevations we have in this case. In QGIS it works, as I just realized, this way, that we need to select the layer, the digital terrain model in the list of the layers, and use this tool, identify. With this tool. If this tool is generally selected and the layer is chosen, if you click in any space, in any place in your map, okay, let's do it, you see the value in this place displayed here in the identify results. So this is the first value. We may remember that this is 37 meters, about 37 meters. So now let's go to the potential outflow. Here we build the model. So supposedly if I check here, I see that this is lower. So it's quite simple just to determine the direction of the flow. Because I see one value which is higher, second is lower. Of course, sometimes it may not be so easy, especially if you don't have the bathymetry. Sometimes it might be a little bit more difficult, and you should check several values in different locations. So just to be sure that the value just chosen subjectively is correct and give you the proper insight of what you have. But there is also another method, more general, let's say. You can use the background map, especially if we have the OpenStreetMap. This is why we need it sometimes, and just check the course of your river and where is the river outlet. So in this case, you realize my river outlet is somewhere here. You realize what is the direction of the flow, basically. So if you look, the river is flowing from here to the recipient, which is the other river, and the recipient on the river is coming to the sea. So you see also the direction of the flow. In this case, if you adapt in your elevations, if they are correct, if you don't have the information about the river bathymetry, but only the general digital terrain model, just check in the background map, in the more general map, where you are and to what is the direction of the flow. So these are the methods. I think the most simple methods. Of course, you can just use the cross sections. You may draw cross sections, you may draw profiles, check the profiles, and this kind of the tools, but it's more complex and needs more steps. So I think this is the best way if you are not sure. Okay.
Mana Pak?
Ya, jadi intinya kalau harus lihat elevasinya ya Pak ya.
Okay.
Mana yang
Tapi
lebih
bisa
tinggi.
lihat nggak di CM yang 7 meter sama 4 meter? Bisa bedakan?
Gimana Pak?
Kan tadi yang pertama
Oh iya Pak,
diklik.
37 sama satunya 35.
Ya, bisa ya ngelihatnya ya.
Bisa, tapi harus dari QGIS ya Pak ya, untuk melihat itu. Maksudnya dari Hackers ada fiturnya.
Ya, dari QGIS. Oke. Ya, anything lainnya?
Understood.
Anyone?
Thank you.
Okay.
Cukup? Okay, you can continue, Thomas.
Okay, can we continue? Okay, let's go to the next step. Okay, first of all, I would like to repeat one more step. So I'm going to open the QGIS, but I'm going to open also the model in Hackers, but I suppose that it will be necessary in this necessary for a moment. Okay, so I will remind what we have. This is our model, how we started, and you have similar models just created in the homework. Some of them are quite the first I remember are ready also to use in this exercise and to make the steps, but we may just focus now on this exercise which was done previously. So the model is created, and what we have is these are the results in the RAS mapper. Yeah? These are the results in the RAS mapper. The results were displayed. You should remember that after the calculation, we were able just to check the results and display the results. This result was by default presented. The first profile available, and we could see that the depth map in our region. We added the additional depths using the option from here. If we select the name of the plan, using the option create new results map layer, and I saw that you were able just to do it. Yeah, so you knew how it works and how to do it, just selecting the profile in the list. You also should notice that when we select profile, we have different options here on the right. The default option is to create a map in memory, and in memory in the HDF file and algorithm which transfers is into our picture. If you want to play with our results, if you want to work with our results in external GIS software, we need to use one of these options, especially the first one. We create the raster, the geotiff, which might be used, which is saved in the disk and might be used in our processing. So this is what we need to remember, that this option let us to store the results in the disk. And it was done quite well. We have one such a map just in the disk. This depth PF2 is saved in the disk, yeah, in our case. So when this depth was just created and saved, we should see also in the Windows Explorer that we have the folder P01. This is the ID of the plan, short ID of the plan, and inside this folder we have the depth map. Yeah, so these are our results for the processing. Yeah? This result was in a very simple way was added to our map. We basically found it in the project home here, and we just move it to our project. Yeah? So it was done. I saw that you also just repeated this in your project, in your homework. So we don't need, I think, to repeat this to show how to do it. You know how this step can be done. Yeah. Okay. So I have such a depth raster here in my project, and I see that it's not perfect. Yeah, I see some inundation zones which are not connected with the river. Yeah, so something is wrong, and I would like to correct it. Supposedly, I'm aware that these results are the effect of the computations which are stored in the cross sections and interpolation between them. So my actions, which just change a little bit this picture, are quite good, and I'm not going to destroy the hydraulic computations, but I'm going to improve the interpolation between them. So this is the idea, just to improve the picture only, not the computations which are done in the proper hydraulic model. So this is what we are going to do now. I will move the depth map in the list just below the river center line and uncheck all the layers of my geometry with the exception of the river center line, because river center line is necessary for this process. So we will just stay with this in this way. Okay, everybody. Okay, now just to make such an elements that we would like to remove some elements and to leave other elements in the raster, It's really difficult because if we want to do exactly directly in the raster, we should just change the values in each single cell. It's really terrible work. So we are not going to do this. We are going to use a little bit smart procedures just to make it automatically. To make it in a smarter way, we have to replace the raster with the polygon. So I would like to have the polygons of inundated areas, just to have store them as a polygons. What led me to handle and to build something what is called a mask. Mask works like a clipping tool. So if I have some area which led me to pick from larger layer the elements, the mask works exactly in this way. Yeah, so I create a mask which cover only the zone which is really valid, where the inundation is correcting is correct because it's connected with the river, and we know that we model the inundation which is connected with the river. Yeah, so first step, if you would like to replace the raster with the polygon, is to change or create the new raster with the values, with one single value in all of the elements which are generally storing the values which are positive in our case. But of course, in our raster, we have also the cells where there are no data. So if you want to check it, just let's select the depth in the list of the layers, and let's use the identify tool and click on the raster, for example, on the depth. You see the value in the depth. This is 1.45. Yeah, in this moment, in this place. But if I click outside, I see no data. I see no data. Yeah, exactly. So I would like to have such a raster that every time I have a value, positive value, I have value 1 in the new raster, and outside I have no data. Yeah, so this is the idea, because the values which are, if we want to replace the raster with the polygon, the values in the raster have to be integer values, and each integer value give us separate polygon, separate polygon. So this is what we are going to do. Yeah, okay. Okay, now let's go further. Let me just use, okay, let's click on any other, just select the ID. Let's go here in the menu. We have a tools for handling of the for just processing the rasters, and as I remember, it should be in an analysis. Let me find it for a moment. I need to, yeah, okay, no, we have the raster calculator at the top. The raster calculator will be good. There are several ways we may use raster calculator. We may also use the reclassify tool if we find it in the list, but raster calculator is enough. Let's use it. This is the raster calculator in QGIS. Yeah, QGIS. You should see something like this. Yeah, everybody. Okay, in raster calculator, okay, I need to be careful a little bit because this raster calculator works a little bit different than the raster calculator in ArcGIS, but generally the most basic elements are the same. But as I remember, it works this way. We can just make some operations on the raster. We may add the rasters, we may multiply the values, we may just change the values. One of very useful operation or operator is the operator presented here, which is called if. In ArcGIS, the same procedure is called con, from condition. This led us to build a condition. We need to build such a condition that if the raster stores a value, we would like to put new value in the new raster, which might be 1, for example. Yeah. If the raster does not have a value, we put 0, and as I remember, the 0 becomes no data after this operation. So this should be correct. Yeah. So let's choose if. Let's click if. You should see if here in the raster calculation expression. We build expression. Okay. Ready? Now let's click on the digital terrain model here. If we are exactly inside the bracket of our if procedure, we have digital terrain model. And we may use also this operator if the value in digital terrain model is greater than 0. Yeah. So let's write something like this. Then we use, I suppose that comma is the proper sign. then the value should be 1 in the new raster. Otherwise, the value should be 0. Okay. And finally, we close the brackets. This is the expression which led us to create new raster, such a raster that, as you see, if we have positive values in the, oh, I'm sorry, not DTM. Why are you not shouting? Not DTM, but the depth. We are talking about the depth. We would like to just build new raster on the basis of the depth, not the digital tray model. You know? So if the depth is positive, we have value 1 in the new raster. If there is no depth there is no depth in the new raster, there should be 0 or no data. I don't remember now. We will check the option with the 0 and we will see the results. Okay, ready? Okay, now we have to look here at this part because we need to
second,
just...
Thomas.
Okay.
Atau second, ya, cek namanya. Sudah dicoba semuanya, udah punya megang datanya? Ada punya filenya belum? Filenya udah ada apa belum?
Filenya ada, Pak.
Ada, udah dicoba, bisa ya?
Iya, Pak.
Kalau ada problem nanti kasih tahu. Semuanya oke? Bisa ngikuti?
Bisa, Pak.
Oke, you can continue, Thomas.
Okay. Tropika, are you with us?
Yes, I'm here. Yes.
Okay, everything clear?
Yeah. Okay.
Yes, what I'm checking because I must do once again. It's something related to the problem with laptop, so I couldn't even open the previous one. I must follow the steps once again. So that's why I'm just checking step by step.
Okay. Okay. So later maybe I will show also where is the movie in the channel. Geoprocessing na UPP, where we have geoprocessing hackers na UPP, where we have the exercise with the ArcGIS, where all the steps are done. But for the moment, let's just focus on this. So we have such an expression: if the value in the depth raster is positive, generally we generate the value 1 in the new raster. Yeah. So this is the idea. New raster, here we define the name and the format of the new raster. It might be GeoTIFF. It will be the same like the depth raster. We have several formats, but generally the GeoTIFF is the most popular, so we will just stay with this. And we need to define the location of the new output raster and the name. So let's choose this cell and let's click on these 3 dots. Okay, let's click on these 3 dots. Okay, we should navigate to the location of our project. Let me check. Okay, I'm here, and this is the location of my project. And in the project folder, we have the folder which is called results. We should have, because we created it last time. Yeah, results. So you have in the results the hillshade, because hillshade was specifically generated for our project. Okay, you see it? If you are in this project, in the results project, we may call, for example, we may just give the name for new raster. It might be depth with value 1, okay, with value 1, or we may call it maybe flag 1. Flag 1. It's up to you what kind of the name you choose. Okay, just only something that you remember that we take care about this value 1. Yeah, ready? Okay, if you just wrote the name here, just press save, and you should see the name of your raster and the full path to the raster. Of course, the TIFF extension will be added. No? We don't need to care about the special extent now, because special extent was chosen on the basis of the rasters just involved in the processing. We have also the coordinate system consistent with the coordinate system of our project in QGIS, so we don't need to change it. So all the elements may stay as they are. May stay as they are. So we care only about the expression, and we care about the name of the final raster. Can we go next step? Okay, let's press OK. Let's press OK. And we see after a short time, you should see new raster in your project. Very simple raster where the value, there is only one value 1 or nothing more. Yeah, nothing more. To be sure that it works this way, just select this new raster and use identify feature and just click where you see the black color. As I see, you have the value 1. If you are outside, there is no data. Yeah, there is no data. So this 0, the second 0 which we use in the if, works as no data in the case of the in the QGIS. Yeah. Okay, it's clear. Remember to save project. Remember to save project. And now let's go to the raster, and we may go to the conversion. Okay. Now we just change the raster into the polygon feature, into the polygon layer, and we have a tool for this. This is the polygonize raster to vectors. Yeah, raster is changed into the vector layer. Okay, please choose this tool. Choose this tool. We should see this, everybody. Yeah. Okay, so we are here, polygonize raster to vector. We would like to change not change, but generate new layer from the raster flag 1. In my case, band 1, because there is only one band, is the basis. Name of the field data to create, it might be, okay, DN may stay in this, but what we have to write is the name of the new layer. Yeah, we should care like previously. So we have the space to give the name of our layer, but it's good to press these 3 dots and choose the location. Yeah, if you press these 3 dots, you have the temporary file option or save to file. Let's choose the second option because we would like to store this file in the disk. Yeah, let's choose the second option. And if you are not in the results folder, just find it. Okay, the results folder. We would like to save our file to the results folder. The format should not be JPG. This is one of the vector formats generally used, but more popular is the SHP file, shape file. Yeah, so let's use this SHP. Yeah. And let's call it, it might be what it might be. We may call it, yeah, black 1, but this kind we call it poly, yeah, or poly 1. Okay, name poly 1 is better. Let's use this kind of names. Ready? Okay, let's press save. So everything is ready. Generally, everything is ready. We don't need to just to select more. We may press run. Okay, we may press run. And after processing, relatively short processing, you should see that the same area is covered, but this time is covered with a polygon feature, not the raster. You know, the raster is still there, but we don't need it more, so we may uncheck it. The polygon is created, and we have the different polygons, and now we may handle the polygons, what is easier than changing the coverage of the raster. Yeah? Okay. Everybody? Okay. Now I will move the poly here below the river center line, because river center line is now important for us. And why we care about the river center line? River center line represents the river here. So everything what is crossed by the river, every polygon now which is crossed by the river center line, of course, is a polygon connected with the river. No? So this is the idea. We would like to leave only these polygons which are connected with the river, and just just remove all the rest which are not connected. What is quite simple, and we could do it manually if we want, but because the number of these polygons may be quite large, we would like to make it automatically. Yeah, we would like to make it automatically. So we would like to make it generate faster without selecting manually each polygon. Okay. Okay, next step. Let's go here, and now I need to find the tool. If I'm not sure. Okay, selection. Okay, here in the toolbar, I need to find this tool because in ArcGIS I know where it is, but I'm sure that in our QGIS it also works. Here in the toolbar, we have the options. We have the options which are necessary for us. Select by location. This kind of the processing is called select by location. In GIS software, we may select the features in two ways. Select by values in the attribute table. So, okay, not two ways, three ways, because the first selection is manual. Basically, we may just select in the screen, and we have the selection of the elements. Then we may select by attributes, just picking the values from the attribute table. Another method is to use the relationship between different layers. So in our case, the relationship is very simple because river needs to cross the polygons. Yeah, and we would like to select these polygons which are crossed by the river center line. So let's go here to select by location. I hope that all of you just see it. Yeah, select by location. Okay, let's choose it. We would like to, first of all, we need to choose what features should be selected, and in our case, these are the features in the poly 1. Yeah, the poly 1. Then we define the relationship, and intersect chosen by default is this what we need. Yeah, intersect. And then we need to choose the feature which is used for selecting. And in our case, this is river center line. Okay. Ready? Now we would like to create new selection because sometimes in GIS it works this way that we have selection in and add to this selection, but this is not the case now. So creating new selection is okay. Yeah. And we are not creating new layer. We only create new selection. So the elements which are selected will be visible in the screen, and this is what we want to obtain now. Yeah. So let's press run at the moment. And you should see, if you close the window, you should see something like this. Some elements are selected. This yellow color means that they are selected, but we have also the elements which are not selected. Yeah. So is it clear? Yeah. Okay, so we have some elements created in our poly 1. Let's click on the poly 1 and open the attribute table with the right button in the mouse. Attribute table. This is what we see. Some elements are created, but only as I see one element is selected. Yeah, the first polygon is selected, and this is okay. The rest of the elements, very small polygons which are here, are not selected. Are not selected. Only the first one is selected. So this is what we see in the attribute table. Okay. And now I would like to create new layer from the selection. Yeah, new layer from the selection. Let's click right button here, and we should have in the poly export feature. Yeah, do you see it? Export. In the export, we have several options. One of them is save selected features as. Yeah, let's choose it. Save selected, only selected. And we see this window. I would like to save them as a SE shape file. I would like to create new shape file, so SE shape file. We will choose the location and the name. So let's press these three dots and let's find the results folder. Results folder, and let's call it, because this is the real results of our processing. The first result, let's call it extend for PF2, as I remember. Yeah, profile 2 is just analyzed now. So we have extend, flat extend for profile number 2. Yeah, because this polygon really represents the extent of the flooding for these computations. And let's press save. Yeah, let's press save. We have the file name, layer name is not necessary, coordinate system is chosen, rest is also correct. We don't need to change anything in the rest elements. So now we may press OK. Yeah, we may press OK. We may press OK. And we should see new polygon, but this time the polygon do not include the elements which are not corrected with the river. You see the difference? Yeah. Okay. Okay. Everything clear for the moment? Should I explain something more? Any questions?
No, can answer.
Okay. Okay, now let's make some order. Let's uncheck the poly 1. Poly 1 is not necessary. Let's change a little bit the display of the extend PF1, because in such case, if I have the extend, I like to see only the border. So let's double click on this rectangle. In my case, this is green rectangle, and let's open the properties of the layer. Yeah? Let's open the properties. If you have a problem with the double clicking, just click right button and use this option properties to see exactly the same window. Okay. Let's choose the symbology in the list on the left. In the symbology, we have the default option for the polygons. Let's choose simple fill here in the last element of the branch. In the simple fill, I don't want to see the color inside. So I choose here, I change solid into no brush. So the inside inner area will be empty. And let's change the color of the border to something, maybe some dark blue, just to see it, but just indicate that this is the extent of the water. Yeah. So just handle the colors you have here. You may change to another method and pick something what is good for you. Dark blue. I suggest dark blue. Okay. And let's make it a little bit. Let's increase the width, maybe to 0.66. And press OK. And we should see something like this. If we uncheck the depth, you see the borders, the extent. Yeah? Everybody? Okay. Remember that this is still polygon. This is still polygon. We see only the outline, but this is still polygon. So we see the border, but the rest is not visible. So we may still use this as a polygon, basically as a polygon. So now let's use it as a mask. Extent will be used as a mask to choose only these parts of the depth raster which are covered by our extent. The rest will be removed, will not exist in the new raster. So let's go to the raster, and we should have something what is called clip raster by mask layer. This is exactly what we need. Yeah, in the raster we have extraction, clip raster by mask layer. In ArcGIS it's called extract by mask. This is the same tool. So clip raster by mask layer. And we are here in this tool. Okay, everybody? Okay, input layer. Let's choose input layer. Input layer is our original depth layer, just taken from HECRAS. So these are the HECRAS results. Mask layer is extend, just chosen by default. But of course, if not, we need to choose the extend PF2. Is this what we really need? Yeah. As I see, we need to choose the coordinate. Okay, no, coordinate system is not necessary to choose. It's necessary only when we change the coordinate system. In our case, coordinate system should stay the same. Yeah, should stay the same. So we leave this empty. This options empty. And extend. We are not going to change extend. So I'm surprised, but I need. What I need some option. Okay, some option to give the name my raster. Okay, so we need to go down here. Clipped raster. This is what we obtain finally, and what should be the name of our file. Let's, like previously, choose the 3 dots and save to file. Save to file. Of course, we should go to the results. we see that we have only one raster, TIFF raster here in our results. So let's call it now. This is depth, real depth PF tool. Let's call it. Okay. So this is our depth map, real depth map, not the pure result from the HECRAS, but the depth which finally is our depth map. Okay. If this is ready, let's press save and press run. Yeah, press run. Let's press run. And if completed, you may just close it. And it's good idea to move it below the extent. Below the extent. Okay. It looks like the previous depth, but if you just look now and uncheck the previous depth, you see that some elements are missing. Yeah. So the elements beyond the extent do not exist in the new layer. Yeah. So this is what we wanted to obtain. Yeah. Now you are ready to change the symbology of the new depth. So let's use the properties, and for example, in the symbology, let's use not single band gray, but single band pseudo color. Are you going after me? Yeah, everybody, not too fast.
No, it's okay.
Okay, so single band pseudo color in the symbology of the new layer. I would like to choose different color ramp, maybe blues. For depth, blues are okay. Yeah, blues. And the scale is okay. The very light blue for the low values and dark blue for the greater values, but the boundaries are not what I like. So let's just expand this arrow, minimum, maximum values, and let's change it. Let's change it. Maybe minimum will be 0, and the maximum will be 10. 10. Okay. So this is what we want, 0 to 10, and let's press OK. Let's press OK, and you see your depth map for the area. Yeah? Sometimes it's also good to choose proper transparency. So let's go to the properties once again, and the section transparency, and let's choose transparency for maybe 50%, and you see the depth in the picture of the terrain model, or you may just uncheck the terrain and use some background map. You see the depth on the OpenStreet layer. Yeah. So you see the inundation, the potential depth. Maybe transparency 50% is not good. You may change it to maybe 70%. It's it's the same. Of course, it's up to you how you play with these values. So maybe the original view is better just without any transparency. Yeah. Okay. Okay. So this is what I wanted to show you today. Just to show you how to create the map. Finally, step by step. These two layers, extent and the depth. This is the result. Yeah, of course, we may just make one more time the classification of the depths or process these elements, this data in any kind we want, but generally it's not necessary to make the next steps. The map of the depth, clear map of the depth, without the elements which are not real depth, which are the effects of the interpolation. Such clear map is quite good, and we may just use these results for any other purpose. Yeah, and this is the final stage of the modeling in flood protection, just where the purpose is to create the inundation extents and to know what are the depths, expected depths during the flood. Any questions?
Ada pertanyaan, Dao? Michelle?
Kalau untuk yang sejauh ini enggak sih Pak, cuman yang mungkin masih jadi pertanyaan tuh yang data hujannya itu dimasukin di mananya itu loh Pak.
Okay. Thomas, as far you have kids already, they have no question. But my student asks that she want to know about the how to input the rain data.
Rain data.
Yeah.
Rain data, but yeah, it's a little bit different subject in this moment. The rain data, this is quite new feature in the HECRAS. And the rain data, of course, in the one-dimensional simulations, we may use rain data also. But generally, if we talk about the rains, we should talk about the unsteady flow computations. So for the moment, we focus on the steady flow computations, like you see here. Yeah? So it's generally it's not possible because these are steady computations. So we may change the discharges in the river, basically on the basis of some calculations from the rain data. But the real rains can be put here in the unsteady flow computations. In unsteady flow computations, where you have the flood wave, we can just talk about the unsteady flow in the next during the next meeting, if you wish any next meeting, and we need to talk about the unsteady flow computations. Then we may talk also in the next steps about the meteorological data and how to put meteorological data. But this option is better and is more useful in the case of two-dimensional computations. When you so maybe it will be better just to talk about unsteady computations in one-dimensional flow, unsteady computations in two dimensions, and then talk about meteorological data, rain on the two-dimensional zone, and how the rain is transmitted into the river flow. Yeah. So we are several steps before, because this is advanced topic really, but in the new HECRAS it's possible. It's possible, and it's quite nice feature. Yeah.
Okay.
Okay.
We get the point. Yeah.
Okay. More questions?
Yang lain ada yang mau nanya? Silakan.
Nggak ada Pak.
Sudah ada. Is enough.
Okay. So I stop for a moment sharing the screen. Yes. Okay.
Yeah.
Okay. So maybe not questions about the exercise. Maybe other questions about other elements. Some suggestions.
Ada pertanyaan atau ide, silakan.
Ini Pak, mungkin yang mau tanya itu loh Pak, yang 35 masih angkanya 350 terus 700 itu tuh.
Okay. Another question is dealing with the how to give the input of the discharge that we used in previous exercise is 340 meter cubic per second and 700 and 1,400. Where is the value comes from?
These values are totally artificial, only for the test. Generally, if you make the real computations, these values should be the result of the hydrological analysis. It might be maximum flows, might be some real flows observed, or something like this. So for the moment, because I knew the real data, so I just picked the values which are in the extent of the flows in this zone, in this reach, but these are not real values. These are only chosen for the test. Yeah? So the model should be, of course, in this part should be connected with, should be supplied with some data, some analysis, something what has a real meaning for the results we obtain also. Yeah.
Okay. And maybe due to the measurement data, actually, maybe dealing with the how to account or the discharge, we have a current matter, we have a cross section. Can we use this data as a base of the discharge?
Yes, it could be good to use this data, especially if you have such a data which were measured in the real system. These data are very good for calibration of the model. If you have the measurements with the current meter, I can imagine that you have measurements in several points of the cross section. Yeah.
Yeah.
This data, this might be, because these are velocities, this might be recalculated into the discharge, total discharge in the cross section, and the discharges what are put in the model represent exactly the total discharge in the cross section. No? So this is the meaning of these values. This 300, 350, 700, 1,400. These are the discharges in cubic meters per second, total discharges in cross section.
Okay. Anyone? Any question else? Okta, Hansel, Rifandi, Richard? Ada lagi? Oke.
Thank you.
Kalau tidak ada hari
Okay.
ini kita beri applause untuk Prof. Thomas. Yuk sama-sama.
Okay, thank you very
Thank
much.
you for this course.
I have one question. I see the questions and interest. So supposedly you want the next meeting? Yes, is it correct? Okay, so what should be, is my imagination is correct that we should focus on the unsteady flow and then go to the two-dimensional flow. So this is the your interest, something what you would like to see. Okay, so that's good. We may just make it, and we will see in the next steps how to create a little bit more complex models and see some animations. Okay, maybe I will also prepare new data, but I'm not sure at this moment. I need to look at the data which are in the Google Drive. So just be aware that maybe I will send the email with some information that something should be downloaded. Okay, but I, at the moment I will not promise for 100%, but we will see. Okay, so okay. So okay. So
Thank you very
for
much.
the
I
moment,
really appreciate it.
thank you very much.
How about the day for the next meeting or next course? But the day specific?
I think okay. Let me check my calendar. I think that Tuesday is okay.
Tuesday.
But I check to be sure. Okay, no, Tuesday is not so okay because at the 10 o'clock next week I have a meeting. So it depends. It depends on if we start. Can you start at 8 o'clock or no?
Yeah, of course, for sure.
My 8 o'clock in your time.
Yeah.
Last time it was the lunch in your location.
Yeah, in Indonesia it's 1 o'clock.
Okay, so can we start this way? Then we have 2 hours before my next meeting at 10 o'clock.
Yeah, okay, it's good. It's
Okay,
perfect.
so in this case we could use we could choose Tuesday and have a meeting on Tuesday. Especially it's important because in Poland the next week Wednesday, Thursday, and Friday we have the days off because of some celebrations, the labor celebration. We have also the day of Constitution in Poland. So these celebrations are connected, and we have a relatively long time without lazy time without working. It's also so we need to use Tuesday. Okay.
Okay. Yeah, let me check again. So the next meeting is Thursday, April. So yeah, 30,
Okay.
30 at 8 o'clock in your time.
8 o'clock. Yes, in my time, 8 o'clock. Okay.
Okay. Thank you very much.
Thank
Have a
you very
nice
much.
time and nice day. See you. Thank you. I really appreciate it.
See you.
Bye.
Thank you. Bye.
Bye. Bye, Trabika. Bye-bye.
Thank you. Future, because I remember your questions and the problems raised. So maybe today I suggested that we just focus on maybe 1 or 2 things. It depends what we manage to do. I would like to talk a little bit about the unsteady flow. This is necessary to just go further. If we want to focus on two-dimensional modeling, if we want to just use the precipitation in the modeling and this kind, we need to make some exercises with unsteady flow, even with in one-dimensional case. So this would be the first task, and we will see how much time it takes. If we have more time, we may also make some introduction to two-dimensional modeling with this data we have. And in my opinion, it will be enough if we are not if we will not manage to make the second task, we may just continue in the next 2 weeks. If we manage to make the second task with the two-dimensional modeling, we may think in the next 3 weeks, not 2 weeks. In the next 3 weeks, we may think about the rain, the rain in the two-dimensional models and this kind of issues, which are more advanced and some previous steps needs to be done before we go there. Yeah. So this is the idea I have in mind, just to go slow, maybe not slowly, but smoothly from one point to another without leaving anything just behind us what may destroy our perception, our point of view on this what we have in HECRAS. Yeah. Okay.
Okay. Wait a second. Thomas, I should discuss to my student. Sepertinya Prof. Thomas nggak punya waktu lagi setelah sekarang. Jadi ada 3 minggu lagi. Sedangkan kita harus pakai. Nggak apa-apa ya, saya bilang sama Thomas, kita coba dulu. Untuk hujan, masukkan data semua, nanti 3 minggu, minta tolong koreksinya gitu aja. Oke. Yeah, Thomas, I've already discussed to my student because we also consider about the time in our schedule, in our university schedule. We do agree about next plan about the 3 weeks meeting, but actually all my students, we try to discuss and they do agree to. They try to give the information about bathymetry, about the rain. They will learn it autodidact, no problem. We need your look like calibration every week in check our works, my student works, true or not. Do you agree? First, we try to learn by ourselves. We try to put in our model because we should consider our university time because they will give presentation too based of their work, of course. And next 3 weeks, all of my students will present to you about their own project. With respect to, yeah, do you agree?
Yes, I agree. I agree. So it means that we are doing this what I said today, and in the 3 weeks we may just talk about your projects. We may just go further. It depends on what we have. Okay.
Yeah.
Okay.
Okay. Thank you very much.
Okay. First of all, let's start. Maybe I will share the screen just to show you what we need for the first exercise. Okay. So let's do it. Do you see my screen?
Yeah.
Yes. Okay. This is the Google Drive, and the data in the Google Drive for the first exercise. I would like to use not exactly data, but this what we have in the models. This what we have in the models. We will try to import the data from another model, from another model to our model. I think it will be faster, and it will be also something new, what was not tested before. So you see these features. To make reasonable simulation of unsteady flow, we should have a little bit larger model than the model we tested before. So let's use this model 1D version 2, which is similar to version 1, but is larger, basically. Yeah. If you have this on your disk, you don't need to download it. If not, just download it now. And finally, you should see. Okay, you should see the model in such a you should see something like this, that zip is in your drive, and the zip should be unzipped in some folder inside the folder for our exercises. Okay, so we prepare just basically step by step the environment for processing. So I will start with the new folder, exercise 03. Here I will prepare the subfolder model 00 as a base model, which will be used later just for taking some data from this. And I basically unzip all the content of the model 1D version 2 to this subfolder. So please prepare something like this. And this is
modelnya semua.
Yeah. Okay. And this is exactly what is, of course, the same what is in the Google Drive. Okay.
Bisa dipindahkan? Coba. Excuse me, Thomas. I think your voice cannot hear clearly. I don't know what's happened.
Okay, should I repeat something?
Kenapa ya? Yeah, because the sound we cannot hear clearly.
Okay,
Okay.
once again, okay?
Yeah, it's okay.
Okay,
Yeah.
as previously, generally, I prefer to prepare some space for working for preparation of the model. So generally, this is the space you see in my previous folder with the exercise 01, 02, 02B, and generally I prepare here the folder which is called exercise 03. So this is the next exercise in
Buat exercise
our process.
03.
Yeah. In this
Okay.
exercise, I would like to have the base model copied from the Google Drive. So I prepared the folder for this model, model 00, for example. Yeah. So this will be my base for preparation that our model, but I will just pick some elements from the previous model. Okay. Okay, so I opened this folder just to be here, and what we need in the Google Drive. In the Google Drive, let's look at the Google Drive. This is Google Drive. You should have access to this Google Drive, to all content which is in this Google Drive. I send the link, and this is open. Just there is an access for everybody who has the link. In this Google Drive, you have the folder with the data, and you just downloaded the information, the data from from this folder. But I don't want to take the data now the pure data. I would like to use the model, one of the models. Okay, so I will just look at this folder. We have the models. The model 1D version 1 is the model we prepared before. We're working, and the final stage is also here. You may check it with this what we were doing during the exercise. But this model is relatively short. The reach is about 7 kilometers, and if you want to simulate the unsteady flow, the effect may not be impressive. The effect will be really small. So it's better for unsteady flow use larger model. The preparation of larger model is very similar the preparation of the shorter model, but of course the time is longer and more effort is needed. But we use the model which exists, just picking some elements from this model and working with our own model. So this is the idea, okay? So we need this Modelo 1D version 2. We need this zip. Yeah, so if you don't have it in your disk, in your computer, just take it now from the Google Drive. Yeah. And if you have it in your drive, as I have here, you just can open it in the Windows and basically select all elements and move to the prepared model 00 folder. After this operation, the files will be unzipped and the model 00 will be available for other applications also. Yeah. So this is the idea. This is what we have to do. We basically need to unzip this file Modelo 1D version 2 to the folder model 00 in our in the folder prepared for our exercise. Okay. Okay. Please do it. If you are ready to make next steps, just let me know, and we can just.
Yeah. Okay. Ready.
Ready. Okay, that's good. So I can close it, and we may focus on this folder. Okay, we generally start with HackRAS. Today we start with HackRAS. We start with HackRAS, but I need to hide video panel. No, not hide video panel. Show video panel. I need to hide controls. Oh yeah, okay. Now I'm ready. I have the access to the entire screen. Okay, we have the HackRAS 6.5. We start generally check this if you have SI units. Okay, it's important to look always in this corner, just to be sure that the units are correct. Let's start with creating new project. So we just start with new project file, new project. And generally, we should navigate to this folder. We should find this folder. If this is in the another drive, we need to change the drive.
Hah? Putus dari? Oh.
Okay. Hello.
Yeah, that
we
you
had
interrupted. Yeah, okay.
Okay,
You can
we
continue.
have interaction. Okay. Okay, let's continue. So let me share the screen. Okay, so we started with the HECRAS. Yeah, HECRAS is ready. I told you also that you should just check if the units are okay. Yeah, the units in the right bottom corner. If we are ready, we can just start with the file new project. File new project. In this window, we should just find this folder for our processing. So I need to change the disk, the partition, and go to the proper folder, exercises, exercise 03, and I'm generally here. Yeah? This is exactly the same folder. I say it here. We can just give some title of our exercise project 03, and I will add the date 0507. Okay, so this is my title of the project. File name may stay as it is. It's okay. So I will be able to recognize properly what is the file of the project in HECRAS. Yeah. If we are ready, we have the title, file name with the PRG extension. Here we may press OK. And we need to confirm that we are just creating the project with in such a file with such a name in such location. Okay, everybody?
Yeah.
Okay, let's go further. I need to check one thing. In the model 00, I see that we don't have the information about the coordinate system, but we just borrow the coordinate system from the previous previous model. So supposedly you have your previous model also in the same folder. Yeah, is it correct?
Yeah.
That all models are in the same. So if all exercises are in the same location, it's okay. I will not copy any file. I just go to another location when I need the coordinate system. Okay. So this is remembered to have in mind where are the previous exercises. So let's start. It's good to start with the RAS mapper. You know, let's start with the RAS mapper. With the RAS mapper, we may open RAS mapper and maximize RAS mapper. As you remember, that just working with the RAS mapper should start with setting the projection, the coordinate system. So let's go to project, set projection. Yeah? Project set projection. And we need to find the file which stores the projection for our project, because this is the same region, the same country. The projection is also the same. So let's go here. The folder of our exercise is open. We should go up to the previous folder with the previous data. And in the data, you remember we have the files with the extension PRG, which are the elements of the shape files which were used to create the previous model. In any of these files, in each of these files, we have the same coordinate system. So it does not matter which of them is chosen. Just take one and press open and let it be displayed here, and the content should be visible here. Yeah. Is it correct?
Yeah.
The coordinate system should be ETRS 1989 Poland CS92. So this is the name of the coordinate system, and everybody should see the same. Yeah. Okay. Let's press OK. Coordinate system is set. We may save in RAS mapper.
Excuse me, Thomas.
Okay.
Excuse me, Thomas. I have a question dealing with the coordinate system. Can we back again? How do you choose? Is Universal Interpolator UTM or not?
No. I'm not using UTM. I'm using projected coordinate system specific for Poland. specific for Poland, because the region is in Poland. Generally, in Poland, we use two coordinate systems. I will explain it maybe shortly with some lecture I use because I have pictures which explain the coordinate system in our country. I'm also doing the lectures on geoprocessing in my university. So here, okay, let me change. Okay, this lecture should be what I am explaining about the coordinate systems, but these are the coordinate systems used in Poland. Yeah, these are the coordinate systems we use in Poland. The 1992 is the coordinate system which covers entire country with one coordinate system. This is why I like it, and this is why it also used widely in the old flood protection issues, because the rivers in Poland generally may cross the zones, so it's good to have one system for one country. Second system is 2000, yeah, 2000, and this is like a UTM a little bit, that we have different zones, different belts. So we have 4 zones in Poland. We use this system, this general system in ArcGIS. This is the name of the system, and in QGIS, if you use EPSG codes, you have this code. Yeah.
Okay,
So,
it's more look like you use coordinate by orthogonal or Cartesian. Cartesian, yeah, Sing. Because the measurement, the unit is meter. That's right.
Yes. These are not geographic. These are projected coordinate systems, and the units are in meters. The distance is calculated on the plane surface also. Yeah.
Because in Indonesia, mostly just UTM or orthographic that you use degree, and another one is meter. That's why you should. This is the idea I have asked you.
Yeah,
I get the point.
UTM is a little bit different. In Poland, we have 2 zones of UTM. So our coordinate systems, even 2000, if this is similar, they are a little bit more accurate than base UTM. So we prefer use them. Yeah. So this is what we generally have. Yeah. Okay. So this is why we use such a system. Okay.
Yeah.
Okay.
Thank you. Thank you very much. Yeah.
Okay. Let's come back to this point. Now terrain. Let's just check terrain, and we just prepare terrain. Now we are not using the TIFF like previously, but we have terrain in the model 00. So we just use this terrain. Let's click right button on the option terrain here, and we may use the option add existing RAS terrain. Yeah, add existing RAS terrain, and we need to find our terrain. Terrain should, once again, the folder of the project should be displayed. Terrain should be here in model 00. We have a subfolder terrain. Subfolder terrain. If we open this, we have the terrain of the previous model, and we will use exactly the same terrain. Yeah? Okay, so let's choose it, terrain HDF, and press open. It should be added very quickly to our project. And there is one drawback: the terrain is not copied. It's still in the previous location. So we use the terrain from the previous location, and we should be careful with this. But generally, it's not a problem because we have a copy of the previous model. So we just work with the copy, and it should be okay. Yeah. Okay. Do you see it? Okay. Let's save this what we have in the RAS mapper. For a moment, we may close RAS mapper. Okay, so for this moment, we may close RAS mapper. And we may come back to the main window of HackRAS. Okay, are you ready?
Yeah.
Okay, here in File, we have some options for importing and exporting the data, but this is something what we didn't use before, as I remember. One of the options is import HackRAS data. We may import the data from another model which is ready model, working model, and we don't want to just prepare the model once again. We simply pick the elements of the another model. Yeah, let's use this option, import HackRAS data. import HECRAS data. Okay, and this is what you see. Before we just go to another location, we need to look at here in the file name. Yeah, the file name. Maybe I will copy this, what we have here, and put into the notepad. You don't need to repeat this step. Okay, what's going? Okay, I need to copy once again. Okay, and maybe. Okay, this is what we have in a file name. It's quite interesting to just to focus on this for a moment, because I don't know how familiar are you with the operating systems. The star in the name of the file. This is old convention from the DOS operating system. This is the star generally replaces several signs. So stars in this places may be. This is the representation of some name, you know, some name, and here we have some continuation of the extension. So the generally this semicolons just show us different convention for naming files in HECRAS. So we may choose the files which just fit this patterns, yeah, these patterns which are available here.
Nama file titik kan ada nama extensionnya sebelahnya.
Okay.
Ya, ngerti ya? Okay, you can continue.
Okay.
I ask one student,
Okay.
yeah.
So, for example, we have some name here, and we may also find here some numbers. Yeah. So name dot J01 means the geometry of the project with name first geometry 01. Yeah, and the numbers represent different geometries which are just added to the project. This is the geometry file, the convention for geometry file. This is the convention for the files with the flow data. This is the convention used, the pattern used for the unsteady flow data. This is for computational plans, and then we have also some a little bit advanced, like the quasi unsteady flow, sediment transport, water quality, and this kind of files. Yeah, so we need to find now, because we are looking for a geometry. We would like to take geometry from the previous model. We need to find the file which just fit this pattern. So this is something what we really need. Yeah, this is something what we really need. Yeah, so this is this I would like to explain to make it clear that you understand why we just make the next steps. So we are in HECRAS now. In file name, we have some patterns, as you see, for files. We see the content of our current folder. And now we should go to the folder model 00. Open this folder, and we see the content of this folder. These are not all files which are in this folder, but only these which fit this patterns. Yeah. So only these which are recognized by HECRAS. I would like to find the file which represents the geometry of the model. So I just remove all of these elements and leave only star.j the star.j star. Yeah. So this I will leave and press enter. You see that the list is shorter, and now I have two files. Maybe I will just magnify. This is what we generally have. Yeah. The list is shorter because other files are hidden. We have two files which are available in this model. This is J01, geometry number 1, which is called geom01. And we have a file which also fits this pattern, but this file has double extension. The real extension of this file is HDF. So this is not exactly what we want. We want only the file with the extension G and number. Yeah. So this is what we need. So let's choose the first file. Yeah? This file. This is our geometry of our model. Yeah? Okay, everybody. Okay,
Yeah,
the question is now, if I need to repeat all these steps, because it might be a little bit complex now, if you don't understand anything, just ask now. Maybe we repeat, maybe we will talk about it a little bit longer.
Yes, let me ask my student first.
Okay.
Udah bisa ngikutin semua? Can you heard my student voice?
Yes, but not loudly. It's rather very weak.
Pakai mic.
Soalnya saya bertanya proyeksi. Dia pakai proyeksi pola. Kalau yang Indonesia ada pakai
Wait a second, Thomas. I deliver the mic.
Okay.
Okay. You have shown that you got the projection in one a certain website. Is there any alternative for Indonesia?
Honestly, could you repeat because I don't hear well what you are
Pelan-pelan,
talking.
pelan-pelan. Agak harap pasang aja nih.
You are muted now at the moment.
Even cannot. Ya. Cek nyala nggak lampunya coba? Hah?
You need to unmute the microphone because the microphone is muted at the moment and I don't hear anything.
Kejauhan mungkin kejauhan.
It's not only the problem of microphone. The problem is okay. Now it's unmuted. Yeah. Okay. Okay.
You have shown that the projection that you get from the website. Is there any similar website for Indonesia?
I don't know if I understand because you ask about the project which is taken from the website.
Projection yang UTM tadi nggak masalah, kita udah tahu.
This project.
Yeah, maybe as I got the question as far, he have a question about the projection that we discussed already. Indonesian use UTM.
Yeah. Okay, so
no problem. Yeah.
In Poland we use as I just presented these two projections for our local projects, national projects of any kind. Generally, this projection is recommended and used mainly in the GPS measurements. But generally, when we just implemented the flood directive, European Union flood directive, we needed the projection for entire country, and so this is why we use this projection. Yeah, and generally, in the majority of the models is prepared with this projection because some generally the rivers, huge rivers in Poland, in the scale of Poland, of course, crosses the borders of the zones. So it's better to have one projection for country. But of course, the scale of the country in Poland is spread. Extent of Poland is much smaller than extent of Indonesia, and we still have huge accuracy with one projection for entire country. If the country is larger, it might be not so easy, because projection also introduces some distortions, some errors, and generally the projections are not perfectly accurate. But for projects in Poland, it's enough. It's enough that the country is generally relatively small in the scale of other countries in world. So we may use one projection for Poland. Okay.
Oke, just one second, Thomas. Ya, jadi kalau di Poland, ini ada yang CS 92, ini khusus di sana saja. Jadi kita punya UTM, kalau nggak salah di Surabaya 49S ya kemarin ya. Nah, kita pakai yang itu. Jadi itu sudah, jadi Departemen Pertanahan, BPN, apapun semua se-Indonesia sudah pakai format itu. Kita nggak usah pakai yang lain-lain. Jadi bisa pakai UTM. Nanti saya jelaskan. Ya harus disamakan, kalau nggak sama nggak pas. Loh. Nah, kalau di sana ya dapatnya dari punya Poland. Oke. Another question, Thomas. That to ask you, where do you get the file projection? Yeah.
Okay, file projection generally, if you remember the previous exercise, previous exercise, exercise 02, we use this data, which I have now in the folder data, and generally they are in the disk in the Google Drive. They are here in the data folder. Yeah, we have base data for preparation of all models. Yeah? So now we are using the model which is ready, just to jump over some steps, steps which were done and explained with the shorter model, but the data are generally here. The data I have in the disk from the previous exercise, they look like this. So this is my folder. I have the shape file of the cross sections. We use it. I have the shape file of the potential flow paths. So of course, this several files means one layer, yeah, in GIS. We have also the river banks here, yeah, and we have also the river center line. And additionally, we have the digital tree model, but digital tree model is not important now. In each of these shape files of this structure with several files, we have such a files like SHP. So this is the main file with the geometry. We have a file DBF with the attribute table, and we have the file PRG with the projection of this of this layer. Yeah? So each of them stores file PRG here and also here. So these are PRG files which stores the projections of each layer. No? Okay.
Yeah. Can my students share how they get the information PRG file?
Look at the previous exercise. Exercise done last time. Look at the data which were used for this exercise. Okay.
Bisa enggak? Bisa. Oke. Ya. Berapa?
And
Yang lain bisa?
if we have
wait a second, Thomas. We still discuss. Ini projection loh. Sekarang masalahnya gimana? PRJ-nya enggak? Kalau di dia kan sudah ada ini. Tinggal kalau di kita gimana gitu. Nah, kalau cara install itu kan hanya 49S ya. Ya, berarti gimana caranya? Di save as-nya ya, ketika di save. Oke, berarti Thomas bisa lanjut ya. Okay, Prof. Thomas, we can continue. Okay, thank you very much for your time.
I would like to show you one more thing about the PRG files, maybe just to complete the information. If you look at the notepad and you just move the PRG to notepad, you see the content of this file. Yeah? So this is the definition of coordinate system. It's a text file, and this is exactly the same what we see in HECRAS when we import the file. Yeah? So this is what we have. I don't want to split all the elements. You see that we have some parameters, the definition of the main axis of the coordinate system, and such elements which are important for definition of the coordinate system. But important for us is, because I'm not going to create my own coordinate system, I would like to use the predefined coordinate systems. So this is the name of the coordinate system. Yeah. So this is how we can recognize what we really have and what we really use. So we are not defining, we are using from the layers which exist. Important thing is that we should recognize the we should understand the difference between PRG, which is a project file, and PRG used previously for definition of the coordinate system. The extensions are the same, but the content of the file is not the same. So this PRG, the project file, is different because it generally stores the information about the project. Yeah, so this is not the same. You know, if we look for the projection file, we need to know where our shape files are located and just pick the projection from the shape file, which let us to use properly define the projection in the RAS mapper. Okay. Okay, now it's clear. Yeah. Okay. Okay, let's go. Okay, let's come back here. Just start again these steps. We have the project defined. We have the GI in RAS mapper. We have the projection and terrain just added, taken from another model. So this is okay. All the saved elements are here. Here we have the previous model. Yeah, and we would like to take the geometry from the previous model. We use this option, file, import HECRAS data. Yeah, we use this option file import HECRAS data, and we need to go to the location where our geometry is. So this is the model 00. I double click on this. Yeah, and I have the list of available files, the files which can be recognized by HECRAS and can be imported by HECRAS. And these files, of course, reflect the patterns which are here. So the patterns were just explained what they mean. I need only the files which just represent this first pattern, star.j star. You know? So this one. So I remove the rest and press enter here. You know, press enter here. So I see the shorter list with the files which are potential geometries. Potential, not exactly geometries, but potential. They basically fit this pattern we have here. I see the first file with extension J01. So this is the geometry of the model, supposedly. Second file is also geometry, but written in another format, not the format we want. HDF format is another kind of format. Maybe we just leave the discussion about the HDF format and we focus only on the geometry. Okay. So pick the Geom01 from the previous model 00 in our case. Just select it and press OK. Yeah? And press OK. And the geometry should be very quickly added to our project and should be copied here. Yeah? Here we have a copy of our of the geometry. So we are not working on the previous geometry, but we are now with completely new copy of the geometry, and we should not be afraid of destroying it because the original version still will be the same. If we open edit geometric data, we should see what we have, what is the geometry of this model. It may happen that the digital terrain model is not displayed. Yeah, so it may happen. In my case, do you see also the digital terrain model? Yes. Yeah.
Yes.
Okay. So for a moment, just okay. So we leave this problem if the digital terrain model is not displayed. We may talk about it a little bit later. Yeah. So this, yeah. Can we go further? Okay.
Yeah, you can go.
Okay.
Yeah.
So if you zoom with the wheel, this zone on the left, if you want to move, just press Shift and you may move your map. Okay. You see exactly the same part which was modeled before. Yeah. So the previous exercise is still element of this model. Yeah. Of this model. This model is also prepared in such a way that the bridges are modeled a little bit more precisely. You see several cross sections around the bridges. This is done just to avoid definition of the bridges, which sometimes cause problems, but properly model the topography of the bridges. Yeah. So such a trick is used in this geometry, and we will stay with this trick. If you just move and zoom several sections of our model, you see quite complex topography here. We have another city here, which is called Oborniki, And okay, I will just show you the map for a moment in Google of this zone. Let's have a look in the map. Okay, we are exactly here. Exactly here. No. One moment. Okay, we are here. This is the ridge here between Oborniki and Wronki. Yeah, we have the river, and this is the Oborniki city called Oborniki with the river and connection with the tributary which is called Wełna. This is another river. Yeah, and then the river according to the map is going through the villages and one more small city which is called Obrzycko, and then goes to okay, this is another small city, and finally, okay, no, not too much. No, this is Wronki. Yeah, this is Wronki, and this is the end. Yeah, this is the end. So this is what we have. The basically, oh, okay, this ridge. Yeah, this ridge in shown in the Google map. So this is what you have, the Oborniki with the Wełna river. The bridges in each case are represented by at least four cross sections, and we have some dikes. If you just look at this, what is defined, and move farther, you see the same topography like in the Google, with the meandering river. Step by step, we go to another city. Yeah? Maybe you remember, as a homework, I used also a parts of these models. So these elements were just cutted to make the data for the homework. Yeah, so this should be something what you also remember. Yeah, so the model is utilized several times for different tasks. And this is what we have. We have the inlet here, another inlet, smaller inlet, and we have the outlet. This is important. We have the outlet here in this zone. Yeah, in this zone. Yeah. Okay. So this is our model. If you look also in the cross section, okay. Before we go further, just look here because this is something new. This in this place we have two rivers which connect, and in this place we have the junction. Yeah, junction was not defined before. The junction, if we click on the junction, we may just open the parameters of the junction. Yeah, parameters of the junction. Junction might be also open from here. Yeah, from the left toolbar, the first button is a junction. These distances, which are quite important, are the distances from the junction to the upper cross sections. Yeah, to the upper cross sections. So this is the one distance, yeah, and the second distance. Yeah. So these distances are important to define the junctions. Okay. If junction is one case, but sometimes we have also bifurcation. So the one river is split into two rivers. It may also happen, not in this model. In such a case, the distances are not defined to the cross section upstream, but to the cross sections downstream. Yeah, remember this. Always we have two distances. One is the upstream in the case of junction. If we have bifurcation, we have the distances to the cross sections downstream. I need to explain also one more thing, because you see connected cross sections. In fact, they are only connected geometrically. Not the flow is not coming between them. I prepared this model in such a way just to introduce maybe later in the future the structures which may connect and may let the flow, flat flow, to be transited just directly between the cross sections. But at the moment, it's not working this way. Yeah, so these are just cross sections, yeah, of this shape, and nothing more. Okay. Okay, so this is the topography. This is the topography, and if we look at the cross sections, yeah, at the cross sections, these are the cross sections as you see, with some base roughness coefficients. Generally, the cross sections are now ready for work. Yeah, we don't need to correct anything in the cross sections. We may focus on them. Okay. And we need to also remember that we have in this model two rivers. One is called Warta, second is called Wełna. And the Warta River is split into two reaches, odcinek 1, odcinek 2. Odcinek in Polish is reach. Yeah. So two reaches because the junction, anytime we have a junction just splits the river into reaches, two different reaches. Yeah. Okay. Is it clear?
Yeah.
Okay, so this is what we have in a model. We need to just remember just to be familiar with this, what is defined here. Yeah. If for a moment now we can go, we can open RAS mapper after this operation. And you see the terrain as previously, but we may also just select our geometry and display our geometry. Yeah, so we have junction, we may show junction. Bank lines are not available because we didn't import the bank lines. We imported the ready geometry, entire geometry which was prepared, and the lines bank lines are used only in the preparation phase, as well the flow paths, so they are not available in this model, but all the parameters are defined. And we have also cross sections. Yeah, cross sections, and in the cross sections, yeah, this is all. We don't need anything more. Yeah, so this is our geometry in the terrain, in the RAS mapper. If we have a problem with a display of the terrain in the geometric data, sometimes it happens, we should just click on any of these options, geometry, maybe terrain. We have the same option, manage terrain associations. Yeah, in such case we need to open it and check if the terrain is correctly adjusted to the geometry. If this is correct, we need to only open and just confirm clicking close. Yeah, and it should cause that the terrain is added, is connected properly to the data, and we can display the terrain also in the geometric data. Okay, ready? Okay, let's close it and let's focus on our project in HECRAS. Yeah? Now, new elements. We just go to the new elements. We should just go to edit. Now geometry is ready. We may focus on the flow data. You remember that we started always with the steady flow data, and generally when the model is prepared first time, it's good to start with the steady flow data. But we avoid this now because this is quite simple, and I'm sure that everything will work correctly. So I'm not going to use this option, steady flow data. I go further to the next step. Next step is unsteady flow data. Yeah, next step is unsteady flow data. Okay, let's go to unsteady flow data. Let's open it. Okay, let's open it. Ready?
Yeah, ready.
Okay, this is the window of the unsteady flow data, and we have several tabs here, as you see, several tabs here. We have, first of all, we have boundary conditions, and boundary conditions, the table which should be prepared fits this what we have in the model. So all the inlets and all the outlets should be here. You know, should be here. We have Warta River, odcinek 1. This is the inlet. Wełna River, odcinek 7. It's called 7, but it does not matter what it is. We have, this is the second inlet, and we have the outlet in Warta odcinek 2. The last cross section is the outlet. Yeah, so we should set the boundary conditions for these cross sections. If you click on these elements, you see that different options are available here. These are the boundary conditions which might be imposed in each cross section. In the inlet cross sections, this and this, we may impose hydrographs. This might be stage hydrograph, flow hydrograph, or mixed hydrograph, stage flow hydrograph. In the outlet cross section, we have additional options like normal depth. We used this option before, as I remember. the normal depth was imposed in the previous model, or rating curve. Rating curve is a relationship between stage and flow. In particular cross sections, such relationships may be determined on the basis of the measurements. Yeah. So this is another approach, and this is what we have to do in the first step. But before we go to and start working, let's have a look here. We have, as I said, several tabs. Boundary condition is the first. The second, which needs to be prepared also, is initial condition. Yeah, but initial condition will be just connected and should follow the data which we put in the boundary conditions. So we just focus on this a little bit later. Yeah. Okay. So initial condition we just look there a little bit later, and I also explain what the initial condition is. You also see, I know that you just look at here before, meteorological data which let us define the rain, but we will use this option later, yeah, during the some of the next meetings. Okay. So this is what we have, and observed data, some measurements. This kind of data might be used for calibration of the model, for example. Yeah. So these options are a little bit more advanced. At the beginning, we don't need to have them. We don't need to use them, but we need to use. This is really necessary, and we will not be able to run the model. We need to set boundary conditions and initial conditions. Yeah. This two. Okay, let's focus on this. Okay, let's focus on this, and let's start with the first inflow, large inflow, which is the Warta odcinek 1 in this cross section. Yeah, this cross section, this river station is the river station of the first cross section, the inlet cross section in the Warta. Okay, here we have the option stage hydrograph, flow hydrograph, and stage flow hydrograph. I would like to use this one in the middle flow hydrograph. So we imagine that we have some flood wave which will be introduced into our river, and then we just look at the propagation of this flood wave. Okay, so let's just click on this, and this is what we have. Okay, everybody. Okay, now we have to just see that we have two options here. The first option, which is not chosen by default, is the read of the hydrograph from some file prepared before. HECRAS uses the format of the file called DSS, data storage system. This is specific storage system for HECRAS. It might be used if we have, for example, data prepared with another model, with another program from HEC web page. So this data, these results are generally stored in this format. For us at the moment, it's not the option. So we leave it just not selected. We focus on this, on this part. We have the option which is called enter table. What means generally that we need to define the table, and we need to explain how the table is prepared. First of all, each table, each hydrograph, which is just presented in the table, each table needs to have constant time step. So each row just represent one data, and these data are equally spaced in the table. We may just overcome the problem related to this kind of the data, but I will show it just a little bit later. Yeah. So for a moment, let's assume that the 1 hour is good enough for us. Yeah, for 1 hour, we should also remember that this is the time step of the hydrograph, but not exactly time step of the computations, because computations may interpolate between these values, and it's okay. The value, the hydrograph will be reconstructed properly. Yeah. So for a moment, 1 hour is enough for us. Of course, we should be aware that this time interval should fit our data, what we have in, for example, our measurements or some potential hydrographs prepared. So, for example, if we have the daily flow data for 1 year, we should use the time interval, which is basically 1 day. Yeah. One day for the simulation, which includes entire year, but we use now only shorter period, so 1 hour is okay. Now our table should start in one point, so we need to define this starting point. So the first option is, let's say, fixed start time, when we define the date and the time. Yeah, but hackers give us another option which is simpler, especially very good for potential simulations. Use simulation time. So later in the computational plan, we define the beginning of our simulation, and this beginning of the simulation will be taken as the beginning of our hydrograph. It's good for us. We don't need to set the start time manually. Start time will be just copied from the computational plan. Okay, so this is why we stay with this option. Okay, is it clear for a moment? Yeah. Okay. Now let's go here. Yeah, this is more serious. Now we have, as you see, the column of the dates. Now this is the default dates. We don't need to care about them, but we have something a little bit more important for us: simulation time, which is just the cumulative time, starting with the first row, and then we see that the time interval is added. Yeah, time interval is added. So this is real time for us, time of our simulation, just with reference to the beginning of the simulation. And we have these two columns are just made automatically. We don't have the access to the values here, but here the last column, flow, with the values in cubic meters per second, is something what we need to set. Yeah, something what we need to prepare. Okay, is it clear?
Yeah.
Okay. Now, now. Okay, let's go further. We have some number of rows here. This number of rows, the length of the table might be changed. The length of the table might be changed with this button, number of ordinates. You know? Number of ordinates, default value is 100, and in the older versions of ECRAS, it was not possible to use lower values. So 100 needs to stay. I suggest to leave it. But of course, if we have a annual hydrograph of daily flows, what is the number of ordinates in this case?
Daily flow ordinate berapa?
Annual hydrograph of daily flows.
Annual.
It means the hydrograph for 1 year with a flow each day. So what would be the number of rows, number of ordinates?
Berapa number flow-nya dalam ordinate selama setahun? Tahunan.
It's exactly the number of days in a year, so 365 or 366. So this is exactly what. Yeah. Okay. So this is the idea behind the number of ordinates. How many data we have, how many rows we have in the table. This number should be here. Okay. 100. We will stay with this. So let's start defining our data. I will just prepare very artificial hydrograph, not real, but it's enough for testing. Yeah, for making an exercise, it will be okay. Yeah, okay.
Wait a second, Thomas. I should discuss first. Ya, jadi ini kan yang kemarin waktu ada latihan dulu, yang siapa ya, yang Richard kasih tahu itu loh, yang direct series. Sama kalau kita di yang mau kita masukkan dari dev kan kayak gini juga datanya. Nah ini kan kita lihat datanya per jam-jaman. Nah kalau tadi cerita Thomas, dalam 1 tahun itu tergantung apa, jumlah row, jumlah baris. Ya, jadi ditanya tergantung 1 tahun berapa hari, 365, 366 hari kan, tergantung tahunnya tahun apa. Kalau kabisat lebih banyak kan, yang 4 tahun sekali itu.
Oke.
Ya tergantung kita desain berapa. Nah, misal oh ya bisa, kalau kita 10 tahun 1 hari bisa. Iya, 1 tahun 1 simulasi. Misalnya kita kan 50 tahun yang akan datang, simulasinya per hari, nggak akan mungkin per jam nangis komputernya. Ya, gitu ya. Oke.
Okay, so
Nah,
please follow me, okay? Please follow me.
Yeah.
I will start with the flow 150. You should remember that in the previous
silakan
test,
coba yang punya ini 150.
in the previous test, in the previous exercises, this minimum flow we used was about 300. Yeah, so now at the moment, because this is the same river, still the same river, we assume that we have relatively small flow just in the channel, in the channel. So we start with relatively normal conditions in a river, 150 cubic meters per second. This is good for us. Okay. Now we assume that this flow is relatively constant through 6 hours. So I will write here in the 6 hour 150 also. Okay, I will leave the rest of the cells empty. Yeah, the rest of the cells is empty, and I will not care much about them now. Okay, so I have from 150 go to 150 here. Yeah? Now I have the beginning of the flood wave of, now I do not care much about the shape of the flood wave, but I assume that the peak of flow of this flood wave is in the 12 hour, and this is about 600. So this is the moderate of the flows tested before. Yeah, so we should expect some inundation zone close to the river. Okay, so at the 12 hour we have 600. Ready? Okay, now let's assume that this is the peak of flow. So now the flow is decreasing, and in the 18 hour, we have once again 150. So we have the flood wave and then jump down. Yeah, okay. And we assume that we don't have another flood wave during some longer time. So at the end row, we also write 150. 150. Okay, ready? So these are the key points of our hydrograph. Now I basically select this column, clicking on the head, and I use this button, interpolate missing values, just to fulfill the rest of the cells according to these key points. Okay, so let's select the column and press this button, and we have other values just generated by interpolation. Okay.
Okay.
Ready? Let's use this button, plot data, to see what we really have. Yeah. So okay. One moment. This is the plot, the graph of our data. This is our hydrograph. It's not real hydrograph, but it's enough to make a test. Okay. So of course, if you would like to obtain real results, we need to use real data. But for a moment, I assume that you understand how we work and what is the composition of the model, which might be implemented later. Okay. Yeah. Okay. Let's close it. Let's come back here. The first hydrograph is ready, and for a moment we just stay with this what we have.
Thomas, I have a question.
Yeah. Okay.
We still have a big discussion how to maybe to give have a instinct. Example, you put it the first flow is 150 meter cubic per second. And can you show us exactly based of the cross section? Can we assume the number of the flow is about 150 meter cubic per second?
Yeah, of course. Okay, at the moment, just let's press OK here. And you see that the boundary condition is imposed here in this row. Quarta, odcinek number 1, river station this. And we may just look at the geometric data, and this is exactly this cross section. This cross section, if we look here, this is the cross section where we impose the hydrograph. The hydrograph is defined for this cross section. The next cross section we just put the hydrograph is this one. Yeah, so this will be the next. Okay, I will close it. So let's go now to Wełna, odcinek 7, this one. Okay, and here we define also flow hydrograph. Let's click flow hydrograph. The picture, the window is the same, but this time river is smaller. So we assume that the hydrograph is a little bit lower than previously. We still have 1 hour here. We still have use simulation time and 100 rows. This is enough. But we start with maybe 30. Okay, 30 cubic meters per second. At 6 hours, we still have 30. And let's have at 12, 120. Okay, and in 18 we have one more time 30. Okay, and let's go till the end. To make interpolation we need the last value, and it will be also 30. Okay, ready?
Yeah.
Okay, if ready, we just repeat the previous steps. Just select the column and press interpolate missing values. Press interpolate missing values. You should see that the missing values are interpolated. Okay, we may press OK. We may press OK now. And now here in this window, we have also the icon to show the plots. Okay, but we need the plan time window. Okay, it's so at the moment we are not able to open the plots and compare them. But anytime you can just by double clicking go into the previous boundary condition and use this button. You see that the hydrograph is very similar but smaller. Yeah, but smaller basically. Yeah? Okay, so this is what we have. Boundary condition is set. Now let's set the outflow boundary condition. Okay, so let's go to the Warta odcinek 2 344. If you look at the geometric data, now we are exactly here. Yeah, at this cross section and the outlet. Okay, so we are in the outlet. Let's select. I don't want to define the hydrograph generally. I would like to define some relatively simple boundary condition just for the first test, and the most simple is the normal depth. Yeah, normal depth. So let's select this cell and press normal depth. In the normal depth, the Manning equation is solved. So the only thing we need to define is the slope. Let's assume that the slope is something like an average for lowland river. So this is 0.0002. Okay, so I assume that this is our slope. In general, it should be the bottom slope. So we may even look at the cross sections and measure or recalculate the slope more precisely. But for the moment, such an approximate value is enough. Okay, ready? Let's press OK. Yeah. Boundary conditions are defined. Do not forget to save unsteady flow data. Okay, it's important and to save from time to time. We can call them unsteady 01, maybe something like this. Okay, it's up to you what is the title of your data. Let's press OK. And we should see that new file with the extension U01 is created. Yeah, so this file is created. It stores this data exactly. Okay, can we make next step?
Yeah,
ready?
Yeah.
Okay, let's come back here to initial condition. Yeah, initial conditions works this way, that we can have the restart file. So restart file might be used, and then generally we can just use the effect of the previous simulation. Of course, we don't have the previous simulation, so we are not going to use the restart file. However, the restart file might be just generated. This is a little bit more advanced option. As I remember, this might be also generated from the steady flow conditions, but I'm not sure now. At the moment, we don't have this, so we just go here. Yeah. This is the entire initial flow distribution. It works in very similar way to the steady flow condition, because at the beginning, the unsteady flow simulation starts from the steady conditions, unless we use some restart file. Yeah? So the another option is to use restart file. So theoretically, the assumption is that we start with the steady flow conditions, and then we have the flat, which just is coming to the system. So this is why sometimes it's good to just prepare some longer period with the steady flow, just to let the conditions be steady, and then we have the flat. So it's not the by accident that I started with the 6 hours of the constant flows. I just wanted it because I assumed that at the beginning you have steady conditions. The steady conditions should be stabilized, and then we have the real flat. Okay. Now we should define the flows in the reaches. In the particular reaches, we have 3 reaches at this case. So this is good for us. Of course, the reach might be splitted in more sub reaches, and we may define more flows along the reach with this button. But at the moment, we don't want to have too complex model. So at the moment, we focus on the most base approach. So we have 3 reaches, and in it three reaches, and in reach we need 1 discharge. Yeah. But of course, the discharges here should follow the rule that if we have the junction, the flows in the junction should be added, and then we have the discharge in this reach below. Yeah, is it correct? Yeah. Okay. Okay.
Okay.
Okay. This is the first rule. I will show you for a moment maybe the geometry. So if we have the flow, one flow here and one flow here, so the flow here should be the sum after the addition should be the sum of the flows in the reaches which are upstream. Yeah. So this is quite clear that the flows collected from both reaches just go down. Okay. Okay. And this is one rule. The second rule, because this is initial condition, so we should start with the same values which we have in boundary conditions at the beginning. Yeah. So we should not use different values because it causes some instabilities in the beginning. So as I remember, in the Warta odcinek 1, I have at the beginning in boundary condition 150. Is it correct? You remember 150?
Yeah, correct.
In the Wełna odcinek 7, we have 30. Yeah, you remember this. So in Warta odcinek 2, we should have the 180. Okay.
Yeah.
Okay, so everything is defined. We don't have any storage areas or 2D flow areas, so we are not going to define the initial elevation. Okay. So let's save. So this is how it works. We have also another option, as I remember here. We may just set the initial stages, but this is a little bit more advanced. So at the moment, I'm not going to talk about it. But this is another method to define the initial condition. You may remember for a moment that it is possible, but there are also other options, but we are not using them now. Okay. Everything ready?
Yeah.
Okay, let's close this. Okay, let's remember that we saved this window and let's close it. Let's close it. You see that the unsteady flow data is ready here. Okay. Let's go now to run. Let's go now to run. And let's use the second option, unsteady flow analysis. Unsteady flow analysis. Okay. So we have the window of computational plan, but this time this computational plan is a little bit more complex than previous computational plan. But the beginning is the same. We go to the file and use new plan. New plan. And we should give the name for our plan. It might be plan, let's call it flat 01. Okay. Plan flat 01. And let's press OK. We need to give short ID, might be PF01. So some abbreviation of the name. Let's press OK. And you should see the name of the plan and the short ID here. Ready?
Yeah. See.
Okay. Now we may choose the geometry file. Of course, we have one geometry. So we have also one set of the data for unsteady flow. So let's stay with this. And we should choose the programs to run. By default, we have the geometry preprocessor. geometry should be processed before the simulation. Then we have the unsteady flow simulation, the main computations of the flat propagation. If we have some sediment data might be also sediment transport might be also simulated. We don't have one, so we stay with unchecked this box. And finally, we have post-processing, what means the processing of the result just to be used later as a valid result for visualization, for just transition exporting to another programs. Yeah. So these three generally are the something what we really need to have. What we really need to have checked, and we really need to make. So if we are ready, we may go further. Okay.
Yeah.
Now we have a frame for simulation time. We need to define the beginning of the simulation and the end of the simulation. Yeah. So this is what we have. First of all, if we let's talk about starting date. If we go over this cell, you should see the tip with the format of the date which should be used. And this is why we need the English United States format in our operating system, because this window accepts your national format, but the computational engine not. So these two formats should be the same. Yeah. So it should be English United States. So just to avoid the conflict in the date. Yeah. So we may write the date manually. Yeah, it is possible just following this format. But at the new versions of HECRAS, we have also a calendar here in this icon. Yeah? Let's press it, and you see calendar, and you may choose the date you want just for start. You may just navigate over the years. You may navigate over the months, as you see. You may navigate over the days, but you may also use this red circle. Yeah, this red circle to go to today. So if you click on the red circle, we have the date today. Okay. Let's select the date today and press OK. So the date is just transferred to our cell. Ready? Now let's go to the starting time. And if we go over this cell, we will see once again the tip, how the time should be put here. You see that we have 4 digits without any colons, dots, double dots, and this kind of designs. So only 4 digits. First 2 represent the hour, next 2 represent the minutes. Yeah. So this is what we put. And I always like to put here the hour when the gauge stations are read according to the requirements or recommendations of the World Meteorological Organization, which is 6 a.m. at Greenwich. But in Poland is, for example, 7 a.m. because we have UTM plus 1. Yeah. So what Indonesia is UTM plus 8, 7,
14 UTM
14.
14.
So
48, 49, 40. Yeah. And our location is 49 South S.
Okay. So it should be 2000. It should be generally, it means the 8 p.m. Yeah. Because we should use the format of the 24 hours. So it should be 20. Okay. So let's write it. At the moment, because ending date should fit the length of our hydrograph. The hydrograph should not be shorter. Yeah, maybe longer, but should not be shorter than simulation time window. So for a moment, let's save this, and let's just open once again unsteady flow data. Okay. If we open unsteady flow data, we may open any of the flow hydrographs by double clicking, and we should see that our dates are changed. Okay. You have now the dates, they start exactly with the starting date because we have the option use simulation time here. Yeah. So let's check the date at the end of our hydrograph. You see? Okay,
yeah.
and let's use this date as the end of our ending date. Okay, let's use it. This is 11th May, so I will just pick 11th May from the calendar, and this is 23 hours, so I just write here 2300. So now the simulation time just fits exactly the hydrograph. Okay.
Okay.
Do you understand why we did it? Okay.
Yeah.
So
Yeah.
let's close
Thank
it
you.
by canceling and closing here. We come back to the computational plan. Let's remember to save plan. Ready?
Yeah.
Okay.
Ready.
And one very important point, the last step, we should just set the computational time interval. The most important is this one, computation interval. This is the interval of our computations, how the numerical method works. So this interval just is responsible for the stability of the computations also. Yeah. So if we have some problems, the unsteady flow computations might be unstable. We should just handle this value. This is one of the options, just to stabilize the computations with this value. There are also other options, but at the moment we just focus on this one. By default, this is 1 minute. This is 1 minute, but it means also very long computations because we have several days to compute with 1 minute time step. It will take long time. So maybe we should start with the 5 minutes, a little bit longer. If everything is okay, we will stay with this. If not, we shorten this time. Okay. So I suggest to change to 5 minutes. The rest is not so important because these are the intervals of the result savings, how the results are saved in the disk. Because the number of the results produced in each time step of the computations might be large, so not all results are saved, only selected. And this time steps just define how we select the result to save in the disk. Yeah. So if you need more detailed results, this interval should be the same as computational interval, but not shorter. Shorter it does not matter because we don't have the shorter the smaller times in the computations. And generally, this interval should be a multiplication of the computational interval. Yeah. So it's really important to remember this. But we stay with 1 hour at the moment. We have 100 hours of simulation, so 1 hour is enough. Okay. So 5 minutes here, and the 1 hour stay as the default option. And let's save the plan. And now we should be ready to press compute, unless you have some questions. Any questions?
Ada pertanyaan nggak?
Okay. If
Ini
not,
misalnya gitu.
let's press compute, and you should see something like this. So if all the bells are blue, it's okay. Yeah, it's okay. It means that we should expect good results, especially if they are relatively fast. So everything is correct. If not, we may see also red color, and red color means that the computations are unstable, and we need to change the computational settings just to correct just to preserve the stability. Yeah. Okay. Okay.
Okay.
Everybody.
Yeah.
Okay. Let's
Yeah.
press close. Let's press close, and let's close the computational plan. Let's see the results. First of all, let's look at view. Okay, let's look at view. Let's go to the water surface profile. Water surface profile. And you should see something like this. We may just maximize this. First of all, only the rich odcinek 1 is presented. Just to change it, let's use this button, riches, and let's have a look at the entire Warta River. Let's select odcinek 2 also. Yeah. We may also change it. We may just select Wełna instead of odcinek 1 as another just path to see the profile. But of course, it's not very useful if you check all of them, because Wełna and the beginning of the Warta are displayed in the same location. Yeah. So this is not good. So just select to see one longer profile. Maybe Warta River is okay. Yeah. Okay, you should also see that we have the left over bank, right over bank presented here. Yeah. Do you have them or not?
Yeah.
Yeah, it should be displayed because we said it last time. Yeah, you see that they are varying. They are specifically different in the places where we have the bridges. Okay, and now if you click profiles, you see a long list of the profiles, and these are all profiles saved from the unsteady flow simulation. The first profile which is displayed is not the beginning of the simulation, it's the maximum water surface, maximum over entire simulation. Yeah? If you would like to see the animation, we need to use this button which just is a button of play. Let's click on this, and now the profile is set to the beginning of the simulation. So you see the rapid decrease of the profile, because now this is not the maximum water surface, but this is the beginning. The beginning, and I put the 150 cubic meters per second. I expected that this is in the channel, so you see that this is really below the banks. Yeah. Okay, now let's just press play here. Yeah, and let's have a look. Yeah, it's really fast. The flood just comes. If you would like to see it a little bit slower, you need to just press these 3 dots, and you have the option to handle the speed. Yeah, to speed. So if this is, yeah, maybe I will shift it on the right, and now the simulation is really slow. So maybe I make it faster. Now this is a little bit faster. Yeah, you see increase, the flood is coming, spreading over the ridge, and now going down. Everything is coming back to the previous conditions. Okay, is it clear?
Ya, bisa ya? Ada pertanyaan?
Okay, now let's have a look, that we just.
Planning is very good explanation,
Okay.
yeah, very clear and very easy to recognize, to follow you. Yeah.
Okay, let's come back to the first step. Let's display, this may stay, let's display in the view cross section. Yeah, cross section. We may choose not only one, we may choose several cross sections, but maybe at the beginning we display the inlet of the Warta River of the odcinek 1. And maybe we display also one more cross section. This will be the Wełna odcinek 7, and also the inlet cross section. Yeah. So you see that we have a little bit complex situation. Maybe this model should be configured a little bit different way. The play may be used as previously. We may just press, and we see the picture in all the elements. Yeah, how the flood is coming in the cross sections, increases and over the profile. Okay.
Ada 2 potongan melintang
Okay.
sama naik bawah.
One more presentation. Let's just look. Okay, stop. Okay, one more presentation. We have one option which was not presented before. Here in the view, let's have a look in the stage and flow hydrographs. Stage and flow hydrographs. Okay. These are our hydrographs, and we may display by default the inlet and outlet cross sections of each ridge. Yeah, of each ridge. So you see that we have several options here. So let's have a look in one, in maybe in the junction. Yeah, let's have a look in the junction in the beginning of the odcinek number 2. Yeah. So this what is coming to the second ridge in the Warta River, and we may just use play once again. Okay, one more time. And you should see this red line which show us where we are. Yeah, in the hydrograph. Okay. Okay. If you would like to see more hydrographs, because these are only selected hydrographs, before we start simulation, we should change the locations for the hydrographs here in this option stage and flow output locations. If you define more cross sections there, you have more hydrographs. Okay, so this is also something we should remember, that we may handle this kind of options. Okay, any questions to this kind of display?
Pertanyaan?
Okay. No? Okay, now let's have a look at something even more interesting. Let's go to the GIS tools RAS Mapper. Okay, let's open RAS Mapper here. Okay, we have our map. Let's uncheck geometry and let's look at the results. We have the plan PF01, and what we have by default is the depth maximum depth. So we may see how is the inundation zone. In some places we have some inundation over, just outside of the channel. In other places the inundation is not huge. In the Wronki, for example, we have some small inundation over the channel. Yeah? Okay, but of course this is the maximum depth. We may also see the animation here and how we should do it. Let's uncheck the depth max. Okay, let's select name of the computational plan and let's click right button. You should remember this option, create new results map layer. Okay, new results map layer. This is the window you remember from the previous exercise. We may choose depth as previously, and you see the options we have. We may display maximum depth, minimum depth, but we may use also this option profile, and we have several profiles. Several profiles. At the moment, I don't want to use any of them. I simply let to be chosen the first. Okay, the beginning. And let's press add map. Let's press add map. If the map is added, we should see something like this. This is the beginning of the simulation, the water in the channel. Yeah? And now we can select this profile here, and you should see that this belt, the play, is active. It's active. You may also use this button play to animate the propagation of the flood. So okay, if this is too fast, we may use this turtle. Turtle, we have the choice between rabbit and turtle. So of course it might be a little bit slower. And now we can press play and we see this picture, this short movie a little bit slower. The flood wave is coming to this location because this is the end of the reach, and now it's just going down to another from our reach. Okay, so this is what we have. Of course our flood is not huge, so you may just make a test with the higher peak flows, so the effect will be greater. And you may also look at the different locations here. So maybe we'll just look here, start from the beginning, and this is what we have in this city. Okay, inundated zone, and just flow is the flood is going down. Yeah, situation is coming back to the previous conditions. Okay, everything clear?
Yeah, that's
okay.
Soalnya banjir Indonesia nggak surut-surut.
Okay, that's good. I am happy with this. Do you have any questions? Would you like to see something more?
Yeah, Thomas, for me, maybe the critical point, how we get the information about when we determine the value of the discharge of the flow.
Discharge. Of course, this is really important question, but a little bit beyond the preparation of the model, because we should supply the model with some results of the hydrological analysis. So we need to analyze the data. We have generally two options because we are talking about this, what we put here, what we put here and what should be ready before. One option is such that these hydrographs are basically picked from our hydrographs, effects of measurements and transition with the rating curve. Yeah, so this should be the real hydrological data from the gauge stations. So we may put here. Yeah. Sometimes, in other cases, we may also build a so-called artificial, potential, or synthetic hydrographs. Some hydrographs like this one, but maybe a little bit more complex because this is really simple. So I use it only for test. The real synthetic hydrographs have generally a little bit more sophisticated shape, and the peak of flow is one of the maximum flows. For example, 100-year flat or something like this. Yeah, and the whole entire hydrograph is just adjusted to this value. Yeah, so these are the options really utilized in this case. But generally such hydrographs needs to be prepared before we prepare the model. Yeah. Okay. More questions?
Pertemuan berikutnya 3 minggu lagi. Kita harus ngerjakan sendiri, tadi nggak bilang. Kita coba latihan sendiri. Terus yang lain? Bisa, sama ini persis sederhana bisa. Nanti saya jelaskan, nanti kita bahas. Nggak masalah. Oke, nanti saya jelaskan ya. Yang lain? Ada sama. Oke, kalau pasang surut nggak masalah. Nanti saya jelaskan. Ada yang lain? Ada yang lain? Ansel, Okta. Ya udah. Enggak, yang ini berarti udah cukup. Nggak ada. Oke, tepuk tangan aja ya, free applause ya. Oke, I think as far we make a quick discussion, we are very happy. Today, PULS is very important for us about unsteady flow. And student, make applause to Prof. Thomas. Thank you very much for this paper.
Thank you very much. Thank you. Okay, I will stop sharing the screen now. Okay. Okay, stop sharing. Okay, thank you very much. Okay, so only one exercise was done, but relatively large. I didn't know that it takes so much time. So maybe next time we start with the two-dimensional flow, because the use of the precipitation is only possible in two-dimensional. Yeah, it is possible with one-dimensional model, but it's not so effective. It's better to have two-dimensional model and just see how it works, how precipitation works on two-dimensional model. So we start next time with the two-dimensional modeling of one bridge, and later I prepare more data from the city I'm living, and we try to simulate another model with the rain. Okay, so this is the plan for the next steps. Okay, if you have other suggestions, you may just tell me or send some information by email. So it will be also okay. Yeah.
Okay, thank you very much, Thomas. Yeah.
Okay.
And then let's conclude. We are very happy for this course. Really very good, and give us a lot of information to make our real project. Maybe in the next 3 weeks, we also will give you or deliver you some presentation as far we did the relocation, our project.
Okay.
And we need your suggestion, idea, or maybe to check something wrong or not. We are believe that we will combine the model from the Delft 3D. We try combine with the HECRAS and show you how it works based our that's good idea for our future. This our 3 location. I think something like that.
Okay.
Anyone have another question? Yeah, it's enough. Thank you very much, Thomas. Yeah, I will be contact with Giovanna too, maybe for the possibility for the next meeting, Thursday or Friday, yeah?
Yes.
At the morning,
yes.
Yeah, okay.
Yeah, okay.
Thank you very much, Thomas. Bye-bye. Have a nice day.
Thank you.
Yeah.
Thank you very much. Bye. Bye. Thank you.